almost. And we are live. Ladies and gentlemen, we are witnessing a rather historic moment. This is Figure.03, and there's a little backstory to what we're seeing here. But first of all, what is this? This is the first live, fully autonomous humanoid robot 8-hour work shift. Figure Robotics picked up the gauntlet that Scott Walter threw on X. We know whom to blame for all of this. The man pulling the puppet strings behind the scenes, Scott Walter, threw down the gauntlet. Yesterday, was it, Scott?
Yes.
Yeah. And Brett Adcock took up the challenge. So why don't you run us through what we're seeing and how this all came about? And thank you to Phil Truby and Dr. Gustav Anderson for joining us. So wherever you're joining us in this live stream, whether it is X or LinkedIn or YouTube or even Facebook, welcome everybody around the world. What you are witnessing is history in the making, and we're 2 minutes and 40 seconds into this. Scott, take us through what's happening, please.
Okay, so first, thank you, Phil, for filling in for normally Spock, because we're rock, paper, scissors, Spock today. And that, Phil knows a lot about AI backgrounds and how some of these autonomous systems will work. So he will be very useful in being able to help explain a little bit of what we're saying. But the main thing is that we've talked about robotics for several years now and what humanoids can do. And you've seen a lot of impressive demos. But usually what everyone says is that, yes, there are always these selective edits. They may have had multiple takes and everything else. And about this time a year ago, we already saw this video. We saw like an hour-long video coming from Figure, which was like to demonstrate that they could do something like this for an hour. The thing is, it was not live. And so everyone kind of accused, like, yeah, they probably filmed it for like 4 hours straight and picked like the 1 hour that was good or something like that. So this is one of those to sort of debunk the whole idea that if you really believe in the system, you would show it live and not as a pre-taped video. And the other is that, 8 hours is like, that's the minimum what these bots really have to do to be useful on the factory floor. Now, we could talk about what we mean by usability or useful work, because that term comes up a lot. And it's going to be different things for different people. There's no doubt about it. But, the minimum threshold is that it's able to do currently some task that's done by a human and be able to do it at the same kind of performance level as a human, which in the end, it should be just as fast, but it's not just as fast. Also, there's always going to be mistakes and glitches that kind of happen in there, but not to do more than typically you would have with a human, so that your overall throughput is on the same level. And at the same time, it would be really nice if the cost of the bot that's doing it is at or below whatever the loaded cost is for a person doing the same thing. And so when we talk about a loaded cost, that's what it really costs the employer. It's not what the wage that they're paying, but it's the taxes, the benefits on top, it's the HR overheads, like a lot of these other things. It's a very difficult calculation to make because the robots are also going to have wranglers. So they may be not necessarily replacing jobs, but changing jobs. People who are currently doing it may be overseeing them and stuff like that. So in the end of the day, you have to kind of figure out is like, when I bring this thing in, is there really a return on investment? Am I saving money? And there's so many different ways of saying what that saving money is. So here's a task. Now, we would love to see robots be able to do multiple tasks, because a lot of times in a lot of commercial settings, you're not doing one thing for 8 hours long. However, there are a lot of situations where you probably are doing the same thing for 8 hours. And that's where the robots are going to be coming in there first. And eventually they will show their utility when the fact that they can bounce around from one place to another. Because a lot of cases, that's why we don't have automation, is that it's so hard to automate all those different tasks. And we've talked about this already on Over the Horizon, that, what would it take to like automate a McDonald's? And when you start thinking about it, there's so many different tasks, there's so many different types of automation you have to throw in there. It would be really, really hard to automate the whole thing. You can automate like one thing, maybe very easily. But if that thing isn't going all the time, then your cost of automation becomes very high. So what we're seeing here is a task, which is reasonably complex. You can see it's very chaotic. It's constantly changing. And in many ways, it seems very simple. And I've seen people in the comments say, it looks so simple, you could automate it, some other ways. And it's just always like, well, if it's so easy, do it. And I trust you. If it could have been automated by now, it would have been. It would have been done 20 years ago if it was really, really easy. And the thing is, you get flexible parts, this chaotic scene. And the task is fairly simple. It's just that it actually has to take the label and make sure it's down, because downstream there's a scanner that's going to scan that thing. And the whole production system has been set up this way. Okay. That's exactly how it is. It's not that they're contriving it. It's like, this is exactly what it's like out in the field. And we just need to see how we can go ahead and do this.
So if there wasn't a label, because quite often it just pushes the package forward, like this time it didn't even check that there was a label, would these kind of conveyor systems kind of drop it out if there is no label? Or
I think the assumption is that they're coming in from somewhere with the label, and I think we just dropped one off the side. I think I may have seen one. So it's 716. Mark that down. I think a red parcel fell off, and that'll typically happen also. That person will be overzealous and something like that. We'll just go ahead and go down. I guess the assumption is that if it's already down, you would sort of, through deductive logic, assume if they do have labels, it must be. And I don't know if there needs to be that quality control check. Now, what will happen is, like downstream, if the labels are facing the wrong way, then the scanner is going to error out and something's going to happen. And it's going to like push it off in a reject. I don't know what to do it. And then someone else will have to go over and sort that. And that's typical. I mean, you're hoping you would love to get 100% throughput here without any mistakes, but no one ever gets 100%. So there's always something downstream to account for something going wrong.
So are we sure this is live? I mean, there's a live symbol up in the corner, but
yeah, there's a live symbol. I think at some point, and I'm glad you bring it up, I think at some point, someone from Figure may show up on screen, and we may be able to talk to them. And we may ask them to give us like the most recent stock quote of some company out there. And if it doesn't match, then we know it's not live, right?
Yes, that's a good idea.
Yeah. So what I'm trying to come up with a proof of live streamness. Like they do with those. I mean, the other thing is they could just hold up like a newspaper with today's headline on it or something like that. But
so we've gone from
it was like 2 hours ago.
So we've gone from live stream or it didn't happen to live stock price or it's not live.
I think I'm trying to think that's probably the closest way. Maybe
I
say
think it's a great idea.
What's the poly market for something right now at this moment, and then
I think
Phil, I think you're muted.
Why don't we plug RoboStrategy right now? So this is you want to tell us about RoboStrategy,
okay,
Scott? I think this is a great,
so the first
great
thing
opportunity.
is we need to make sure there's full disclosure that I and I think Phil also, we are Figure investors, and the company I work for, RoboStrategy, is also an investor in Figure, along with many other companies in the physical intelligence space. Apptronics is another one. Dyna is another one. And we recently listed on the New York Stock Exchange. And with that, I think I have something else that I need to say here, just to make sure now that we've got the sort of the full disclosure here.
While you're doing that, can you guys hear me now?
Yes.
Yeah.
Yes.
Okay. Loud and clear.
So this is something. Yeah, I just want to make sure I say, the views expressed on this live stream are my own and are for informational purposes, entertainment too, and only not intended as financial advice. Okay. So, remember
we've gotten that out of the way.
So,
including loss of principal, please consult with a professional before making any investment decisions. Those are wise words. Advice. Okay. So, so again, this is information only, and you'll learn about more about RoboStrategy in the coming days.
So the other thing I'd like to say about this demo, I mean, the big thing, obviously this is live, that's nice, but it's also human speed. So that's a new innovation. We haven't seen Figure operating at human speed before. So that's a nice innovation. Although we kind of did see human speed when they were cleaning up the bedroom a couple of days ago in that demo. The other thing I'd like to say about this is not a customer facility. This is inside Figure's facilities, right? So they have like a jury-rigged, not jury-rigged, but they have a system that mimics what a production environment would look like. And I've got to say that is truly the thing that is missing in humanoid robotics, is let's actually see videos of humanoid robotics deployed in production at customer sites. I mean, it's ironic that you have those videos from some of the really lesser, like really low capitalized companies that aren't humanoid robotics, but they are AI robotics that have customer locations and they're making money from customers. And yet the humanoid robotic companies like Tesla and Figure are the two biggest ones. We still haven't seen any actual production use other than proof of concept, that kind of stuff. So that's the next thing.
Yeah, I agree. And usually it comes down to that the customer, the client doesn't want that. So at this point.
No, do not use that excuse. I do not believe that excuse. You can find a customer that will give you the ability to actually show that. You don't even have to disclose who the customer is.
Not all.
I know, not all, but one. Surely you can find one.
Yeah. And I was amazed they were able to show anything in BMW, because having worked in the automotive space for years, it's like impossible to get permission from anything.
But that BMW, but that BMW thing wasn't a real production situation, right? I mean, everybody says BMW, but those parts that the robot was lifting off the carrier, they were one of that part had been put on that carrier by a human, and then the robot was lifting it off that carrier and then putting it into the fixture.
Yeah.
So I mean,
it was a proof of concept at that point. Yes.
Yeah. There was no. It was a proof of concept, but there was no production intent there. It wasn't really working in a production environment as a production piece of production equipment.
So where would you put the level, Phil? Like to what extent does it need to be in production? Is it enough to kind of have just moving a box, or do you want it to go through the whole?
No, I want this demo is fine. This demo is fine, but I want to see it in the actual UPS or wherever, what they haven't disclosed the customer as far as I know, but I actually want to see this running in, the post office or UPS or wherever they're, and they do have a logistics customer. I like to see it running actually on a line in their facility.
Right.
Would be an example. So, I mean,
doing a live stream might be tricky at a customer facility. Getting a video out of a customer facility is one thing, because they have to go through all kinds of review. So in many cases, there's like 2 weeks or 3 weeks or something like that, where they go through to make sure everything that's contained in there is okay. Getting a live stream would be a little bit trickier.
I understand, but we haven't even seen a video of an actual production use where a customer says, yeah, we've got this running in production. I mean, as I say, I'm an investor in other companies, and another one, small little company, I think they've raised, I don't know, I want to say $10 million at most or something like that. They have AI robots in customer facilities running production today. It's running as a robot as a service. So I'm just saying that the actual humanoid space is not there yet. It will be.
Right.
Now, what do you think is stopping these guys from doing it now? Is it, I mean, this is still a demo, but what extra steps do they need?
I don't know. This looks pretty good to me. I don't know what's stopping them.
Well, if you look at this compared to what we saw last week with changing the bed, which do you think is closer to deployment?
This. I don't see why you couldn't deploy this in production.
I mean, this is a far simpler problem to solve, right?
Again, the idea is it's a single task, and all you're doing is you're focusing on a single task that you just have to do it right. And it's one of those, it's like, we have to do it for 8 hours straight.
Yeah.
So it is something you could imagine being very long. It's not broken up into a lot. It's just like, it's like Sisyphus here, just constantly rolling that stone up the hill and doing it again and again and again.
And remember, we've seen this before, right? Figure and Brett have released a full work shift video, unedited in toto, but that was pre-recorded. This is live. So
this is live, and it may indicate that Phil's wish maybe is closer than we think.
it will be a milestone when we
Yes.
see a humanoid robot doing it, for sure.
Yeah. So,
but the other thing that's impressive about this, presumably this will go on for 8 hours. If it goes on for 8 hours, I mean, it shows you, and Scott would talk to this. It shows you the level of hardware reliability that they've gotten to, and this is Figure.03. They say that they've actually done design. I think pencils down essentially on Figure.04. It'll still take many months to actually build that thing. But it shows you that Figure is running well anyway.
Yeah. Okay, so for just to set the lay of the land for those who are joining us from LinkedIn, X, YouTube, Facebook, this is, I mean, we've seen demos like this before. Correct me if I'm wrong, Scott, but Agility has done something similarly, but this is a full humanoid form factor live stream that's been done, demo that's been done for the first time by Figure. Is there anyone else? We've got a few humans walking past in the background. Any other company that's done this before?
Yeah, so everyone knows Agility, it might be like 3 years now, was sort of the first one to do a live stream from a trade show. So I think it was like FabTech, where they were showing the totes moving around. They have Digit there. And since it was like a live performance in front of everyone in a hall, they just decided to live stream it, and you were able to see that. So I would say, so the difference here is the human level speed. So while Digit was able to move those things around, it wasn't able to move the totes quite at the same speed that you expect a human worker to do. So this is getting close to that. And the other is that this is going to be an 8-hour challenge. I think Agility might have been around 6 hours, whatever the length of the trade fair was. It was like from 10 to 4 or something like that. Now, the expectation is, I don't think the same bot is going to be doing this for 8 hours straight. There's probably going to be a swap over because of the battery.
Well,
so I'm not sure if they're doing charging on there, but what it may happen is after a couple of hours when it gets low, they may get a swap out. So
or Figure has this cool base recharge, right? Wireless recharging through its feet. So it's possible.
It's possible. It's possible. See, this is what we don't know.
Yeah.
This is where I'm speculating. I'm assuming that they're doing the swap out. And the main reason is I believe Brett had mentioned something on the Sorcery podcast with Molly O'Shea about the fact that they've been running these, I think, like 72 hours straight. They did a lot of tests like that. The 72 hours was basically doing the same task, but swapping one bot for another when it was time for a recharge. And
so the 3 charging stations in the back are very suitably
placed. Yeah. So it's possible that one of those will kind of walk over some point and tap that one on the shoulder and they'll move. Now, I don't know if they use tap on the shoulder because we know they're using head nods to communicate. And so there may be something like that. We also know there's this Vulcan system that they have, what they call it. It's kind of like the fleet management that knows where they all are at all times and what the status is. And if one of them has either got a low state of charge, it will then know to deploy another one over to replace it. Or if one of them suddenly has an actuator fail, it will then do this thing where it locks itself up so it can actually, not fall over, but those actuators will lock up and it will limp away. And then it will limp to the bot spital. And then another one will come in and replace it. So hopefully that's not going to be a reason for a swap out. The reason for the swap out will be to do the charge. Now, there's many schemes, as Phil mentioned. There's ones you could just plug it in, and we've seen the plug-in before. So, Optimus does that at the diner. The popcorn bot there is actually plugged in to make sure it has a full state of charge. That's always one way of doing it. But the thing about cables and being plugged in is that they're always kind of get in the way. We like to have the battery so we don't have to do that. So the other way to do charge is wireless charging, and this can do wireless charging through the feet. So I don't know if it's on stand or not.
I was about to ask you that.
It's inductive charging, just like your phone, and that potentially could be used to keep it going for 8 hours straight. So that means we're going to have to sit here and wait 8 hours and find out ourselves exactly what the state of charge is. And the other way of doing it is, of course, battery swap. So there's a lot of robots that are designed to have these battery packs that you can swap in and out. And that's another way to quickly do it. But usually it means it still has to go over to some place, do a quick swap out. Either something has to do it for itself, or it does it, and that still takes a little bit of time away. And then there's pros and cons to that concept. One of them is there's all this. We're trying to shave every single gram out of these things because mass costs a lot. And we're also trying to pack as many batteries in there as possible. When you have a swappable battery pack, that means your container and everything is a little bit different, and it's going to have a little bit more mass, and you have to worry about a connector and all those things that are working. Figure and Optimus are using structural battery packs. So the whole idea is that rather than having something that has to hold the battery pack in there, it's like that is the thing that's holding it all together, and you can reduce it. The downside is it's not swappable. It's replaceable, of course. Someone can go in and open it up and take it out, but it's not swappable. So the argument is that if you can get these things down low enough in cost, the bot is the swappable battery pack. When it's time to swap out the battery, just swap out the bot. And so this is a strategy that they're going to be using.
Yeah, so it makes a lot more sense.
I mean, I wish we had a second camera angle to kind of see what's happening on the other side. Where
just going around in a circle, the same packages were coming back. So I counted, so at 20 minutes, it was exactly 450 packages. So I kind of asked Grok what is considered human speed, and it's considered to be around, depending on the type of package handling, but it says that UPS conveyor handling is 20 to 25, which is actually what this bot is doing. It kind of felt that it was a little bit slower than I would be able to do it, but if I'm going to do it for 8 hours straight, I mean, I'm already fed up looking at this after 20 minutes. I'm not going to be doing this for an entire day.
Yeah. So Gustav, have you done the calculation yet on exactly what the packages per second or per minute are?
So it's 22.5 per minute. If it was 450 at 20 minutes. So
at 20.
2.5
okay.
per minute.
So that's right where it needs to be. Yeah. Now that's the thing, is that you can always have these bursts of human speed. Mm-hmm. And when you go into a lot of factories, you will see some workers that are very eager and working very fast. And they're actually told a lot of times by their management to slow down. And you think, oh, that's some union thing. They don't want these guys. And it's like, no. These are 8-hour shifts. Okay. And that 8-hour shift you're doing tomorrow and the day after that. This is a marathon. It's not a sprint. You can come in and you can do these things and you can be really high performing, but you cannot continue to be high performing forever. So you really have to find out what it is that you can do. And the other thing that has been pointed out when I point out the 8-hour shift, it's rather interesting looking at comments.
Was that a bit of a stutter there? Did you catch that about 10 seconds back?
Yeah. So occasionally there may be some little hiccup like that, and it's a question of how it recovers. It's trying to figure out, okay, how do we move this in?
I think it got a bit shocked because there wasn't a single package on the tray there. So it's like, whoa, what's happening?
Yeah.
So Brett just posted on X describing what's going on. He says the use case is small package sorting. Figure.03 must detect the barcode, pick up the package, and reorient it barcode face down onto the conveyor. The robots have to reason purely from camera pixels. So that's a bit of context for those of you watching around.
Oh, okay. It lost one there. So there's one area you see was like overzealous. Part of that was like the pile coming in, kind of get it off a little bit. But again, these are going to be the things that you're probably also going to see an occasional error like that from a human. And the main thing is to make sure that your failure, what they call the OEE, is within the same kind of numbers or metrics that you would have with a human.
Yeah. Okay, so 25 minutes, 20 seconds. We've got 574 packages sorted yet. I mean, already, as Gustav said, I'm bored to death just watching it. Imagine how repetitive this task is.
I'm getting some posts from people saying that they're mesmerized.
They're mesmerized? Okay, this is like
if you have a really
ASMR
nice
for the eyes.
on your headphones, like listening to Over the Horizon or something. I mean,
so the other thing that should be said is, I mean, fundamentally, you don't need a humanoid for this, right? I mean, this could be done with a 2-armed, even gripper hand robot in theory.
That's right.
So people are always confused, why a humanoid, right? And the real answer is economics. This one form factor can do, in theory, anything a human can do. It's why we only have one iPhone or a small number of iPhone models. It's because when you're making millions or billions of this of a thing, you want it to be only one thing to get the cost down as low as possible. when you get the cost down as low as possible, then you can use it in more activities, and it's a self-reinforcing thing. But that brings up a very important point, and this has been the bane of robotics throughout its existence, is training the bot to do whatever you want it to do. Historically, industrial robots takes a software engineer and a lot of laborious training and figuring out what all the edge cases are and the like. Whereas the promise of AI robotics is that you just tell it to start doing something and you describe it. Maybe you show it a 5-minute demonstration and then the bot just starts doing it. It's a huge change in the way you would interact and deal with robots. And that's the part that we haven't seen anybody really talking about. There was an interesting podcast by Jim Fan from Sequoia, right? It was a Sequoia podcast. Jim Fan was the NVIDIA guy talking about training robotics. It's only a 20-minute long presentation. It was an awesome presentation talking about what the state of the art is, what the state of the art must be to get to that point where you have the nirvana of just being able to tell a robot, do this new thing that we've never trained you on before, no teleop, none of this kind of stuff. I'm just describing what the task is and have the robot do it. And that's another thing that I would like to see, the humanoid robot makers describe, talk about, demonstrate, because they're the ones with the big money, right? They're the ones with the billion-dollar budgets, and they're the ones who are working on this and can show us how they train and how they can do essentially one-shot task setup.
Yeah. I mean, it's the picking of these plastic bags are a bit not really impressive when you take it. If it would just be a gripper, we would do the same thing. But look at when it flips the box. I mean, these might all be empty boxes, I'm not sure, but it's doing this like flipping of the box in its fingers. I mean, that's quite tricky. If there's like a weight in there, I can't even do it without losing it. So maybe it doesn't do it now, but it kind of flips it between its fingers. And I thought,
that's a great point. I mean, I don't know. It's very difficult because this is a bot, so the biomechanics are different from that of a human. So, Scott, any insight on what's inside these packets that we're seeing?
Oh, they're filled. They've got some masks just so to make sure that they're realistic as far as moving around. The one thing with classical robots, it's always tricky to flip a package upside down. So you got to get all your degrees of freedom. So you have some robots that can only move around like this, and then they have this rotation here. These are known as Scaro robots. And you can use that to pick up a package and move it over there. And you can rotate the package, but only in the plane. You can't flip it. And even like with a one-axis gripper, you might be able to kind of grab it and bring it around, but it's really kind of awkward because you got to get your wrist around, and they're very, very hard. So it's, in many ways, it's easier to do those kind of movements. And I've seen proposals where people wanted something to be flipped with a Scaro robot, and they didn't know that it couldn't do that until we ran the simulation and showed it to them. And then they go, oh, and then they have to rethink their strategy and something to do with that. So that's like one of the advantages is the flexibility. You don't have to worry about the type of gripper you have, how it's going to deal with something like that. Yeah, again, flipping that. And again, to Phil's point is that, we could make the argument that this could just be a torso only kind of robot. There's no reason to have the legs. Part of the reason for the legs here is that you can sometimes extend your reach a bit, but you can still make the argument, I can find a solution for that's going to work. The thing is, there may be other tasks that you're doing in your factory. So, right now we're saying that this is like, it's doing this 8 hours straight. Maybe it only does this for 3 hours, but then there's something else that has to be done somewhere else, and something else is somewhere else. And now you can start deploying it around. So right now, the return on investment, or like the argument for this for a single task, is pretty hard. It's like, if there's that single task, you might be able to say, I can come up with a solution that's specifically for it. Assuming that solution exists in enough places that you can deploy it in enough, because if it's always a niche case, the customization is so expensive in the hardware, it's not worth it. That's why you go general purpose. So when you start going into this middle ground, and everyone wants the ideal general purpose robot, And the general purpose robot is going to be the robot that comes in your house and does everything. Until then, it's not general purpose. But before then, we can have a lot of multi-purpose that can do a lot of things that are specific tasks in there and be deployable. So that's the real thing, is the bot deployable? And can it do a variety of different tasks? And then if it can, then it's very useful for 8 hours. Because if you're running this robot for only 3 hours of the day, the return on investment becomes a lot harder to make that calculation. You would prefer that you get at least 8 hours out of this thing. If you can get 16 hours, then it's even better. But you don't build a solution that only runs for an hour. And I saw this in a lot of aerospace companies I was working with. I was surprised how many of them did not have any robots after being in automotive for 20 years and seeing, hundreds of thousands of robots these companies have, and going to aerospace companies that had just bought their first robot. And I was stunned. And like, why? It's like, it doesn't make any point. The thing is going to be done work. It starts at 8 and it's done at 8:30 in the morning. What's the point? So they have to find some way of doing deployability, because they're producing maybe, one product a day. If you're building an aircraft or you're building a helicopter or something like that, you generally don't have the high volumes like you do in automotive. So that's what makes automation very, very difficult to justify, is if it takes a lot to deploy, it's not worth it. We'll just go manually or just use traditional methods.
Okay, so we've got a question coming in from Facebook. Pratik Rathore asks, when will humanoids do all my household chores?
I know when.
Not this year.
Not this year.
And Phil, I apologize because these banners are covering your camera shot.
It's okay. It's all right.
Not this year.
Definitely not this year. Definitely not next year.
Okay.
That's going to be one of the later. That's going to be one of the later use cases, honestly, of humanoid robots. The first use cases will be exactly this. It will be factory use. And home use, it's just way too variable in environment.
And also the economics of it is not there yet. I mean,
yes,
a lot more
yes,
feasible to have it do.
Yes, that too.
Gustav, you hit the nail on the head. Oh, just like batteries, battery economics, robot economics is all about cost. Yeah. And actually everything's all about cost. But Gustav, your point about the economics and the fact that the value to a business customer is far higher than the value to a consumer. This is the problem, by the way, that the whole AI industry has run into. ChatGPT kind of accidentally fell into a consumer use case first, and they started, giving it for free and then selling it $20 a month. But in actual fact, had they started in the business use case, they could have been selling this for $1,000 a month and been making a far more money. So they kind of have to back into a more profitable use case.
Yes. Yes. Yeah. And you make very good points there. Is that there's a couple of reasons why you won't see it in the home. So I think, Phil, we know the first couple. One is it's not capable enough right now, and it's too expensive for most people. But even once we solve that, there's a third reason, and what is that?
Robot uprising.
Safety.
Yeah. They're just not safe enough. So you can make them capable and you can make them cheap, but until they're safe, they can't go in the home. So that's going to be the big difference. And the other is a very good point. It's like, ironically, there are people willing to pay a lot more money for this with less capability than people who expect full capability and don't want to pay a lot. So the consumer is expected to do everything and they want it for almost nothing. However, a business is like, if it can do exactly the job I needed to do, I will pay you $100,000 a year. Now, notice I said a year. Not that I will buy it from you for $100,000. I am willing to actually do robot as a service for $100,000 a year versus the consumer who says, I want to buy it for maybe 10 grand.
Yeah. The other thing that, by the way, that I'm impressed with Figure, I think, Scott, you mentioned their Vulcan system.
Yes.
Which is their back-end logistics or back-end infrastructure to coordinate all the bots and really give the bots the whole high-level instructions and what to do and how to coordinate with each other. This is something that any humanoid or non-humanoid AI robot maker needs to build in the back end. Everybody looks at the front end and finger manipulation and body control and all that kind of stuff. But there's a lot of work to be done on the back end, the stuff you don't see. Traditional software, frankly, of interfacing with the packaging system. So there's this one company I know that does kitting, and so it needs to know what parts to put into what package, and then once it's done, put the label on the package, and then put it into the UPS, USPS, FedEx, or whatever bin for delivery. And all that, it happens, it's a computer database system that needs to be conveyed to the robot somehow. So there's a lot of work to be done in the back end as well. And it's impressive that Figure's doing it. And on your safety, again, in that Sorcery podcast, Brett Adcock was showing off how they're working on that too, right? They're showing off how when an actuator fails, the bot can still recover and not do something stupid like fall over.
There's redundancies built in. Yeah, which is great.
But it's built in the software, right? So the software has to know how to handle those situations. And then they're teaching the bot how to fall properly, how to fall without falling on somebody. So basically crawl in, contort itself into a ball onto the floor.
And not kick
all
up.
that stuff needs to happen.
Yeah, I mean, I think there's been enough of these accidents around the different demos of bystanders getting a robo kick in the head or
but that's mostly unitary.
Well, we
traumatized children
but
unitary.
But
I mean,
before we do that,
shade on the Chinese bots, okay?
I mean, it's not Unity's fault. It's the guys running the demos, I'd say.
Yes.
Okay, so there's a comment / question from a viewer. I'm just going to pull it up. I think this is a good question. Fully autonomous 1x speed?
Yes. So it's because it's live, we can assume it's 1x speed. It's pretty hard to and it is autonomous. That's been posted. That is autonomous. It definitely is. I've seen this. This is something to be very difficult for someone with teleoperation to be able to do. I would be absolutely amazed if a teleoperator could keep up at this speed. The other thing I want to do is I'd just like to make a shout out to my friend Derek, who's watching in the live stream and is recovering from something. So I wish Derek the best luck. Get better, buddy.
Cheers to that from us. And the humanoid bot in the picture.
Yes. So now I have seen this myself, this setup a couple times now already at the figure. So I do know it exists. And as Phil points out, that's just something built up, which is pretty typical because a lot of times it's very hard to go actually to the customer site and work there because it's very costly to have your forward deploy engineers. It's a lot easier to have it where you development. So they've built a couple of setups in there. One is like this, obviously they built the BMW one when they were doing that. And of course they have bedrooms and kitchens and stuff like that, which we have seen that are set up. And currently their campus is 4 buildings, of which I think 2 are sort of fully occupied. The headquarters, where I believe this is still in the headquarters building. And then just across the parking lot is the bot queue. And bot queue is where they are doing the production. So that's the production hall. And then as we noticed, when they're completed building the bots walk across the street to a 3rd building, which is called the grid. And the grid is being populated right now with equipment. So it's more than likely setups like this would be going in there in the future when they want to be doing proof of concepts or doing training with different things. So they'll be doing more because they need more and more space for being able to do that. The big question, of course, is like how some of this training is done and how much of it was like originally teleopt to get your training sets, and how much of it could have been done through methods other than teleop, which would be like egocentric data, things like that, to be able to do it, which it is also a possibility here. And I think Figure sort of hinted that that's what they're doing based on the Brookfield announcement and a few others, that I suspect that a lot of training may have actually been egocentric. And Phil can probably explain a lot of times, like the whole training cycle, like pre-training and post-training and all this other stuff that you go through, where you kind of grab the data to get the idea of what it's doing, then maybe you put it in the sim to refine it a little bit, then you deploy it. And when you deploy it, it doesn't quite work exactly the way you want. So you need to go a little bit of post-training to touch it up. And
Yep.
sometimes it's in the touching up aspect that you might use like a little bit of teleop to give it the proper control to get it to where you want to have. So, yeah.
Yeah, exactly. And that Jim Fan presentation from Sequoia walks you through what those steps are. And it's interesting because people have been kind of complaining on X about Elon's fixation with Grok's image generation capability. And the reason why he's fixated on that isn't to generate beautiful videos, it's to generate beautiful physics, real-based videos. The better the thing that you can judge a video generation engine on is how good it mimics reality. And so if you can create a image generation system that really mimics physics properly and reality properly, then it's a great component to be able to train robots. And not only train them, but to actually use them. Because what a robot needs to do, what this robot is doing right now, it is anticipating, it is projecting what's going to happen in the next couple of seconds. It has to do that because things are moving there too fast for it to be reacting in less than being in the future. And that's what humans do too. We're constantly imagining, our brains are constantly imagining what's going to happen in the next few seconds. And thus we can position our fingers and our muscles and our entire body to be ready for that. And so a video engine that allows that is a very important part of the whole training pipeline. And as you said, Scott, teleop is kind of going by the wayside. People are not using teleop anymore, or at least they're not going to in the future. They will use it for the final fine tuning. So you will have a proper visual language model, but it's really based on vision and physics. Will be the underpinning of everything, and then you're going to have a lot of simulation in a proper physics-based simulation that actually works, and then at the very final stage, you might have like 2% of your actual training will be teleop just to fine tune it. So for instance, 1X, which infamously says, we're going to have teleop bots in your home. I'm not sure that that's the correct training pipeline, or it's not the modern training pipeline, put it that way. It might have been the modern one 6 months ago.
Yeah. Well, at the same time, they're kind of uses that same model. So many companies announced around the same time that they're going to be using what I kind of call the Doctor Strange mode, where you imagine what the different futures are and you pick the one that's the best. So 1X might have been one of the first ones to kind of show that when they released something in January, kind of talking about their idea of how they're going to be doing it. Rhoda has also talked about being able to do that. Jim Fan with the Dream Zero. So they are taking the robot and figuring out how to imagine through a video and then try to get it to match it. And so there's a lot of different white papers from different companies out there. They're all kind of moving in that exact same direction. The question is like how you do it in a manner that doesn't require a lot of pauses. Now, my understanding of what 1X is trying to do is they're hoping to get a lot of autonomy. And the idea is that they're going to have the teleoperation come in and maybe touch up or do something that maybe it can't do in your home right now. And that's like this remoting in, which is a form of teleoperation. It's more than, and there's two different types you can do teleoperation. One is like with just VR headsets and handsets moving around. The other, you can have an exoskeleton or something like that to give you maybe finer precision control. The other method that we're seeing everyone using is like you've got the egocentric, which is like, we're just going to mount a camera up there and we're going to watch what you're doing. And then hopefully that's absolutely enough. And then that means the egocentric data, the camera has to look at maybe what your hands are doing and then infer that. The other is using this kind of idea of what they call a Dex Umi interface, where you actually put on special gloves, which are almost like one-to-one what the actual robot hands or gloves are going to be like, usually like a kind of gripper. This is something that Sunday Robots has been doing that because it was pioneered by the founders of that company. And so you're taking this this little interface, and you're going around and basically grabbing everything with those things. So not with your hands, but with like little claws or little gloves that are exactly the same as what's going on there. And then it gets enough information that when they start to train it, they know what's going on, and all have to do is figure out how to get the rest of the arms to move around there. But that's just like some inverse kinematics, which sounds easier than it actually is, because there's a lot of other things they have to kind of put in the model. But these are the approaches that everyone's doing of trying to get out of the teleop phase. In the main, because teleoperation has got two problems. Remote teleoperation has got a latency problem. Simple as that. It's just like, if you've got someone that's halfway around the world, by the time they see the stuff and the movement of the robot, it's just very late. So as a result, everything is very deliberate and very slow moving around. But then you have the teleoperation where you may be actually right there. You're either like in the next room, or you might physically be right there, very, very close. And you can do it, and you get rid of a lot of the latency because you're not using the internet. You're just connecting straight in. But still, depending on how you do it, you may be trying to see what the robot's saying, so you get a headset on. And there's like latency there as well. By the time that kind of comes in and gets in there, and then a lot of times I put them on there, they give you like a fisheye. I was like, how many of you have like lived your entire life with, seeing the world through a fisheye? You haven't. So as soon as you put that on there, it's very difficult for you to get oriented. Yeah, it takes a little while, you can get it. So a lot of times the perspective doesn't match your normal perspective, and that becomes very hard. So you're not sure when you put your hands out exactly where the distance is, your proprioception, everything gets kind of thrown off as a result. So in many cases, you'll actually see everyone that has like these headsets. And a lot of the reason why they're using these meta headsets is that they have these cameras in there that will track your hand positions for you, the gestures. But it turns out the latency that you get in your eyeballs is so bad, everyone's like wearing it down against their neck. So you will see constantly these guys are over there at trade shows and everything else. They would rather see it with their own eyeballs than see it through the camera, because that means they are much better and far more adept. But they still have to deal with a little bit of latency. So the thing with teleoperation that I sort of see is that a lot of cases you're training to do a particular task. And rather than having the expert do it, you just get some guy off the street and you bring them in. And they've never done the task. You say, yeah, we want you to do this. Oh, and by the way, before you do it, we're going to liquor you up, and we're going to put on a pair of glasses that are like really out of focus, right? And all foggy. And we're going to put like these really horrible gloves on you, and maybe a big, heavy fur coat. And now go ahead and do it. So you're encumbering everyone, and you wonder why the quality of the telerobotics data is so bad. So the idea
there's also the calibration problem, isn't there, Scott?
Yeah. Oh, there's calibration. I mean, there's a litany of things we can go through there, but a lot of it is just the user interface is so horrible. It's very hard for us to feel like we've actually embodied it. No one's really allowed us to feel like, man, I'm really inside this robot, and everything feels responsive and stuff like that. Instead, it doesn't respond the way you do. You get overshoot and everything else. Your perspective's not right. Its hand gestures aren't right. In many cases, its elbow doesn't match your elbow. You're like, hey, what's going on here? And so your proprioception is off because you think you're here and it's actually over there. So there's a lot of these little things. The idea of the UMI gloves is it's much closer to your real physical experience. You are the robot now. You are actually doing the task, not the robot. All you're doing is you're having the gripper. But now you have to learn to do that. So basically, it's learning to use chopsticks for a lot of people. It's like, it's like I'm used to it, but suddenly I'm having to experience the whole world through chopsticks.
Yeah, you see that a lot with training videos where the elbows are out to the sides, so they kind of adapt how to move in order to get the bot to do what they want it to, and it's not really matching human movements. So any future like video training without teleoperation seems like it's too big of a gap if you go that route.
Okay, so Scott, I know we've got a few minutes more with you before you got to jump off, and hopefully you'll join us back soon. So for those of you watching, I want to quickly take this live stream off for a couple of minutes and give you some background, because Figure has been releasing a few very, very interesting videos in these past few weeks, and we've talked about a couple of them. The first that I want to bring up, let me just take this off the live stream. And so let's talk about Figure making the bedroom. All right. So you want to talk us through what we're seeing here, Scott? Because this is quite impressive. These are two bots coordinating with each other.
Yes.
And I mean, this is a fantastic use case. Who wouldn't love to have this?
European handle. They can't do the doorknob, can they?
Oh, interesting.
I mean, that's a good question. It's like, yeah, let's say Florida homes also don't have doorknobs for a reason. It's like, the reason we have doorknobs is it's really difficult for a 2 or 3-year-old to open the door.
No, safety.
Yeah. And once you get that little handle on there, they can grab it and then they fall through. So it's almost like a safety reason that you don't want to have it. But anyways, I mean, here we go. The same bot that was doing the packaging is now suddenly able to do this. So again, the idea is showing different kinds of flexibility. It's going to be a while before this is deployed in your home. I don't see why it couldn't be deployed in hospitality pretty soon, because one of the ways you deal with safety, it's very easy to deal with in a factory setting because we control it. We're able to, first, everyone that goes through the door in there, they are trained on what the safety protocols are in the factory. They're well aware there's dangerous equipment all over the place. There are guidelines of where they're allowed to walk and not walk. And when you get near dangerous equipment, there's safety equipment and everything else around there. You fence it off, okay? There's kind of an easy way that you could put similar safeguards in homes or other settings like this. And that is, the robot is only allowed to operate when it's in a room by itself. As soon as a human comes in, it somehow disables itself or something like that. So you can imagine in a hotel setting, you say, oh, okay, we know there's no customer, there's nothing in there. It's already kind of safe because it's literally walled off. It's able to go in there. The other beauty of a hotel is like every room is very similar, very, very similar. A lot of them are identical, and then others are basically variations on the theme. So they may have all very similar beds. They may have a different bed count, but you know the divans may all be the same color, the same chairs, the same setup on the desk. I mean, this is kind of concocted. It's like, well, you get headphones at desk. Not everyone has headphones at desk. What's going on? Well, you're running your hotel a particular way. There's certain items you expect to be there after the client has checked out. Okay, when the client comes in, we have no idea what's allowed to be on the desk and what's not allowed to be on the desk. But we kind of know what the reset state is, and we know where we want everything to be. So that if the customer that was there kind of moved things around, you know exactly where to move it back. So this is more the case. And this is the case that gives you the experience and the leverage to then go into the home eventually. Because while we have narrow diversity, let's say in a particular hotel, between many different hotels, we will see so many different use cases that we can start to generalize. And then we start putting them in Airbnbs.
Here it uses the foot. So we talk a lot about the hand being a universal tool user. So just having the gripper won't be able to use a hammer or whatever, but having a wheeled bot, it would not be able to kind of open the trash bin. So there are, aside from just walking upstairs, there are probably more cases than we think of where the foot or our legs are actually, our surroundings are designed around our anatomy, including the lower limbs, not just the hands.
Including access. Now, this particular bed has very good access, but you know, I've been in hotels recently, and one side of the bed or the other is very close to the wall, and there's a gap that's like just enough for a person to be able to kind of walk down there, slide down there to change the bed. But when you have a wheeled bot, it's very difficult. It may be much wider than whatever the foot span is of that, or the footprint that you would think of it. And you know, that's not always the case. You know, in middle America, our hotel rooms are really big. Try a hotel in downtown New York, and you'll see how tight everything is and the tolerances. It'd be very difficult for a wheeled bot to be able to operate around there. So in many cases, we've got no choice.
People who talk about wheeled bots go, oh, it's so much more efficient to move around on wheels than it is to walk. And they're right, but that's not the important part. The important part is access and be able to do things in tight environments, whereas wheels will not give you that. That's a good point, Gustav.
Yes.
Okay, and very quickly, sorry, Gustav, make your point.
No. I was just wondering if there are any other aspects of this room that we didn't think about, but please move on. We can come back to it later.
So
I thought it was fascinating. I thought it was fascinating. Okay, sorry. One quick thing.
Yeah, go for it.
That obviously humans, the robots following human video or something, because the humans are the ones that did the head nod, right?
Yes.
The humans decided, okay, how am I going to coordinate with this other human bot, you know, in actual fact? So they kind of trained the bots to do this head nod thing.
Correct.
Is what's going on there. Which
and you'll see that in the white paper. So when you go to the website, it makes clear. So Phil is not speculating. That is actually the case. They were told that go ahead and do this is for communication. The bots will learn from that.
Yeah.
I have to exit for 30 minutes and then I will be back. I have to go to my day job.
All right. Look forward to getting you back on. In the meantime, Phil, do you think that is kind of anthropomorphism that is unnecessary, the little head nod?
No, it's necessary at this stage. So in the future, you would hope that they would have radio communication with each other, right? That these bots would be communicating via radio with each other, so they wouldn't need that. They just haven't gotten to that stage yet, right? So they need some way of communicating. They probably just haven't built the robot-to-robot radio communication layer yet. But when they do, then this will go a lot faster and everything else. So for now, they do the head nod.
Although having said that, the Helix AI stack is pretty advanced and very, very impressive. But I'm just wondering whether Grok and Grok Voice has a little bit of an advantage here over the Helix AI stack from Figure. Grok for Optimus, of course.
Yeah, well, Grok is very, very impressive. Grok Voice in particular is very impressive if you use it in your car. And that's via cellular internet as well, which has latency as well, stacked on top of everything else. And it works really well. I mean, you can interrupt it. You can have a regular conversation with it. So it's they've done a lot of work there, and you know why it's not really a toy, but it can be kind of a toy in a just a regular car. But the reason they're working on it, I mean, Elon always has a reason for all these things. They might start off as toys, but they end up being production in the end, and they'll be used for autonomous robotaxis so that you can actually talk to your robotaxi and say, oh, hey, could you stop in this corner over here? Or, oh, by the way, I need to pick up my sister, or I need to pick up a package at this pharmacy, all that kind of stuff. So, and then, of course, you need it to talk to robots. This is something we haven't really seen. Figure's kind of done some demos of this, but you haven't really seen it in any meaningful sense of humans talking to the bots. But we all know that has to happen. We all know that bots and humans have to be able to effectively communicate with each other via voice.
I thought, wasn't there a Salesforce or an Agentforce demo that was shared by the CEO? I think was at the end of last year of the Figure bot talking to a human.
I might have missed that. I don't recall that.
Yeah, but there was a lot of latency though, so it wasn't. I mean, it was okay, but it wasn't much of an improvement over their original demo in the kitchen, where you had the two Figure bots unpack the shopping bags.
Right. We missed the magic trick actually. Looking at the hotel, they swap positions. So apparently at 56 minutes and 50 seconds, the bot in the back came forward and took over the place.
Oh, really? Okay. Let me just see if I can. Let me just see if I can.
56:50 or something. We will see it coming up.
Okay, we've just crossed the 1 hour mark, and this is 1,370 odd packages.
So go to 56:50 or something. Yeah. No, it just moved. Here it'll come. Let's go.
It'll come now.
Yeah, it should in a few seconds.
Yeah. So thanks for that, Gustav. So the bot swaps out, okay? Is that it?
So the one in the middle will come up and swap positions in like half a minute or something. So,
by the way, I love the uniform. Really cool. Very Star Trek-y.
Yeah. And they showed they showed it quite a long time ago, but recently they had a new video of them cycling through the different outfits. I mean, I don't expect it to all be Figure designed outfits. You could probably put any jacket on top of it, but I like the
another example of how Figure is looking to the future, because that's obviously something you're going to want to do.
Yeah,
uniforms and stuff on them.
Yeah.
Mm.
Oh, this anticipation of the bots. Oh, here we go. Swapping.
Yeah,
I think I see something moving in the background. No, not quite.
Not quite, not yet.
Oh, yeah.
Doom, 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 doom.
There we
Oh
go.
yeah, there we go. Yes. Here it comes.
Pretty cool.
Someone needs to go back through the first 1,000 packages as well and count how many mistakes it makes. I mean,
Here we
it
go.
Yeah.
mistakes, but it's not.
That was radio communication right there, right?
Yeah, it did not.
Yeah.
So somehow the two bots, or maybe there's a coordination layer on top. There's a coordination layer that the two bots are listening to, and there you go.
Yeah. There's definitely no verbal or visual signing communication of any sort.
No.
Just an exchange. Yeah.
Unless Brett is standing behind the camera, like waving.
And then
The man
that's another
behind the scenes.
And that's another example of coordination, right? Somewhere in the coordination layer, that conveyor that pushes packages onto that platform had to stop while the robots were changing
Yeah,
shifts.
that's a great point. Yeah.
Yeah, that's a simple coordination thing there.
So the bots in the back, are they the same? The one on the right, like in the far back, the blurry ones, there was like a metal, is that, or whitish one behind the one who just started charging? It's not a Easter egg of Figure 4? Probably not.
I don't think they built Figure 4 yet. So Brett said that they had designed it, so they had finished designing it, but I don't think they built it yet.
Okay, I think let's catch up with the live stream now.
Okay.
Here we go. We're at
Not quite caught up. There we go.
a little more. Yeah.
I'd like just to make a shout out to New York robotics, because a lot of these, in fact, most of the high profile robotics manufacturers, not all of them, but a lot of them are based in the Silicon Valley Bay Area, where it's really suburbia, right? So they have these big campuses and they're separated from their customers. Their customers are elsewhere physically, like maybe, in different cities and stuff. There's this one robotics manufacturer I know in New York, and they're in Brooklyn, actually. They're based by the water in these giant buildings that I think were built in the 1930s, that were used for back in the 1930s when they used to have shipping coming right up to the harbor in Brooklyn. And there were giant warehouses and packing and sorting places for dry goods and bulk goods coming in from ships. But anyway, so these giant buildings have now been converted into hundreds or thousands of individual businesses operating out of there. They've been, cut up and internally cut up into different businesses, and a lot of startups are in there, and a lot of logistics companies are based out of there. And so that's an example where your company can be like essentially in the same building as your customers, which really helps with the iteration speed and ability to service customers and deal with them. There's a mistake the robot just made. Be able to deal with them right then and there. Anyway, so dense environments like New York are also an interesting place for robotics.
So it's still keeping a steady pace of 23 packages per minute. So, but
pretty impressive, actually.
Yeah, but you'll have to go back later tonight, Royden, and watch through the first 1,000 and count how many it misses, and then get back.
I need CloudBot for that.
Yeah.
All right, so let's talk about the form factor. Gustav, you're the hand surgeon. We have relied on you for your expert insight and analysis of the functionality of the robotic hand, the humanoid robot hand. What we're seeing here is, I think it's the latest. It has cameras in the palm.
Yes, at least it's the latest that they've shown. I mean, they have this demo of the one with the ab and adduction that we haven't really seen, aside from like a blurred video clip. So we know that they're developing the next gen hand, or maybe it's already finalized, where they would introduce the splaying of the fingers, whereas this bot is only a flexion and extension, and the thumb cannot pose, I guess. So it's not their final design, and there probably won't be a final design. We'll keep iterating on it. But we often talk about this the minimal viable product. And I mean, for this application, the basic gripper would get you a long way, but the flipping of the package and then cleaning up the hotel room, then this hand is a lot more dexterous, I'd say. It's not the final design that I'm looking forward to, but I mean, it's really effective at doing this. It's keeping up with human speed, at least according to Grok, when I asked it about the number of packages per minute. So why really stress too much about making it more advanced? If you get 1,000 of these bots out in the different factories, you could get a lot of data collection. And I mean, I'm not sure how much you could use that data then for the next generation of the hand if you start introducing more complex movements, but that's beyond my know-how. But I mean, for this, it's definitely good enough. And for a majority of human tasks, you could probably get away with this design if it's durable enough. And at least it's been keep holding up for an hour.
Yeah, the other interesting thing is that Figure, unlike, well, we don't know what Tesla is doing right now, right? Because we had Elon maybe a few weeks ago dissing his patent, right? So somebody had posted the Tesla patent on the latest Tesla hand that we know of, where all the actuators are in the forearm with tendons going into the fingers, and Elon basically said, "Yeah, that didn't work. That didn't work. We've got something new now. We don't know what that new thing is, and we don't know what part of that didn't work." But it's interesting that Brett in that sorcery podcast basically said that, yeah, we tried tended hands and it didn't work, no. and these hands are obviously not tendon driven. The motors are in the hand itself, and they're not too bulky, right? They're not too big, and they seem fairly performant. As I'm talking, this poor robot can't grip this thing.
Oh
man!
I mean, all the I'm saying the old, they're not old, but the prosthetics for humans are based on only having the hand, and all the figures are in the hand. So they are not as dexterous or quick usually as these ones are, and they are built to really be durable and last a long time. But yeah, I mean, we're seeing more and more the Wuji hand, that they're developing that to get around the overheating issues. And just today I got sent a clip of, it was just a rendered video, but of kind of like a hybrid approach where you have some intrinsic, or as we call them, or actuators in the hand, probably performing the abduction, but it was also a tendon-based design. So they're kind of going a hybrid approach, some developers. I mean, I think we haven't really seen the best solution yet. I think the tendon-based system is going to be really tricky, especially if you want to introduce wrist motion. If you have a totally stiff wrist, then it's probably a lot easier. But as soon as you start introducing motion in the wrist, your tendons will start moving and fraying and introducing friction. So I don't know, as a non-engineer, I would expect this design to be easier. But then, of course, you have the overheating issues and the tight packaging. But I mean, yeah, why not just get that? I'm still surprised that Tesla didn't go the same approach as with the, I don't know, or SpaceX design. We just build a rocket and send it and see what happens. That they didn't do the same with the Tesla bot hand, or maybe they have internally with the older gen versions, which are more similar to this in design without the tendons, and just get it out there, starting seeing what kind of sticks. Because
we've got to presume that they have tested it internally, and it didn't do what it was supposed to do for whatever. But yeah, it seems like the hands are going to be the final frontier for hardware robotics, and for hardware anyway. Is that it's the toughest part, Turns out walking and locomotion was the easiest part, but hands.
Yeah, I did not expect that, actually. I thought that walking and keeping the balance would be more problematic, but no, they seem to have, a lot of groups seem to have solved that.
Yeah. No, that turned out to be the easiest part, and then the hands for hardware seems to be the hardest part. And of course, the AI is going to be hard as well. But the AI is, I'm getting. It's funny if you ask me about how the robotics AI is doing. Every month I'll have a different answer because it changes that often. So yeah.
It's moving on quite fast, and I really like that there are so many groups into this now. I mean, there are new. We don't know what happens to them, but there are new clips on X or YouTube every week of a new hand or a new group designing a hand or showing off their version of it. So maybe that's been the case for many years now, but there aren't that many good designs out there, or hasn't been in the last 10 years. There are these like 3D printed home DIY projects, it seems like, or research projects, but they were probably never really built to be durable enough. So the intersection of being really dexterous and being able to do this day in and day out.
Yeah, and the final boss, of course, of any robotic hardware is cost. And maybe the Wuji hand is incredibly performant, but they cost $20,000 per hand or something. Who knows? And as you say, longevity, whether it'll last for more than 3 months. So, there goes the package.
See the pile.
Yeah. I think, by the way, Royden, you were posting questions and feedback, and I saw one cycle through about 15 minutes ago, questioning whether this was autonomous or not. And it is autonomous. I mean, Scott Walter talked about it. Yes, you're seeing mistakes being made and stuff like that, but the robot is running totally on its own, making the mistakes. And the mistakes aren't probably, I don't know, they're probably, if a human were doing this task at this speed, they might make half the mistakes that this robot is doing, but they would still make mistakes. The robot's just going
to the cost.
The robot's going a little bit too fast for my liking, because the reason it's making mistakes is because it is going so fast.
Yeah,
possible. And remember, this is the worst it's ever going to be.
And of course, in a production environment, you have down the line, down that conveyor line that you can't see, you'll have gates and stuff so that when a box comes that doesn't have a label upside down, it will be shunted off to the side and just recycled. It'll just literally move in a big circle all the way back when something doesn't look right to the downstream equipment, which is fine. That's how production environments work.
I mean, I'm still amazed by that flip. I'm really impressed with that.
Oh, yeah.
Probably because it gets it right so many times. I mean, I can't really do that if the package is weighted. So it has to really have practiced that quite a lot.
Yeah. The Dreaming Oracle says like all these packages are probably bubble wrapped, no real weight to them.
Yeah, I mean, we can't really know that for sure.
Yeah.
I kind of expect it to be easy packages, most of them, to not kind of overstress the system, but someday they will need to. I mean, there's a big variability in the sizes, so that's one thing, and then you need to introduce the weight factor and things.
I gotta say, I did notice that too. I mean, that was a good comment, because the previous demos that they had shown where they had videoed a 1 hour continuous, that seemed to be more like in a production facility, in that the variety of packages was far higher than what we see here. They had like thin packages that just had like paper inside or whatever, which you will see in a real environment. Whereas here, the variety of packages, and it seems like the weight, I agree, they all seem pretty light, all these packages, including the boxes. So I don't know if Figure is doing themselves much of a favor by practicing on this, because it's not real world packages. Maybe it's just.
Brandon says, if I make a suggestion, I would say give your robot the ability to use play and maybe music, and it'll go faster. Now there's a tempo to keep up to.
Yeah.
Why not?
Somebody else, again, on a comment that went by talking about UBI. So they're now
Yes.
going off into the future and going, okay, in 10 years, when robots are doing many things, are we going to end up with a UBI? And my comment to that is, yes, something like that is inevitable. And you see it, it's not something that you have to wonder about in the future, science fiction or whatever. You see it in the world today. So in the United States even, so Alaska as an example, they have so much oil resources, so much oil wealth, right? That the state taxes the oil producers at a high enough level that they end up with a surplus. Who imagine a state government with a surplus, but they end up with a surplus at the state government level, and they actually will cut checks. They cut checks to Alaskan citizens every year, a couple $1,000s, something like that.
And that is Republican state normally, right? So it was at least introduced by a Republican leadership, I think. So it's not just left wing.
No, not at all. And in the Scandinavian countries, like in Norway, they have a similar thing. They have a lot of oil wealth. They don't cut checks to citizens. Instead, they have they use the government to provide social services, right?
Yeah,
so
the social net is strengthened. Yeah.
Yeah. So there's
shout out to the humanoid hub. Sorry, Phil. He asked, is the robot being actively charged, or are they going to swap the whole body out every roughly 3 hours?
So they did swap it at 56, 57 minutes. We already saw it once. So.
Yeah. This was from earlier. But a special shout out to the Humanoid Hub, who does a fantastic work for the community. Sorry, Phil, back to you.
Yeah. So anyway, I'm just saying that governments, as the society gets richer and due to automation, will have ways to distribute the wealth, the accumulated wealth out. It just has to. I mean, people get worried about, oh my goodness, the Silicon Valley leader going to make all the money on this. It's like, no, that will not happen, because in a democracy, the population will not allow that to happen, right? They will elect politicians that if a group gets too powerful or too rich, the politicians will make sure that wealth gets distributed. So it will just happen. We don't have to worry about it.
And I mean, even this rich Silicon Valley individual will not, he or she will need to have some kind of income from the populace. So the population, sure, it could have the bots just building them ivory towers or whatever, but in order to live in a functional society, you would need the population to have some kind of disposable assets. Otherwise, the economy as we know it will kind of shut down. So, but it will be interesting to see where this goes. I mean, we live in exciting times.
Yeah. There's a surfeit of basic economic knowledge out there in X land, on Twitter posts and Facebook posts and everything else like that. If you actually study a little bit about economics, you find that it's going to work out. It'll be fine. You don't have to worry about it.
It will be even more fine if you invest in the right company, I guess.
Yes.
Absolutely. Or invest in RoboStrategy.
Yeah, so full disclosure, I have like $50 of RoboStrategy since yesterday. So
you bought some?
Yeah, I mean, I have to support good old Scots.
Yeah.
Big investments of a few bucks.
So I don't know if I should mention this or not, but I'll just give a hint to anybody listening. RoboStrategy is a closed-ended fund, and you should read about how a closed-end fund works. Ask ask AI. Sorry, it's become a verb, right? I should say ask AI. Ask your favorite AI how a closed-end fund works, and especially look at the net asset value. That's the number one number that matters in a closed-ended fund. Now, RoboStrategy is unique in that most closed-ended funds are based on public companies or assets that are priced continually, in which case the NAV is actually accurate, very accurate. But RoboStrategies, all of their assets are private companies, right? So they own chunks of Figure. They own chunks of, I'm kind of blank now on what the other companies are. But anyway, they're all high quality, Aptronic is another one. They're all high quality robotic companies that are all private. So the valuation for private companies is always a bit mysterious. Sure, you had a valuation when you bought the private stock, but over time, assuming the company is doing well, like Figure is, that valuation is going up. But unless the company does a fundraise, you're not going to know what that valuation is. There's no market for it. So the NAV is going to appear low on RoboStrategies, but that's only because these companies haven't recently done a fundraise. It will go up over time.
Oh, what's happening now? Gonna fall over.
Oh.
Looks drunk. God save it. Or Brett.
Maybe it's reorienting itself.
Yeah, it's like, what am I doing with my life? I wanted to be a singer.
I think there's a system pause there, right? Again, I think that's a bit of coordination because the packages on the incoming packages stopped as well at the same time that the robot stopped.
Yeah.
So there might have been some kind of system pause there going on.
Glitch in the matrix.
But yeah, maybe the as you say, maybe the robot needs to get its gyroscopes or whatever reconfigured, and it told via radio, it told the conveyor to, hey, stop there for a moment while I figure out my life.
So we've got a few comments coming in from obviously Tesla supporters, Optimus supporters, and this is the first of them. Dreaming Oracle says, yeah, I think there will be different use cases. The Figure is probably good enough for many scenarios, but in terms of capability, Optimus will win. And Tony Soar says Optimus will win the real world. AI Figure will win the early contracts, but people usually keep what they learn first. So here's the thing. This is not a winner takes all. It's a winner takes most. And it's going to be a constantly evolving market for bots.
I mean, if you build it, someone will. If it works and you build it, someone will buy it. And I don't see this market being what do you call it, filled up or crowded in any time soon. I mean, if you build 1 million bots and they are very capable of, you will sell them or rent them out. And if you build 1 billion to the right cost, you will also sell them. So I'm not sure I buy this Optimus will win or Figure will win. Everyone will win in the end, as long as they are capable to the same extent. Of course, if you pay the same price and one of the machines is significantly better, then of course you want the one that is better and more effective for your company or your home. But I mean, I'm an Elon fanboy as everyone else, and I know that his companies have kind of done the impossible before when it comes to making the electrical car industry work and space industry, etc., etc. So I'm not gonna kind of say that Optimus will never catch up to Figure, but I also have to be honest that I haven't really seen where they beat out or where they are better than Figure yet, because they haven't really shown that much. And I know that Tesla has a lot of talented engineers and they can recruit the best and brightest, but yeah, they better step up if they're gonna.
Yeah, no, I agree that this is a huge market, and it's not going to be a winner takes all by any stretch. What it's going to come down to, well, first of all, you have to assume that Figure, Tesla, and others are actually going to be able to produce a performant bot. So assuming that all these companies can produce a performant bot, then the next step is, okay, at what cost? Okay. And there's where you get into manufacturing economics. At that point, cost, right? If Figure does a robot at a service at $30 an hour, and for the same thing that Tesla can do it at $15 an hour, obviously Tesla is going to blow Figure out of the water. So how do you get low cost? Well, I mean, that's the tough manufacturing problem. And so right now we're looking at these humanoid robot companies as an R&D challenge, and we're seeing an R&D thing right here. But within the next year or two or three, it's going to turn into a manufacturing challenge. And it's nice that Figure is actually building or built a bot queue, their manufacturing line. It's a relatively low volume manufacturing line, but they got to start somewhere. And just like Tesla, this summer is building a relatively low volume manufacturing line at Fremont, right? They infamously nixed the my poor car, my Model S car assembly line and the Model X assembly line. They nixed those assembly lines partially to build a Optimus assembly line there this summer. So both Figure and Tesla are basically at the same position, or at least will be by the fall, building a low volume actual manufacturing line for these robots. And I suspect a lot of the output of those manufacturing lines will still be used for training. I don't know if we're going to see too many Optimus or Figure robots in customer locations by the end of the year, but next year we will. I'm pretty hopeful that next year we will. But then we go on from there. Okay, that's only 2026, 2027. Right now, as we speak, Tesla is building the mother of all robot factories at Giga, Texas. And you can see it in Joe Tegmeyer's drone videos every 2 days. It's ridiculous. It's like, it's like, oh, here's another drone video from Joe. I mean, my God, that guy is prolific. But, and it's a huge factory. I mean, the ground clearing that's going on now and the foundations are building for it. And they've got this interesting plus deep foundation right in the middle. And it's like, what is that for, right? I didn't think that robot manufacturing was going to require deep special foundations. But I mean, who knows? For all we know, Tesla.
I think that's for Stargate to shoot these straight out into orbit to Moon and the Mars. So
yeah, I was gonna say maybe Tesla is gonna start doing iron ore processing. You know, they're gonna have a giant smelter there. I don't know. Yeah. I mean, you never know with Elon, right?
So here's an interesting question. What do you think consumer robot timelines are? There's a previous one that said
consumer as in me or you buying one.
Yeah.
So OneX
I would imagine so.
has said that we will be able to receive them this year. At least I'm guessing the US customers. Do you think that's going to happen, Phil, or they...
I think it will happen, but they're in a small number, like 50 to a couple hundred at most. The average consumer, where I'll be able to put in an order on my website and get one within a couple months, that's going to be a while from now. I think 3 years would be my guess, earliest time where ordinary consumers can get a bot that's actually useful.
Also, the functionality is also going to be evolving, right? It's a moving target, really, because as more and more features in terms of functionalities are added, the bot's going to become more and more useful. And so I don't know, how do you price in the cost of a bot that's available to consumers?
Yeah, and where are the consumers? To what level do they expect it to be? I mean, you could buy a Unitree now and you will have a robot at home, but it won't be able to do anything unless you kind of specifically program it to do that task. Or
well, here's an interesting comment. He says, Setup 3030 says, I think they will pass the espresso test this year. What do you think?
Yeah, but that you need a lot more than making espresso. I mean, you're talking a $50,000 espresso maker. How many people buy that? It's not a very big market. So
you could definitely have them deployed at cafes.
Yeah, but that's not in the home.
No, the novelty factor will kind of, I mean, it might be worth it for the first few bots to show up in a coffee shop. Maybe you could kind of motivate getting more customers, but in a while, the novelty factor won't be there, I expect. So it's like, then what do you pay for it? Would you pay 30,000 or 10 or? I mean, I guess if you can replace your human espresso maker, then perhaps it's worth it.
Well, we'll wait for you to get your 1X first, and then Give us your analysis.
Yeah.
I mean, cost makes markets, right? So the lower cost, the higher the market. There will be the Silicon Valley elite that buy $100,000 bot to do a few things within their home, just to say that they bought a bot to do a few things in their home. But that's not a very big market. If you can get down to a $50,000 price point, and I know people are thinking 10, but if you get down to a $50,000 price point that can do all your laundry and your vacuuming and your toilet cleaning and your kitchen cleaning and stacking and unstacking your dishwasher, all those, household tasks that you might, that are annoying or that you might hire a house worker to do, then there will be a market for that. Yeah. Relatively, a decent sized market. 50,000 is still a lot for a lot of people, but some number of people will actually pay for that. Once you get down to $20,000, then a lot more people will pay for it. And at that point, you can actually do it at robot as a service, and you could lease them out, rent them out, just like you would pay a household employee.
Yeah. I mean, in Sweden, we have this kind of, if you buy an apartment, it's usually in a complex. So we have like call it förening, kind of like everyone who owns an apartment in that house have like a small, we call it council. So that kind of building, you could split that bot in 10 apartments or 10 families, then it would definitely be worth it, especially if you don't need it every day, probably.
That's a good point.
Like I have it 2 hours. Point. It goes to the neighbor's house and it goes to the next neighbor, and then you could probably it would be quite cheap, I'd say, for a
also Airbnbs or larger. So Scott mentioned hotels in the hospitality industry, but even Airbnbs for properties that have multiple units on one property, that's a perfect use case because you can just go through each unit, clearing up.
Yeah.
Gustav, I like your idea of condos and sharing a robot.
It's a socialist Sweden, the commune.
Right.
But I think that's a good place to start, at least, because then it won't be as big of an investment. I mean, it's the same with carpooling. I don't know if it's a thing in the US, but in Sweden, there are quite a lot of people kind of buy into a carpool, so you only use the car when you need it, and then someone else can use it, and you can split the costs. It's not really a big deal in Sweden. Not everyone needs to own a car in most of Swedish cities. So
yeah, in the US, for suburban lots, people hire gardeners, right, or a gardening service that once a week comes and cuts the grass, as an example.
So there's an interesting comment here from Al Force, who says, I worked in a shipping company and they have size sections, so similar packages are frequently grouped by position for the shipping line. Earlier in the line, they can sort by size. Yeah, I mean, I'm not quite sure what size packages he's talking about, because that might not just be the use case for this particular humanoid bot. But yeah, it is interesting. All right, we've got Scott back. Let me bring him on stage.
Yeah.
Welcome back, Scott.
All right. Anything exciting happening?
You missed the bot swaps.
Yeah, you missed the bot swap.
I knew that was going to happen.
That's 56.
We've had two bot swaps, which is interesting, right? Because
only one swap and one kind of shaking.
Oh, I'm sorry, you're right. Anyway, we had a bot swap at the 1 hour mark, more or less, which was early, but maybe they just did that to show it. I don't know.
And it's still keeping a steady pace at 22.5, 23 packages.
So it was able to do the pull down when everything backed up, right? Because I assumed there was a transition period of like 30 seconds or so.
Yeah. Let me see if I can go back to the point in the live stream and we can replay it and kind of get Scott's analysis. So I think, Gustav, it was about 56 minutes into the stream, right?
10 minutes back.
That was like 30 seconds after I left.
Yes.
Of course.
So here you can start there a little bit later. So in 1 minute it will swap.
Okay, let me just take it forward a bit. 56, here we go.
Yeah, keep it there. It will start shaking in the back and come loose from the charger.
Yeah, look at the bot right above the current bot's head in the background, and you will see it start to move. It's kind of like a horror movie.
And one of them's going to wake up back there.
There he goes.
I think there he goes. Yeah.
Oh
He's
yeah,
starting to
oh,
shake.
Yeah. It's like
And then he rises
He
up,
awa-
right?
He awakens.
He's rising up.
Right.
He's waking up. Oh no! Here it comes.
Here he comes. Oh no, it's the boss.
And you can kind of feel him coming. It's like, uh-oh, what did I do wrong?
Yeah.
And he freezes like, oops.
Okay. I'm being called. I'm being summoned.
That's
Okay.
an all-hand movement.
That's okay. So it's probably something that's taught to make sure the hands don't accidentally hit the conveyor when it goes
The tray,
down.
right? Okay.
I mean, it almost looks like something an industrial roboticist would do when it's like, oh, when we're all done with something like that, we try to get it in the same position. It's tried and true.
But I mean, the swap is less than 1 minute in this setup. Around 56:30, it started moving, and now it's already at the conveyor belt. So
Now it's in the set position, and now it's like, okay. So there you saw the legs were probably useful in being able to get that package that was way over there.
and the-
Yeah.
Allowed it to kind of reach in. And now this is a critical part in any sort of production system where your conveyor starts to back up. You need to get going pretty quickly there to do what they call a pull down, get you back to where you need to be. So ideally, you would like everything to be a constant rate, but that's never the case. Things go faster and go slower. So every now and then you need to do that to make sure it's able to keep up. So you're going to be a little bit behind, but hopefully within a minute or two, you're kind of back up to where you should be.
Yeah, I think there was some coordination there because the packages seemed to stop when the robot decided to switch. So there might have been some coordination there, and or this is a manual package because this is really in the factory. So who knows what's going on there?
It's in there, and of course it's going to be like that. It's also going to be a little bit feast and famine in the actual customer setting.
Yes.
Because these trucks are coming in and they're getting unloaded. And so basically a dump truck backs up. It's like, and you're kind of going there in your front. And then eventually it'll probably get sparse. And maybe the next one comes in the next one. So you're going to expect the ebb and flows that are going on here anyway. And so if you know that, you would probably time it around there. That we know it's going to be a low point here. We know that our state of charge is pretty good right now. We'll just go ahead and change out. Oh, I wasn't even paying attention to the bot going back to the charging station. Yeah.
Or maybe go to the end of the live stream so don't miss any juicy.
Yeah, go back to the live.
Yeah, exactly. The thing is that they need to have different colored vests so we can tell whether they. Oh, wait a minute! Did we just? Oh, that was the very beginning. Did they just drop a package?
It did.
Done it a few times, like 2 or 3 packages. Yeah,
okay.
So
wait a minute!
There goes another one.
Okay. I bet that blue one went off too.
Maybe it's if it positions itself slightly
maybe
to the
just
side
a
or to
little
the
bit.
back.
So something's happening right now that that one there I bet went off too. So
You have rails. I mean,
we're rail right now, right? Yep.
Yeah.
It's missing a rail.
Yeah.
Okay, there's an interesting comment that's come in. I thought I'd toss it up and ask you for your reactions. This is with regards to charging, and Brandon Miskell says, I think if you own a factory, you should get rid of the charging flow pads and just have overhanging cords that drape directly over the top of the robot, no matter where it is in the warehouse.
Kind of like these, what do you call them? Trams systems or? Like
Sure. I mean, that's one way of doing it. There's many ways of having electrical distribution within a factory. But yeah, if you had a factory, presumably you would get the cheaper bot version that only has 1 hour or half an hour of battery life, and you have it plugged in essentially. Yeah.
You don't want to clutter your factory with a lot of things that they can get stuck on. And
okay,
I mean,
let's see what it does here, because last time it kind of got itself. Okay, so it's got a big pile up here to try to pull it down. Now it needs to be careful to make sure. Oh, okay, it failed on one. And getting that. Oops,
that was wrong. Yeah.
Back to the charging pad for you.
That's where it still needs a little bit of work. And I think I've seen that before where that happens. You get a lot in there. It's trying to figure out what its prey is.
There's another one.
That one there failed. Okay, we go ahead there. Should be getting
But
better.
it's probably in an ordinary factory setting, if that was an issue, we just circle around back and maybe you lose 1 in 20 packages, and it has to redo it.
Yep. Now it's getting it. So basically, that's like the question is how many times they've sort of done situations like that where you have such clutter that you're really trying to figure it out. It's almost like
more
it's in
training.
panic mode. The boss is saying you're gonna hurry up. And here you need to separate those. There we go.
Yeah, I mean, I think Brett was pretty proud of the fact that this is going at human speed. So I don't know if he probably told his guys, okay, make sure this happens fast, and that what got missed in there was accuracy. So there's some optimization still needs to be done, I think.
What's the acceptable error rate?
Usually these things you would like to be high 90s. Some cases it depends upon the particular factory setting in there. So there's usually this thing called the OEE. It's a type of KPI. So it's overall equipment efficiency, because each piece of equipment at each stage may have a certain failing. That'll kind of pile up to that. You have your theoretical output and you're only able to hit it at a certain amount. In many cases, you may be as low as like the low 80s. In other cases, you'll be a little bit higher, up in the 90s. So it depends upon the particular use case. They already know what it is for that particular setting. And what they're doing is they're telling every one of them, you've got to hit this KPI, this particular one. And if you can hit that, then you're ready to go in. So it's expected that there's going to be problems. There's going to be drop packages, and there's going to be also some examples where they forget to turn it over.
And I mean, it also has to go factor in, if this bot cost half as much as a human employee would, then you would tolerate a higher degree of inaccuracy, I expect. Kind of your, I guess there's a minimum output that you want to have in your delivery service, but still.
Yeah, basically it's a TCO, total cost of operation calculation that you're doing at the end of the day. The business, all they care about is the cost per unit output, per unit correct output. So you can make mistakes if it's faster or cheaper. As you say, if it has like half the cost of a human, it can make a lot of mistakes.
And then you just charge the delivery.
Speaking of cost, what's the value of just this bot doing this task?
You've got to replace a fully loaded human, which is probably getting paid. I don't know what factory costs are these days. Well, the actual per hour rate would be $18 or $20 an hour, something like that.
Right?
Yeah.
Well, plus
higher.
a bit. Higher. Almost nobody gets paid minimum wage unless you're in the hospitality restaurant business, because they get tips or whatever. Mm-hmm. But let's say it's $20. Let's say it's $20, but then you've got a loaded cost, right? You've got healthcare and downtime and sick days and vacation and everything else. So that might easily raise it to $30 an hour. Yeah. So if you can do this for $20 an hour, you're golden.
Yeah,
but then how many bots do you need to deploy? Because we're seeing now 3. For an 8-hour shift, it would be a human, singular. But then if you factor in battery swaps and then all of the other things, how many effective bots do you need to replace one human?
In theory, the bot has about 5 hours of runtime. They probably run it for about 4 hours, and it takes about an hour to fill it back up. So you probably would not have 2 or 3 bots sitting around doing nothing. This isn't in a construction zone. This is something else. We're actually paying people to do work. So you could come up with some sort of ratio that, in a lot of these logistics sorting centers, there's more than one of these. There's quite a few of them. And maybe your ratio is you have 5 of these bots, but 4 of them are working, and one of them that's always charging. So you could do something like that. Just make sure you stagger the charging on that. So that's how you'd have to base your costs, is like the number that they're. And again, this is why early deployments are going to be more narrow kind of applications where you not only do you need to do this particular task all day long, you need to do it multiple places. So you get that advantage of being able to scale up with a lot of bots where it's it's okay to have one extra bot. Because if you just had one of these, we'd have to have two, and then the numbers don't quite work out. And the other thing that Phil's mentioned, $30. That's sort of what I've seen as typical for a lot of what is the loaded cost, and that's kind of the low end that most people will come up with. As you start to get more complicated tasks, then of course it's going to go up. But that's about where you are. It's also going to depend upon the jurisdiction you're in. So California could be a lot higher because the minimum wage is a bit higher. The cost of living is higher. Sometimes you have no choice. Whereas other parts of the country, it might be a little bit lower and a lot harder to be able to justify it, except you may not have anyone to do it. So a lot of the reasons why these logistics centers want to bring in automation is that no matter what they pay, they just can't find people, or the people come in and they leave after a month. And that's part of the loaded cost, is that the onboarding is expensive.
Yep.
And the fact that you're constantly having to recruit and do everything else. So that's like that other additional cost that kind of goes in there. If you have to constantly be hiring, then that's very costly. You need to find some way to be able to reduce it.
Yeah, the loaded costs, I mean, the costs get high pretty quickly, right? You got HR to pay for, you've got recruiting costs to pay for, you've got the lawsuits to pay for, because every single employee is a potential lawsuit.
Yes.
And so insurance, right? Lawsuit insurance, lawyers, legal fees. I mean, you just add all these things up, and the hourly fee ends up being a fraction of what you're actually spending on these employees. And that's what a lot of people who don't run a business don't realize, is they only look at what they actually get paid. They don't realize there's a lot of money behind that.
Yeah. If you know what's involved in running a business, you would never want to run a business.
Yes.
Once you find out, it's like, whose idea was it for me to set up this company?
Well, I've got my my aphorism, owning a business is great. It's kind of like having a money tree, it just prints money. But the only problem with it are the employees and customers. If you didn't have either of those, it'd be great.
Yeah, exactly. Okay. Oh, it got really confused there. I think it had it down.
2,500.
And there we go.
So here's an interesting comment from Dreaming Oracle. I'm sorry, Scott, is going to cover you when I fire it. But it says, Dreaming Oracle says, I think the fear of worker replacement is just arbitrary fear. I think the real way it'll pan out will be that bots will enhance plus supplement your workforce as opposed to simple replacements.
Yeah.
More
in many cases. I agree with that sentiment.
Initially, at least.
Yeah, there's a lot of concern that's going to result in workers being fired. And that I've spoken to a lot of robot companies, and also a lot of companies that are planning to use it. And all of them are like, agility has come right. I think Peggy Johnson says the first question they ask is like, are you planning to replace workers? Because if you are, we're not interested. A lot of what they're doing is they're trying to supplement it or make up the fact they can't get it. So there are a lot of shortages around the country in a variety of different areas. And a lot of it is because no one wants to do this work. It's boring. Maybe it doesn't pay high enough wage. There's all sorts of reasons that people don't want to do that. And in many cases, you're right. It's going to be supplementing, and through attrition, it'll be a lot easier. I mean, it's not going to be that they're going to say, "Oh, we're going to fire people now." Since the people are just attriting anyway, you can kind of put it in that way. The other is the possibility that the people there are now suddenly going to find that they have more of a kind of a managerial role, that they're going to be managing the bots, and they kind of go up there. And that's the same thing that sort of happened in Detroit with in the automotive, is when the robots came in, suddenly there was actually better paying jobs in the factory setting because you were managing these robots. You had to be a skilled technician to be able to do it. And then there was also a huge workforce outside of it that was building these systems in the first place. So I don't see it as something that's going to result in the loss of jobs, but actually improvement overall. And in many cases, some of these companies, they're not looking to reduce headcount. What they're trying to do is improve throughput. So if they can actually get twice the number of product out the door with the same number of employees, they're happy with that. They're not going to cut back on employees if they don't have to.
And we're seeing it right now with AI, right? ChatGPT has been with us for over 3 years, and has
Write that down.
improved. Yeah, has improved worker productivity in a lot of different areas, and
Oh,
yet
absolutely.
the U.S. unemployment rate is still stuck at like 4.2, 4.3%. It hasn't budged. We still have historic low unemployment rate. So, and we've seen it historically, you know, with the advent of microprocessors and personal computers, and then the advent of the internet. These were huge society-changing changes, and yet we're still all employed for anybody who wants to be employed. So the same thing's going to happen. It's just that robots just feel a bit more visceral, right? But it's amazing what an economy does. It just figures it out. And yes, you're going to end up with UBI as well eventually. That'll be the eventual end state. But it'll take a while to get there.
Another interesting question, and this is from Gerard Levens. Sorry if I butchered that. Has anyone here seen consumer robots outside of China? China might be ahead of us when it happens.
So China, I'll just say two things real quick, Scott. China is interesting in that they have had kind of like a state mandate, if you will, to spend money and to invest on robotics. So they have hundreds of companies and a broad ecosystem for building all these things. They're just as behind the eight ball as we are on the AI. Their bots aren't incredibly useful yet. They're trying to figure out use cases. I mean, they end up in entertainment, right? You see these dancing bots in actual entertainment, which is a perfectly fine use case. Not a huge use case, but it's a perfectly fine one. So they're figuring out places in which these things can be used. So I'll just leave it at that. But the AI is really it's stopping them from using it in more places. By the way, you noticing that figure bot, it's like it's using its feet. It's moving all over the place to get these things.
Yeah,
it's impressive.
Yeah, to increase its reach. That's the whole idea of legs, is to give you a bigger work envelope.
You can't do that with wheels, can you?
It will depend. If you need to kind of reach in, it's kind of hard, or whether you'd have to design your mechanism a little bit different. But you do have to be a little bit careful with wheels. Can be more tippy than you expect, because you don't have the ability to sort of actively catch your balance. But once a wheeled robot starts to fall over, it seems like that's it. Whereas like when we start falling, we know just put your foot out and you can usually catch yourself on that. Now, this is typically, like industrial robots have always had a limited work envelope. And the way we always extended it is we put it on a track or something like that to be able to do it. But it means you have to have an axis for each direction to be able to do it. And usually that's bolted down on the floor. So that's a typical way of taking something, because otherwise you'd have to have an arm that's way too big, right? If I want to have a 10-foot reach, I don't want to have arms that are 10 feet long. I want to have it a little bit shorter, and then we can go in there. Now, of course, you won't get a 10-foot reach by leaning over because everything else is in the way. And of course, our reach is limited to our overall height. Maybe we can get 8 feet from toe to tips.
Yeah.
So, Scott, we kind of interrupted you. You were going to say something about China?
Yeah.
Oh, so that was interesting. It whacked the package and did it tumble over on there. I was just like, that last one there. So I guess the one thing is the question was something about, have we seen anything out China? So there are some European companies and others that are trying to put together kind of consumer bots, but I don't think there are any out there. So have we seen robots outside of China in like a consumer setting? So yes, you have, and they're Chinese bots. Okay, so like Agibot or Unitree. And then there are, and those would be more in the commercial. So and also Booster. So a lot of people are being able to buy them to do entertainment with, or just experiment in their homes, also universities and everything else. Unfortunately, there aren't really any, I would say, Western robot companies that are producing something that you can buy as a consumer. Unitree has famously opened up a store for being able to sell robots. We do have a robot store now in San Francisco.
Rex,
which Rex just set up. And full disclosure, RoboStrategy is an investor in Rec, okay? But Rec is doing entertainment with robots for boxing. And I think they'll be showing you might be able to buy and service your robots there, but they're going to be unitary bots. So REC is using them. Now, this is where this is kind of an interesting question on economics. When are the robots going to be useful? And we talk about them doing useful work and stuff like that. And we think of a setting like this, but when they're useful is when they can actually kind of pay or justify their existence. And so like in the entertainment areas, they're getting to the area that they could be justifying their existence. And there's a lot of companies and small startups with people doing exactly that. You know, bots that you can rent for a party to come in and do entertainment there, you know, boxing matches and stuff like that. So you're going to be seeing more of those things because those are maybe the lowest of the low hanging fruit, because you really don't need manipulators to do a lot of those things. So because that's the trickiest part. So that's where we're at. And again, want to remind me about the booster bot. The booster bot is sort of famous for playing kiddie soccer. And they put a lot in there in being able to kick the soccer ball and do other little things, and not necessarily like the kung fu flips, kicks that you're used to seeing with Unitary and others, but it still does kind of one of these little twirly kicks that seems to be a mode that they have. And there's one individual that decided to bring the little booster bot onto the Southwest flight. It was kind of doing that out in the waiting area before getting on the plane. And he's kind of wondering why he ended up getting banned from Southwest. I mean, basically getting the bot. So it was allowed to make that flight. But then afterwards, they were like, okay, he did everything to make sure the battery was the correct size, because that's usually been an issue. You can't bring a bot on the airplane because the battery is too big. And you can't put it in the luggage hold. It's like, there's no way you can do that. You actually have to bring the passenger compartment. So he actually changed the batteries to make sure they fit the spec. And then the bot had its own ticket and it walked right on down and sat next to everyone else and get strapped in and everything like that. And then I guess afterwards, management looked at that and they're like, we're not so sure this is a good idea, because you don't know what the operator is doing. We've seen it in China that the bots have come very close to injuring people. There was someone that was decided to do a kung fu kick of the Unitary bot that came like that close to a child's face.
Yeah.
And now that wasn't necessarily the robot making a mistake. That was the operator deciding to either intentionally hit that and maybe intentionally spook or scare the child. Wasn't a good idea because he's afraid of robots for the rest of his life now.
It's scarred,
yeah. But you could argue, well, wait a minute. It should never be operator error. If the robots are safe, no matter what the input is, the robot has to know, okay, you're asking me to do a kick right now. No, I'm not going to. It's not safe. So there's going to have to be safeguards like that. For
just a couple of things I wanted to add to this discussion about China. The first is, if you're interested, anybody watching, please, I encourage you to go and read China's 15th five-year plan and their ambitions for autonomy and robotics of all form factors, but specifically humanoids. It will really blow your mind just how ambitious China is. Second point is, I think we need to stress here that China dominates the supply chains for robotic parts. And I think that is an advantage that currently is unbeatable. America's trying to do a lot to onshore that, but it has its challenges. Scott and Phil, if you could add to that, please, that would be a great value for our viewers.
Oh, absolutely.
Yeah.
You take it first?
Well, it's pretty much unbeatable. I mean, China has been doing this since at least 2000, right? For at least the last 26 years when they got invited into the international trade system. And they, the other thing too, I mean, they're 3 times the United States size. And then they also have on top of all that, they also have a societal culture which doesn't, which encourages people to work with each other within a capitalist system. There's a lot of structural differences with China. Anyway, and then on top of all that, they're entrepreneurial. Like individual Chinese are I swear, are just entrepreneurial by birth, or so it seems. They'll just do things and just try things. And anyway, and then you've got the structural financial incentives, where when central Beijing says to do X, then all the provinces and mayors follow through and deliver loans and equity to startups to do X, whatever that is. But yeah, it all results in a manufacturing base which is unparalleled, very entrepreneurial, very quick, and yeah, I don't see the United States catching up anytime soon.
Yeah, it definitely, there's this huge advantage to having the supply chain there. When Optimus was first announced, the first thing Elon said is that we had to design our own actuators, because you couldn't find any in any catalog anywhere for no matter what price you wanted. And that was a very true statement at the time. They had to do that. They probably built some of those actuators or a little bit, but at the same time, you can design actuators now and then have someone build it for you, or get some of the components that will go in there. And of course, now there is a catalog, so that has changed quite a bit. So if you were in the same shoes as, wanting to do a humanoid startup today versus 5 years ago, it's really easy because there's a whole catalog of actuators to choose from that allow you to get that jump start. Now, the disadvantage we have is because it's here, or because it's in China as opposed to here, even if you order that thing, it may take a while to get it. So you lose the speed. And if you have a change, it takes a long time. And it's not just with actuators. You're constantly hearing all sorts of parts that people want to have that by the time they get a response to their email of what they want to do, the other side not only has quoted, but already built and shipped, and it may already arrive. So in many cases, people are frustrated that it takes a long time on the back and forth just to get someone to build a simple part for you.
You're talking about the United States
I think is changing. Talking about the United States, yeah. In many cases,
right. Yeah, that comment about the frustration has to do with United States suppliers, right? Whereas Chinese suppliers, you can order things and you'll get it right away. Overnight it to you for
it's
for
crazy
R&D.
in Shenzhen. Yeah, there will be people that say they're working like midnight or something like that, and they need a part, and they literally go down the elevator, walk out in the street, and they'll find some sort of PCB manufacturer right there, and by 3 a.m. they'll have the part that they need. That is crazy. So
so that's China
that
versus
versus
the United States, which is like weeks difference. Yeah,
that's what they mean by Shenzhen speed.
Yeah. There's an interesting comment. Let me just find it, but it said that Trump is there in China right now to take a look at their bots. I would say also, there we go. Also, their supply chains.
Mm-hmm.
Yes. Yeah.
Yeah. And I'm sure Elon definitely is very interested in kind of sussing out what's happening. He probably knows
he knows
ton of what's going on. But yeah. So here, let me just bring this up again. And apologies, Scott, for it covering your face. But it says, this is from Norbert Furels. It's like this robot with a gripper that is supposed to pick you out a cool toy, but it always slides through the gripper and never grasps it.
What is that thing called? The claw. Is that what's called?
The claw comes out,
yeah. It goes down and never gets it. Yep.
So supposedly this Figure hand has, not only does it have a palm camera, and I don't know how much they're utilizing it right now, but also has sensors, right? So it has sensors on the fingertips.
Yeah.
And again, I don't know how much they're utilizing it, right? Sometimes these robot manufacturers put on hardware functionality that the software hasn't really caught up with yet. So it's not clear how much those fingertip sensors are being used or the palm camera is being used, but the capability is there. They could be using it, and this could be why it's able to do what it's doing.
It feels a little bit like when Elon decided to go with all the cameras on the Teslas back in the day, way before they even had the vision-based kind of setup running. The software was not there, but they decided to equip all the cars with cameras and skip on the light or whatever. So maybe they're having a similar approach, like just add what we think we might need, and we could always remove it. But is it too early? Or, I mean, like this, do you think they're training now as well, or is this just for show, or are they actually?
Yeah, absolutely training. Absolutely, yeah. And I imagine there's, in a lot of these training scenarios, you have something like you have an AI evaluator, right? So you can, and the AI evaluator can be offline as well. So they can be recording this video and then offline even, so you can have a lot of AI compute put on this problem. The AI compute can be seeing what we are seeing, right? We are seeing mistakes, right, in real time. The AI evaluator will see that as well. They will see the mistakes, and then you've got the training video, you've got the mistake signal, and that just goes right into the training loop. So let's train the next model, next figure model, and it's got all this very good signal that, hey, you know, about every, I don't know, looks like about every 5% of the time it's making a mistake, or 2% or whatever, and that signal goes right into the next training loop. So absolutely, this is I mean, this is, you're looking at this as a nice demo, but I guarantee this is being used for training as well.
Okay, there's another interesting question here, and we've discussed this on our robotics chat on Over the Horizon in the past. And this is Dreaming Oracle. So there's no real actual reason it has only 2 arms. It could have 6 arms with tools attached, etc. But that's a response to an earlier comment. But it's a valid point, something we've discussed about form and functionality, and whether you need to be limited by the human form factor when you're building humanoid robots for the factory floor, for example.
You don't, but it's an economic argument, right? I mean, you build one embodiment that you can make 1 million copies of, whereas if you had a 6-armed robot, it could only be used in a limited number of situations. So you couldn't make as many of them, so you couldn't make them cheap enough.
And also the training data. I mean, maybe in the future, the bot will train based on its own form factor and not based on our videos anymore. But before we get there, to have something training a 6-armed octopus design,
the arguments go back and forth on why, you know, 2 arms, and again, like not 3 arms or 6 arms, why 5 fingers, everything else. And everyone has a good argument. The main argument is that the closest it is to human embodiment, the easier it is to be to train if we're going to be doing egocentric. So that's one school of thought. Others are like, oh, we think we can get around it with other ways of being able to do mapping and everything, and they're pursuing that. I think the argument that we can make between, you know, why not just build a single purpose robot for this? And it's just like, we have been for like the past 60 years. It hasn't been going very well, because if it was, we'd see a lot more of them out there. So what you're hearing basically is a tired argument. I've been there, I've seen it. It's just very, very hard for special purposes. It seems like it's perfect, it would be super efficient for it, but the economic justification is very, very hard, because your volumes have to be very, very, very high to be able to do it. When you have small batches, you know, especially with very high mix, it's very, very hard to get these things go, because there's no such thing as like the universal gripper. Every time you think you've developed a gripper that's able to handle something, then some other part comes along and it doesn't work. Everything else about the robot arm, all the programming, everything, it's very hard to get them. They become very specialized and extremely expensive. So that in a nutshell is the reason. If that was the solution, it would have already been solved.
Yeah.
But it's not.
Evolution is not without fault, but there are that many animals that can perform as dexterous tasks as we can. There are a lot of different grippers out there, claws and the different tentacles or whatever, and some of them are really good, and some are good at using their beak and doing different things. But there are no other form factors in biology, at least, that can perform as well as the human hand.
But that's also function specific, isn't it? And environment specific.
Yeah, but humans are adaptable to an extent that no other animal is, and it's not just a hand, of course, it's also our cognitive abilities.
Yeah, Gustav, you're biased because you're a hand surgeon.
Yeah, but I mean, the hand, there is, sure, if you're in the Arctic, you would need gloves. But there are no animals that have the dexterous capabilities to make gloves, I'd say, even if we gave them a human brain. Maybe you can with a beak, I don't know.
I mean, the main thing is that we're the tool makers. And isn't there like one of the species, the Latin came out, something about the tool maker? That's what really is the distinction. I know there are some that have kind of figured out how to use tools. I'm not sure if they know how to make tools. There are a few, I think there might be some bonobos and others that are making it. But for the most part, that's what makes us different. It's not so much that we can do everything with our hand, but our hand is good enough that allows us to make tools and then use those tools with that hand, that the tool allows us to unlock and do all these other things. So in some ways, we are still using special end-of-arm tooling, but end-of-arm tooling we're putting robots is not something a human can pick up and use. So my argument is, if the robot's going to come into the kitchen, I expect it to use my appliances and my utensils. I don't want any special robotic stuff in there. I don't want to have to pay for it twice.
That's a great point, and it's a perfect segue to the question I've been wanting to ask you, gentlemen, about transferability of skills from one bot to a fleet and then to deployment.
Yeah. And it's once you've taught one bot how to do something, they should all know. Now, that might come with some caveats. It depends upon your model size and whether you can jam all that stuff into the same model. And Phil is nodding because he agrees. It's just like, okay, get this thing over. The thing is, those weights are specific to that. And I've got another one that does something else. And can I merge those two together? And are those models going to be, and some would argue it might be better, because now the fact you can do this skill and the other skill, they complement each other and you're better, or it could be that it dilutes. We don't know what it is.
Well, physical intelligence, the model company certainly believes that training a single model on many different types of tasks ends up making the entire bot, any one single task, better. That's been their mantra, and they've published papers showing this. The interesting thing, I mean, you're going to run into, at some point, you're going to run into chip limits and memory limits. How much compute power can you stuff into a bot that is running on a battery? And because that is Figure and Tesla's, that's what they want to do. They don't want to have a supercomputer, right? The data center in the background communicating with the bot to do ordinary things. They want the majority of the compute to be done on the bot platform itself. And to some degree, that's why some more advanced functionality and more performant bots are just going to have to wait for chips, the better chips to be built, right? So Tesla has an AI4 chip right now into their Optimus bot, but the AI5 chip, which is going to come out mid next year, is slated specifically for Optimus. It's not even going to go into cars. The AI4 chip is being used in cars right now, and Elon has recently said, hey, we're going to keep on using AI4 for the foreseeable future until that process node basically dies, because why would we change? It's good enough for full self-driving. It's good enough for robotaxi. So why would we upgrade that?
Yeah.
But for the bot, they need something more powerful. They need the AI5 chip, and probably the AI6 and AI7 chip when you get down to it. Because it's a lot more complicated doing what these guys are doing than driving. And it's interesting seeing what the differences are, right? So driving is absolutely a safety critical thing. So I mean, that's paramount is safety and driving. And yet it's working fine on a fairly inferior chip, the AI4 chip. But it's because the degrees of freedom, the number of things that a car can do, is relatively straightforward. You've got a steering angle, you've got a brake, you've got an accelerator. That's about it. That the brain has to figure out. The complication with a car is it has to figure out really quickly because it's driving at 70 miles an hour. So it has to figure these things out quickly. Whereas but on the other hand, here we go, another bot switch right now, real time.
Right. Exciting.
Calibration thing.
I think it's a
right.
bot switch, or no? I mean, it's another calibration thing. You're right. It just tried to figure out what its purpose in life is.
I think it has Tourette's.
But anyway, so the differences between a car AI. The interesting thing with a bot, though, we say it's not running 70 miles an hour, and it's not. But it still needs millisecond precision on all its movements right now, right? As in a way, its fingers and its thinking is running 70 miles an hour because these movements are so small and so precise. It needs a lot of processing to be able to do that.
Yeah, and we were kind of talking about this before, Phil, is that when they talked about the AI5 chip, it was almost like, is this imperative for Optimus, or can Optimus do what they want to do before the AI5 comes out? And
I think they need it. I think they need it because right now the NVIDIA Jetson and Orion, basically the inference chips that the robot makers use, are a lot more powerful than the AI4 chip. I mean, the current NVIDIA line, because Figure is using the NVIDIA.
Yeah.
Basically, all the other robot makers use NVIDIA chips. Only Tesla has their own unique inference chip, and it's an old design. And it's been passed by NVIDIA, a couple of years ago. So Optimus absolutely needs that AI5 chip, I believe.
Okay, and that's concerning because they just did the tape out, which means when do you think would be the soonest they would actually have some working versions that they could at least begin to test in Optimus?
Well, they would be able to test it maybe at the end of the year, let's say beginning of next year, for any small quantity. But Elon's not talking about production volume until summer of next year. So a year from now, they'll have production quantities of it.
Yeah.
So they're going to have to be getting by with AI4 to do what they're doing, which kind of gives you an idea of timelines, right? So that's where, and that's what Elon said. He said, okay, so first use of Optimus in their own, well, actually he said external factory. So the first use of Optimus in an external factory would be at the end of 2027.
Mm-hmm.
So, people who are thinking, oh yeah, these bots are coming right away, and Optimus bots in particular, no, they aren't coming right away. They've got a lot of work to do yet.
So can you kind of simulate that chip?
That's what I wonder. Can you train without it? How much training can you do between now and then if you don't have the chip?
Yeah, or can you run like a simulated AI5 chip in another computer, or do you need the actual chip to kind of assess what it and kind of what can it do? What's the capabilities of it?
That's a good question. Tesla is unique in that I know for full self-driving, they actually use the AI4 chip in their training computer. They're actually training on that chip as well as inferencing on it in the cars. And the reason they're doing that is so that there's no training to real world difference going on. There's no, it gets complicated as far as quantization and turning floating point integer use and all this kind of stuff. But the point is that they absolutely use the AI4 chip right now in training even. Having said all that, there's a lot of training I believe they're going to end up doing in simulation, right? This all goes back to Elon's fixation on Grok Imagine, which is their video generation model. I think they're going to do a lot of simulated training on the supercomputers using Grok Imagine. So yeah, I think they'll be able to do training. I think they'll be able to do useful work. I mean, they're going to be building Optimus this summer in the new line. It's still going to be all R&D, right? It's going to be all, let's see what we can do. Let's see what happens. Let's see what the problems are. Let's see what the issues are with training.
Yeah.
It's going to be R&D. It's going to be R&D until end of next year.
Yeah, I think there's still a lot they'll be able to do with AI4. There's not all the things that they would really want to do. They'll probably be able to do some stuff, maybe some limited things in the factory. It just depends. Again, it's coming down to low-hanging fruit where something is pretty simple to be done as opposed to something that's very, very complex.
So it's an interesting question. Can an AI4 chip and an Optimus do this particular task that we're witnessing right now? Do you need something of the NVIDIA power that we're seeing? That's an NVIDIA chip running in that figure. Do you need something that powerful to do this quickly? Or will an AI4 chip just run out of compute capacity and won't be able to do this? I don't know the answer.
Yeah. Roy, you have Elon's email, right? Maybe we can invite him on.
Yeah, I wish I wish we'd gotten this question a bit earlier. I just got off the phone with him.
Oh, darn it! It's about the China trip, right?
Yeah.
At least you and me, Scott, has gotten.
He's still not sharing. He's still not sharing with us.
Yeah. Okay, so a couple of interesting questions from. Let me just bring this up, and apologies again, Scott. So
that was all sarcasm there for anyone who thinks we have his speed dial. No, we don't. I've learned an accent. People
being sarcastic.
There's a certain percentage out there that do not get sarcasm.
it's just okay. So Listic 9392 apparently has some background in working in this particular function, sorting stuff, and says one fun thing about packages sorting is that you never know the weight.
Yeah.
It can be half a kilogram or 30 kilogram what you're picking up, and you can't tell by looking at the package.
Yeah.
And
I mean,
there was
probably a little bit. I mean, depending on the size of the package and how it's rolling down the conveyor, you could probably infer a little bit that, okay, this is going to be a 30 kilo or a half a kilo. There should be some kind of range that and I guess the bot could learn that as well. Like what are the dynamics of this box? It doesn't shift at all on the conveyor, whereas the other packages are rolling. Perhaps can for a little bit, but it needs to react very quickly to.
Yeah, and this was the earlier comment, which I found really interesting. So I do have to say I worked a little bit in package sorting, and these packages are all more neatly labeled than I came across. Packages can have multiple labels on multiple sites. That's a very valid point.
Especially returns. There are labels all over the place. Someone's doing a return. So I just want to do a shout out again to Derek. He finished his procedure for the day. So Derek, thanks for being able to join back. Basically he's going to be bored otherwise. He wanted some stuff to see. So all right. Hope you're doing well. Rest up. We'll try to entertain you.
For your viewing pleasure, Derek.
Yes.
I'd also like to make a shout out to Figure in general, because they are unique in the robot space for actually showing us stuff like this, right? Nobody else is really
warts
doing
and
live.
all.
Warts and all. Yeah. Right.
Warts and all.
We're picking this apart and we're saying, oh yeah, these packages, this is a demo facility and blah blah blah. But they're showing us stuff, and nobody else is showing us stuff like this. So it's impressive. I'm impressed by Figure.
Yeah. Now, a lot of the things they're trying to do, they're trying to do a 2-for-1 here. One, they're trying to improve their AI, get this thing overall better, but they're also trying to validate the hardware. They're trying to validate the whole system of going on there and see if it breaks. And things that Brett has said is like the hardware doesn't break often enough, so they don't know where the actual stress point. And the only way you can do that is you just need hours and hours and hours. So this is running 24/7. They're going back and forth, and of course they're trying to test out the different schemes that they have of the robots swapping out. And I think there's more than this. We'll find out later, but I believe that there was like more than one sorting station that they have.
So to play devil's advocate, is this any different than what we saw last year or whenever they had the long recording?
I think the difference is this is live, and that one was not. That was only 1 hour. This is going to be 8 hours. That was Figure 2. This is Figure 3.
Oh yeah, that was Figure 2 as well.
Yeah, and I think the speed is also a little bit higher.
Oh yeah, speed's a lot higher. But the impression I got, Scott, correct me, but the impression I got is that 1 hour demo, that looked like a customer facility.
I think it was still here. I think it was here. We'd have to double check, but I believe it was here.
The variety of packages was certainly different. It had more variety of packages than what we're seeing here.
It's possible. It's possible, but I'm not 100% sure if that was it. It is because I think they may have done those tests.
Okay, I have a surprise guest. Chris Paxton is in the house.
Oh, hey, Chris.
Hey, how are you doing?
He's been watching us for like the past hour going, these guys have got it so wrong. He's got to come in and fix a few things.
All right. So for those of you who don't know, this is the dude from Agility. Chris, how's it going? What are you making of this?
I don't know. I love seeing it. I think it's I was watching it. I've been watching it on and off between things, between meetings today, and
Yeah.
I think it's human speed, right? It's good. What do you guys think? What was the take from everybody?
Yeah, no, it's impressive, and it's impressive that they're doing it. I would like to see more, humanoid robot makers do this kind of stuff. Actually show us what's going on. Show us what your capabilities are. And in particular, I would like to see, real world customer deployments. And we're part of the reason I think that some robot makers don't want to do that is because they know that their robot isn't perfect, right? It doesn't match up to sci-fi's imagination or the public's imagination of what robots could do. But those of us that are in the know that AI robots are still relatively rudimentary, and we're very forgiving. So if we actually see real customer deployment videos, even if it's just a 5-minute video or whatever, it means something.
Yeah, I mean, I see. Like, I love the minutes like that where it actually does mess up for a bit, right? Like, we know, like,
Yeah.
I feel like I'm someone who's in the field. I actually like seeing that kind of stuff because, like, I mean, it's gonna mess up, right? It's nice to see it actually handle it elegantly, and yeah, right.
What would the Latin be? Error robotum ist, or what it's the... To err is human, to err is robotic.
Yep.
Maybe I wonder if because you don't even see labs doing this. I mean, real research environments in a university setting where it's not as much at stake. I mean, they should be worried about investors backing off or coming in, and so it has to be a lot of PR into this. But aren't they afraid of kind of showing what they have? Because I get the feeling that a lot of other companies, they want it to be very, it has to be a perfect package that they show off. They don't
Well,
dare.
I think there's a lot of work to do with it here, like to get it to work this reliably, like to be able to run it for 8 hours, and then that's just.
So
Do you think it's a hardware or the software or both?
I mean, it's everything. If any single thing goes wrong, it breaks, right? You got to get it out, like there's all the data collection, all the testing, all the hardware, there's lots of things, and it has to work for 8 hours. Or, I mean, there's people have done it. Like there's the video of the coffee that Pi did. Like there's a few academic papers that have really cool long running demos of at least a few hours, which I think is quite a lot of work for just a couple grad students. But so it's getting more common, which I think is really cool to see. But yeah, you definitely don't see a ton of it.
By the way, Scott, for those watching and wondering who Chris is, please, would you give us a lowdown on Chris? And shout out to Chris. He's at Chris_J_Paxton on X. Please follow him. He does a great breakdown with podcasts with a couple of others. And I absolutely love his work. And of course, Chris is with Agility Robotics. So, Scott, please go into the weeds with who this dude is.
Well,
I think there's just one word. He's a legend. He's well known within the community, no doubt. Oh no, he's
camera shy.
Yeah, well, a little bit camera shy, but no, Chris is definitely known from the standpoint of he does a lot of research in the area of AI and has really cogent takes on a lot of different things that he sees. And sometimes I forget that he works for Agility because he a lot of his takes talking about everything else are all very, very positive. So he's like an overall cheerleader for the industry, and he doesn't really take sides. He'll show out what he thinks is impressive and also point out where progress has to be made. So I think it's kind of nice to have someone like Chris in the community who is always kind of very upbeat, but still realistic about what the challenges are, but not really negative about it. I mean, you can be really negative about the challenges, or you can be really positive. It's like, this is what we have to do. I mean, we look at the progress we've made and what we have to do to get to the next step. So yeah, he's definitely a treasure and well-known. Anyone in the robotics community definitely knows Chris.
Yeah. I was hoping to ask him the question about transferability of skills, but well, maybe the next time he joins us.
Yeah, yeah. I mean, it's the way I kind of look at it is our phone. We have all these apps that we can download on our phone, but we know at some point we can't download them all. You know, we have to make that choice. We have to make space for one or the other. And it's going to be the same thing with these robots. Is they're going to have like a foundation layer where there's like a lot of very basic things they can do. And then there's going to be maybe some super skill set you want to put in that you're going to have to say, I'm going to have to kick this particular one out and load that particular set of weights in. And it's going to depend on what the architecture of these things are going to be in the first place. So I don't know how easy it is to just swap out your weights. There's going to be a lot of security questions there. It's like, whoa, wait a minute. You know, you're going in here and fundamentally changing my robot because you want to bring it in. So there's going to have to be something like the App Store where everything is going to screen to make sure it's not malicious in any way. It's able to do exactly what you want. But I mean, that's the nature of the beast. Is there's a limit, and you know, even as humans, we can learn lots of skills, but if we don't keep using those things, those skills atrophy for a reason. We only have so much room in our head.
I agree, Scott. I think there's going to be the equivalent of an app store, or you basically ask your bot to do like, I don't know, gardening, weed pulling. So it says, yeah, okay, just give me half an hour while I download the weed pulling app, so I know what I'm doing. I think something like that could very well be part of the architecture. We won't know for a little while, but it's not hard to figure out not hard to conceive that would be part of it.
What I would like to know is, when can I have a master-slave connection through Neuralink with my bot?
Yeah, I don't know if you want to. Do you really want a hole drilled in your skull?
Yeah, I mean, if I can think something.
Evidently, the ancient Egyptians did. Remember?
Yes.
There was one of these things. Literally, the hole in the, I need like a hole in the head. There literally were these rites where they gave you a hole in the head.
Yeah.
And there's all sorts of questions about what that was. Gustav, I think some of them said it was an actual necessary medical procedure in some cases that released brain swelling.
In Swedish, I don't know if the English name is the same trepanation, where you kind of to relieve the pressure after like a hemorrhage in your skull. I'm not sure that was the case, but that's what some people suggest. And I think that at least people survived the procedure. At least you could tell that the bone had kind of healed a little bit. So yeah, why not bite the stick and drill a hole?
Okay, here's an interesting question, and I wanted to pivot into this a bit. Is the model compute local or stream? Jiaqing Li. Sorry if I butchered your name.
I think he's asking whether or not the model is running on the bot, or whether or not it's running in the cloud, essentially.
In the cloud, yeah.
As far as we know, it's running on the bot. These models are, in fact, I'm pretty sure Brett said that in a recent interview, that these models are running on the bot. The only thing that happens in the cloud is the training, and then the new models are downloaded to the bot whenever the new new model occurs.
Which brings me to the follow-up question about, and we touched upon this in the past, you did in particular, Phil, about the AI chips that go into this. How much of onboard compute is going to happen for inference and versus for training? And how do you see it evolving with successive generations of chips, AI chips?
Yeah, I mean, if you think about it, so think of Grok as an example, right? You're interacting, you're talking with Grok. Let's say in your Tesla, you're talking with Grok, or maybe on your desktop. That takes a cloud, right? Because that's a big model. It's a large language model. You're not going to fit that onto a robot today. Can you fit it onto a robot in 2 years from now with 2 years worth of chip evolution? Hopefully, or a slimmed down large language model, a slimmed down Grok, one that's been shoehorned and properly made efficient to run on a bot. So the goal for the humanoid robot industry is to have the bot always be running locally, and the only thing it does in the cloud is for coordination kind of stuff, or maybe it literally asks a large language model, how do I how do I fix the brake caliper on a bicycle, that my human is asking me to do? Maybe it has to look up YouTube videos for that, just like a human would. So the goal is for the bot to know everything now, but then the question is, how big a model really can you run on these things? And it's going to keep evolving year by year. NVIDIA keeps coming out with a new inference chip generation every year, and Tesla is committed to doing that too. So these things will become more performant over time, and that's one of the reasons why I'm a little bit more pessimistic than others on when we're going to see these things in the home, because that's going to take a very, very performant chip. You're really going to want like a Grok level large language model kind of stuff running on the bot itself at that point.
Mm-hmm. I mean, the whole teleoperating version that 1X is planning, I don't see that cutting it for the big markets. I mean, maybe a few individuals are okay with it being teleoperated in their home, but to get it mainstream, you need it to be on the edge, like an edge compute situation.
Yep. So
sorry, go ahead.
I did this post maybe 6 months ago that the AI bot industry and the humanoid bot industry in particular is firmly in the fake it till you make it phase of Silicon Valley startups, where the functionality isn't there yet, right? They can't build this product and sell millions of quantities of this product today. They just can't. There's a whole bunch of things that they're still working on. It's still firmly in R&D, from the hardware, from the hands, from the chip running in the bot, from the AI model. So we're still looking at an R&D industry.
Yeah. So it was an interesting question. I'm going to try and find it, but essentially it was the viewer was asking us which bot, in our opinion, is the BlackBerry equivalent, and which is the Android or maybe the iPhone. Here we go. This is from Tony Sow.
I mean,
too early. They're not production yet.
I mean, if I had to pick today, I'd say the BlackBerries, and maybe Scott will agree, like the Roomba, or like what people consider really early robots in our home, like the vacuum cleaner or maybe the lawnmower that kind of runs around. And then when you get the humanoid, then people are like, why would you need a humanoid bot? You can just have a specialized vacuum cleaner and a specialized lawnmower. No one will ever want to check their email on a phone or whatever. I guess you could do that on a BlackBerry as well. But yeah, I'd say that is the case. But it's, as Phil says, it's way too early for the humanoids.
Maybe the best way is to say, like, they're all kind of BlackBerries right now. Whereas I assume the analogy here is that BlackBerry was kind of a dead end and ended up getting replaced. So they're all going to be replaced. They're all kind of in that very early experimental prototyping phase where they can have a little bit of marginal utility here and there, but they're not going to be there yet. So the one thing we forget is that with all the hubbub about this live stream happening today, one of the last things Brett did last night after setting up this live stream and getting that done was he did like the design review for Figure.04. So he's already talked about that. They pretty much locked that down. They're getting ready to get the parts for it and start building it and doing the testing. And said, it'll still be a little while before you see it. The same with Figure.03 last year. So we first saw Figure.03 a little bit around this time last year that there were hints of it. But it was still months before it was revealed because of all the training and everything else that still has to go in to make sure it's reliable. So you already see that the machine we see doing this is deprecated, almost by definition right now. It is deprecated. And we've heard the same words coming out of, Elon is like, as much as we're excited about V3 coming, is that it's soon going to be replaced by, their V4 and their V5 as well, with the idea that, yearly updates, yearly to 18 months, it's somewhere around there that everyone's going to be doing to iterate. before you get to that level that you would finally have the Android and or this, you know, if you want to call it the Android or if you want to call it the iPhone, and it will be iPhone 1. Okay, iPhone 1 was pretty interesting, but it still took a few years before, and what was it, iPhone 3, when people actually started to adopt it. They realized, hey, this is actually better than the BlackBerry.
Yeah, which belies the robot as a service business model, right? I mean, I think initially that's going to be very attractive to people because they'll get an upgraded robot every year, more or less, right? And it's up to the manufacturer, obviously, to upgrade the robot or not, but they will, right? Over time, they will realize that the existing robot just doesn't cut anymore. They can be more efficient or whatever.
So here's the thing. Where in the timeline, at what point do you see the hardware iterations slowing down? Because the software / skills will keep updating, and then those could be over-the-air updates, just like a Tesla car.
Never. I mean, cars are. I mean, look at cars. They've been in production for 120 years, and we're still getting constant. I mean, not yearly updates, but through the industry, we're getting yearly updates. I mean, if you look at the entire industry, every year there's something new in a car. And that's a very mature technology. So, you know, I think robots are going to be iterating for quite a while.
Yeah. It's, you don't appreciate it until you get into a 10-year-old car. And you go, wait a minute, there's no screen here. There's no backup camera. You know, it's like all these things that are missing that you're expecting to be there. What? You know, I need a key. You know, it's like, so there's always going to be, you know, the question is when they're still of like high enough utility that they're going to be around for 5 or 10 years. That they're still, because I have a feeling that most of the early stage robots, when they actually go out in production, will be 2-3 years max before they're, you know, even then maybe it's a year and a half. So that comes down to the ROI calculations and whether its utility is enough that someone is willing to pay $100,000 a year, and that whoever is doing his robot as for services sees that covering their costs enough. But one thing's for sure is I'm not going to pay for a robot for $100,000 and have it be broken by the end of the year and have to buy another one for the house. You know, we expect these appliances that we're getting to get. I mean, we used to hope 10 to 20, but now when I get a dryer, I hope it lasts 5 years. You know, dishwashers, I'm hoping it makes it to 3 years. So hopefully the reliability is a little bit higher than that.
Yeah, I mean, if the development goes as quickly as we've seen the last few years, both when it comes to the software of AI and also the engineering and the mechanics, I mean, we haven't replaced the type of worker, the human worker, but if next year there's a bot that is twice as fast and twice as capable, of course you would want that straight away. You would not keep the bot from last week if it's not up to par. So, but will they be totally worthless? Do you see there being a second-hand market for like this bot, for instance? In 2 years, it will be no use. But do you think there will be like it will be good enough for lawn mowing or UPS or?
I mean, I would think so. I mean, there's always going to be some utility that you'd be able to find for it. And again, if you kind of look in the Star Wars universe, which I think is almost kind of predictive in a way, that you had a lot of those different robots that were very specialized, you could tell were kind of antiquated, but still quite useful. It's always going to come down to is like at one point, does, you know, the maintenance of the robot and everything else it really has to go to the scrapyard. And
hey guys, yeah, sorry, I gotta go. It's actually like well into lunchtime now, my time. Here I am on the West Coast, but 2 hours and 45 minutes. That's a record for me on a live stream. Thank you, Royden, for putting this together, and I appreciate the chance.
Such a pleasure to have you. Thank you so much, Phil. And I'm looking forward to more of this with you and the gang. And if you are tempted to come back, please, anytime. We're probably going to go to the end of the show. if you're bored, just come on and we'll hang.
Okay, well, okay, and maybe in an hour or an hour and a half. I'll try again. I'll see if you guys are still here.
Yeah. I mean, hopefully, Dr. Know-it-all will be joining us in a few minutes. And
oh, nice.
Yeah. And I think we're trying to work it out with Herbert to see if we can co-stream. So that'll be wonderful as well. So
that'll be nice. Yep. And then
back.
John is going to try to help us stick the landing. I'm hearing a rumor that maybe we will have another special guest in maybe 45 minutes or so, something like that.
Oh, wow.
Yeah.
Well, in that case, I'm going to have to check the live stream while I'm gone.
Yeah,
see you guys.
Yeah. Enjoy lunch. Yep.
All right.
So this guy has been going for close on 2 hours now. So in another 2 minutes, it's at least 2 hours. So I'm not sure it will go.
Okay. So every now and then it's sort of funny. It kind of gets it and then gets. It seems like the big square boxes maybe are a bit confusing because there's no real clear up or down. Whereas when you have like the flatter boxes, usually you kind of know where everything's going to be, and you always assume it's like either on the top or the bottom. But this case can be one of those 6 sides.
And sometimes it only checks the size without the tag, and then decides, oh, the tag has to be on the other side because I can't see it, unless it kind of leaves it on the side.
Here's an interesting question, and this is from Mark Donegan. Do you have insights into the training methods used for this routine? Is it RL, simulated environment? Any idea on pre-training data size?
Stick around. Maybe we'll be able to get a good answer to that question. But I believe the training methods, the first thing they had to probably capture the data, and I assume maybe egocentrically, to get enough to then be able to put into the simulation with some sort of RL reinforcement, and then a little bit of cleanup afterwards. So this is running Helix 2. So last year I think it was running Helix 1. So this is now running Helix 2. And actually, when John comes on, he might have a pretty good guess of how that's done. We can double check with him.
Yeah, I'm going to try and cycle through as many comments because it's a bit of a backlog. There we go. So this is from Alan Sanchez. Think about it. They could break down any task to a simple station for the bot and boom, fully automated assembly line. Well, yeah, I mean, technically, but it depends on the complexity of the task and how well the bot is trained on it, right?
Yeah. And some assembly lines you have really basic things. I mean, there's like almost nothing, one verse, and others where there's quite a lot that has to go on that is kind of beyond the dexterity and capabilities of some bots right now. They're more of these long horizon ones. So you can always find an example in a factory where it literally is someone just like almost doing the same thing again and again and with very little. And then others where there's maybe a couple of minutes where they actually are doing quite a lot of different operations. And those are a bit more challenging for many of the bots to do right now, partly because there's a long horizon involved in there, and also partly because of the dexterity. So again, I want to look at it as that these bots will become useful before their general purpose. They don't have to do anything. They just have to be able to do enough in particular tasks. And the other thing to remember is that we have job shortages everywhere. And right now, there's a lot of competition for labor because there are more openings than there are people to fill them. And once the bots start to go in here, that means a lot of those people are now available for these other jobs that we couldn't do. So we don't have to worry about this contention between we've got this job shortage and now we can start to use them to do something else that may be of actually much higher value because the person is more capable than the robot. And so they can kind of move over to there. So that's one of the things that can kind of help is that you get what they call kind of this guns and butter kind of thing in economics that you can produce one or the other, but you can't produce both. And you've got some production possibilities frontier of some balance between the two. Well, as soon as you increase the production of butter, you can all of a sudden produce the production of guns without having done anything different. And vice versa, because what that means is the resources that you're deploying for that other one, because it's more efficient, you can now redeploy to the other one.
I have to go say goodnight to the kids. I'll be back in a few minutes. I'll leave you with my
All right.
fingers.
So right, it's just you and me. I don't know how we were able to kind of keep the conversation going without Gustav.
And the hand.
And the hand.
He's left us with a hand.
He definitely has. Yes.
Yeah. So I think we've got a lot of comments to run through, and I think there's a whole question about UBI that keeps coming up repeatedly, because there's a lot of obvious concern about jobs being lost, and we've addressed this earlier in this live stream. So I think it's going to be human bot collaboration for the next few years at least.
Yes. Yes. And
we have Dr. Nodal in
Hey!
the house.
I couldn't let Scott sit there for the entire time. So, and Gustav's here. So cool.
yeah, whew, boy.
Yeah, Gustav's
Yeah.
hand is here for the moment.
Yeah, we got someone who's actually more loquacious than me. So
I don't know about that one. I
my
think
voice
that's
gets a rest here.
I brought some water with me. So
And John, which one did you bring? Show
I
the
brought,
logo on there.
I brought the summer meetup. There we go.
Yes, there we go. Show it right.
There we
Show
go.
it again.
This is from 2025. Obviously, 2026 hasn't happened yet, but yeah, this summer in Michigan. And weirdly enough, Scott, I ran into some people at the parking lot at Costco who were interested in the Cybertruck, and they we got to talking, and I said, "Oh yeah, it's going to drive us up to Michigan." And they said, "Wait, the guy said my brother lives there, my sister, one of the two of them. Anyway, but his sibling lives in Muskegon. So of all the crazy things,
okay, so maybe they'll come out. And
yeah, what a small world. I was like, well, clearly they have to come out.
So John, I had a Cybertruck parked in my driveway yesterday.
Not yours.
Not mine.
Okay, whose was it?
It was actually Tesla service.
Oh,
because they came over to do the tire rotation. It's really nice that when you want to have like the tires rotated, rather than having to drive in the shop, they come to you and do it in your garage and check out a few things. Change the HEPA filter. It was great.
Yeah, they don't do that for me. I have to go all the way into Atlanta. It kind of sucks.
Yeah, no, it's nice for me that I don't have to worry about that.
I like that you left your little. Just leave the hand there. Hey, Scott, how are you?
So we'll be at the summer meetup, and it's going to be lots of fun. We're going to be doing some STEM kind of things, talking about robots and how they work. If anyone is sort of interested in knowing,
that'll be awesome.
Yeah,
cool.
Much more exciting than watching this.
This actually, you said this is spellbinding, right?
It is. It's weird. I wrote to Scott this morning after it started about 15 minutes in. I said, this is kind of what I do is I go about my business and then I stop and watch for a while, and I just find myself just sitting there staring at it and just really enjoying. I don't know why.
ASMR for the eyes.
Yeah. You know what it is? It's a lot of people that they will put on that YouTube video of just showing a fireplace.
Yeah.
Oh yeah,
it's kind of relaxing. Yeah. It's kind of like one of those.
Maybe I feel vicariously
packages.
I feel vicariously like I'm actually accomplishing something just watching it. I'm sorry. Also, is he not Sisyphus? I assume that
yes,
there's
I already used that term.
Okay, sorry.
You remember one of John's advanced degrees is in English literature.
Yeah, exactly.
Yeah.
I do know my Sisyphus from my Scylla and Charybdis. There we go. It even
rhymed. Bravo.
There we go. Very nice. So yeah, I have a feeling we're going to see a lot of these packages over and over and over and over and over again during the day. So since I'm coming into this, have they swapped out any figures yet, or are the two in the background?
Yes, they did early on.
They did early on, yes. Yeah,
So
the 56 something mark.
I think what happened is that these things are just running 24/7.
Right.
And so they set up the live stream, and the bot probably had already been running for a while.
Yeah.
And that one swapped out at the hour mark.
Okay.
But at this point, we've gone, another 2 hours? We haven't.
Yeah.
Who knows? Maybe it's another hour after that before we do it.
But I guess we'll get to know.
Stick around. Let's kind of find out where it is.
Yeah.
Well, if they did it at the hour mark, it might only be 3 minutes. We might actually get to see them swap out. That'd be cool.
Yeah.
Okay. Lost one over there. So we are seeing some failures.
Yeah. I saw one where it flipped the box the wrong direction. And
it flipped it like 3 times, and then it sort of decided not to. So this, the other bot I think was a little bit better. This one's been a bit aggressive. Sometimes when he sweeps with his hand, he almost pushes it off. It's like right on the rail. And
personality.
Yeah.
Exactly.
So there's an interesting comment that's come in, which is this is from Joel Alexander. Robot looks more repairable than a car. I think this is going to be an issue moving forward. Important one.
In many cases, they could be. From everyone I've talked to, this, it's really easy to swap out a limb. That many of us, so long as you have the spare parts. So they are designed for repairability in many ways. Maybe not down to I'll just take the actuator apart and fix it, but from the standpoint that you want to repair the bot and get it back out there, you can do it. And then whatever that part is that you took off, maybe you do additional service on that. But I think he's right. In many ways, everyone is doing a lot. Well, I'm hearing pushback back and forth. There's sort of some in the community that are complaining about they don't have like design for repair for a lot of different arms.
Right.
But for the most part, it's just swapping out a major component, as opposed to in the old days when you were like fixing a car, you would like just go down there, find like the one little part that was broken.
Right.
And then do whatever you can, where rather than just saying, yeah, I just need a new transmission, if there's something I can do there to fix it.
Yeah. So a little bit, maybe more like consumer. I managed to crack the screen on my phone recently, and they don't repair the screen; they just take the screen off and put a new screen on with the camera and all the other stuff. So it's more like that, where from a consumer point of view, it's just very rapid. They just swap the whole thing out.
Yeah. Now, in their standpoint, they're going to have an infirmary or botfirmary or whatever you want to call it, bots where they go when something is wrong to get the servicing done on it, and then it kind of gets back into the field. And then you imagine there may be some other techs that can go in and do a little bit more.
Right.
So there was a question just before you came on, John, about
John,
how do you think this is trained?
Yeah.
Oh, that's something I actually was thinking about, and I would assume human I mean, my assumption is all of the above. It's sort of human demonstration first, and then put it in a virtual world where it just does this, where you can have millions of figures, virtual figures, sorting virtual packages. And then, of course, they have to do the sim to real, though, because this is, I like, one of the things I like about this is not just boxes, it's a lot of soft packages, which is significantly more challenging than a box to sort because, of course, grip. I saw it like sometimes it would grip it and miss the grip. So yeah, but I mean, but it also retries. It doesn't just give up. There's a fail. Yeah. So I really, what I would really love to see would be a side by side with a human doing this. I just don't.
You want the? See, that one is okay. It missed it. It saw it was wrong, but couldn't get it. So you want the John Henry?
I do, but sorry, Gustav, what were you saying?
No, just that the speed is actually what's considered human-esque in this like 1300 per hour, which it's doing. But then the figure rate, I'm not sure if it will be acceptable in a human to do.
Right. Yeah, that's the thing, is I just don't know what we're talking about in terms of like what it would be helpful to calibrate that and to have that sort of John Henry.
So notice how confused he was there, he wasn't sure where the label was and wanted to double check.
Right.
Now, in some cases with the soft packages, it's like, I know the label's down. I don't have to check it.
Yeah, exactly.
When you get a bot that's equal-sided like that, you have no idea. If it's a flat box, it's either on the top or the bottom, usually.
Right. Yeah, he just shoved that one right on and just made it. But I mean, that's clearly taking human learning or something along those lines to get to that state, because the bot's not going to know that automatically. That's a human bit of knowledge. It's like if we have a flat box, it's going to be on the top or the bottom. And so if you don't see it, you can just shove it right on through. So clearly it's learned that from people.
What'd you say? Just shove it?
Just shove it. Yeah, just shove it.
So John, I got to, as a literary major, a lot of people in the audience may not be familiar with the tale of John Henry. You want to tell that?
Oh yeah. Well, I mean, oh gosh, you're gonna put me on the spot. I know that I don't know all the details anyway. He was a steel driving man. That's what I remember. And it was during the construction of the railroad when they were working on the steam powered, I believe it was very steampunk. It was a steam powered spike driver on the railroads. And so John Henry famously went up against this thing and actually beat it, and then died of a heart attack and passed away. So
it was the classic man versus machine kind of thing.
Yeah.
Where that was he represented all of humanity at that point and gave it his all.
He did.
And when we say the John Henry example, it's sort of what we're referring to, except we don't want the person to drop dead of a heart attack afterwards. But
I think OSHA might have something to
really
say about
what
that.
it's like.
Yeah, exactly. yeah, I think that OSHA might have a word or two to say if he dropped dead down the line. So, but it's fascinating because like, how does this work in real life? Do humans? Oh, I'm curious what he's going to do with this now. Is he just going to let that? Oh,
okay, that one fell off.
So he didn't catch it. He's very, very hyper focused.
Yeah.
But I'm curious whether humans, obviously, you have to take a break. I would assume every 45 minutes or so. Do they put another person in? Is there like a rotation, or does it just sit idle for 15 minutes?
That's a good question. Whether, I mean, the humans get breaks. The question is, do they? I'm not sure if it'd be every 45 minutes.
Yeah, well, I mean, or some, I mean, whatever.
There's something usually what you see for what would be, I think, a 9.5-hour day.
Oh, wait, I think he might be switching.
No, he's recalibrating.
Doing the imaginary bike.
I guess he got calibration.
This is like a recalibration that'll happen.
Yeah, like, he's like, okay, what am I doing in my life?
Okay, did he fix that one? Yes, there we go.
He's questioning his existence.
Yes, exactly.
There was an old Saturday Night Live, skit from, I don't know, probably in the 80s or something. And it was Stephen King. And he was like, just typing away on a typewriter and just going nuts. And then all of a sudden he goes like, oh my God, I've got writer's block. What am I doing with my life? And he sits there for about 5 seconds and then he's like back to writing. It felt like that. It was like about that much time where it just had an existential angst for about 20 seconds.
So if we look at,
kill humanity, kill humanity. Oh, okay.
No, sort boxes, kill humanity. Sort boxes, kill humanity.
If we look at normal break schedules, that there will be somewhere in like you have like a morning schedule, and there'll be a coffee break, which will be about 15 minutes.
Yeah.
And then there'll be a lunch break, which will be a half hour, and then there'll be an afternoon break, and maybe there's another second break in there, but they're usually just 15-minute breaks, and you may go for like an hour and a half, maybe maximum 2 hours before that break happens.
Right.
That's what would be typical for humans. So that's the expectation here. And that means like if you're doing a battery swap or let's say a bot swap because of battery charging, that would be the key time to do it, that you schedule it around when the humans are doing it, assuming there's still going to be humans there.
Right. Yeah. So I guess the question in my mind was more along the lines of, do they just stop the line while the person takes a break, or does another person come in? Because if they stop the line, that means the robot gets, an extra 15 minutes to catch up if it's, say, a little bit slower than a human, but it's working the full time instead of taking breaks, then it sort of catches up. So, Scott's gone. Yeah.
No, the bot swap was really quick. It was under 2 minutes. So at least there was not that much downtime for the bots.
Okay.
So there was an earlier question about cameras. I think there's an array in the head.
Yeah. Yes. And then the new version has ones in its hands. I'm assuming this is the new version. It's hard to tell because his hands are moving really fast.
There's another one walking in the background there, a white colored bot.
Yeah. Wow. What a weird.
Going to see HR about the job.
Exactly. I don't. Wow. It's got to feel so weird walking around a building where the robots are kind of walking around doing stuff the whole time. It's very strange to imagine that. And yet someday, 5 years from now, it may be very, very common where it's just so normal that you don't think about it. I was actually talking to somebody, speaking of the Cybertruck, I was talking to the person about it, and he was asking me about full self-driving. And I was like, the weird part is it's so science fiction and so completely like, how can you imagine this? But yet it's completely normal. And I don't think about it when I just go out and drive now. So it's a very strange, where human beings are just so good at adapting. I think that's what it comes down to, is that we're just remarkable about that. So
non-US dwellers or non.
Yeah, sorry.
So I've only ridden in one once in San Francisco.
Okay.
Actually, it was like, even if you've seen it on videos, you don't really comprehend it until you're there. But as you say, it's been around for like a few weeks. Everyone will be like, yeah, this is normal.
Exactly. That's the crazy part. And the really weird part, I have to say, is a few years ago when we had the older versions, and I'm talking about my personally owned car, is when you're sitting in the passenger seat now, you don't even, I don't know whether my wife is driving or the full self-driving is driving. Like I can't tell unless I go over and look or something like that. But if I'm sitting behind the driver's seat with the steering wheel in front of me, there's that long, your brain is like engaged in this sort of driving mode where you're like, I'm supposed to be responsible for the car. And that's the hardest bar to like get over.
Well, that's a great backhanded compliment to your wife, of course, for her driving skills.
There you go. Exactly. Yes, there you go. So
if you can't differentiate between your wife and FSD, then oh boy, she is good at driving.
That's exactly right. She's actually what
Is
she
she
does.
watching brownie points for
Yeah,
you?
there you go, brownie points. She's actually in PT right now for her knee. So anyway, but otherwise I'd be getting big brownie points for that one. That'd be great.
Yeah. So had to take that call. My car's in the shop.
Okay.
Oh no, so they ended up taking it?
No. My second car.
Oh, the
battery issue.
Oh, okay.
Ice. It's like the third or fourth. I've had so many battery issues with this car in the past 12 months. You'll not believe
the irony. Of
yes, the irony.
So about the repair issue. I wonder when people will start anthropomorphizing, or whatever the word is. Like, if I have a bot that has been in my household for like 3 years. I will probably be sad if it gets decommissioned. Or do you think we'll ever go there, or will it always be like a second blender or something? Because my cat, I'm sad if my cat passes away. The same with the bot.
You take it to the vet, right?
Yeah. But if you kind of we just swap out his head.
So to add to that, have you really had a deep conversation with Grok Voice?
Mostly chat. Actually, but
just try it. It's pretty freaking crazy. Okay. it is, it vibes off you, and you can switch from one subject to another across the synapses as if it's so smooth. And I've caught myself thinking, oh my gosh, this is going to be so deeply impactful and transformative for society because of the way we connect with everything that AI is connected to. And to your point, when you look at an advanced AI with voice and a personality in a bot, is it a machine or far more than the machine?
Right. And it's a little bit hey, calibration boy. I don't, I think that it would really come down to the personality of the bot. So let's say that we had a Figure.04 in the house or something, right? So whatever the next generation is, and then 05 comes out, and you better catch up. So Figure.05 comes out. If you could,
is he about to cry? He looks like he's going to cry.
He's seriously having
yeah.
It's too much. I can't.
He's like, please stop.
Last year there was a situation like that in which it seemed like he just kind of panicked. Okay, what do I do? But now he's doing better. Okay, let's see. Does he get the box flip? Because sometimes he messes it up. He gets two at the same time. He's lucky in that one.
He got both.
This one, is he going to make it?
He's going to recover.
Okay.
I'm reminded of Lucy in the Chocolate Factory. Certainly, Scott, you must have already talked about that.
Scott, I need to ask you a very quick question, because we've just seen both hands used successfully to flip multiple packages at the same time. How much are the cameras in the hands coming into play here?
As
opposed to the cameras in the head.
I assume they're probably helping quite a bit. I would assume, yeah.
It's also possible.
This is what's going to be interesting is I wonder if the cameras are being used to see a label, because just imagine you put your hand behind, I see the label behind the box. I don't actually have to figure around and stare at it. But the thing is, if there's egocentric data, it's not learning that trick because people don't have eyes in their hands.
Yeah.
But I wonder if eventually it would be able to use that as kind of a cheat or a way to be a little bit faster.
I kind of wonder that. I was thinking that too, Scott, because I was noticing when it would flip it. But notice what it did. It did a very specific sequence of things.
That was interesting.
So it does this
how
thing.
Did it see the bottom? How did it see the bottom there?
I don't think it did.
It just realized there's.
Do you think it looked around and said? Do you think process of elimination?
Yeah. It saw what 1, 2, 3, 4. It saw 5 of the 6 sides.
It saw 5, but I'm not sure that the head camera saw all 5. I'm wondering if the hand camera came around and said, "Hey, there's nothing there."
Right. That is possible. that would be very advantageous for the bot because, of course, it could do something where it could just be like,
Yeah.
I see the label.
Yep.
I love the little flipping motion, by the way. That's very
it's
human.
really impressive. I mean, and as someone commented earlier, there's probably very little weight to these boxes. So if you would add like a loose, I don't know, 8-ball in there, it would be tricky for it. But
oh yeah, I was actually, this is the random thought you have while you watch this. It's like, did they go to a thrift store and just buy all the $1 shirts and pants and things? Like, did they just buy out the whole store so they could put them in these packages? Like, I don't know. Or did they go to Amazon and like just order them but never unpackage them? So they've got, it's just the strange. I'm like, you wonder how they set this whole thing up. But anyway. But you're right. Some variability of weight and definitely things that would move around inside the boxes would be useful to know. It's let's see if he gets it. Oh, there we go. Okay. All right, he got that. Nice. Yeah, I mean, it's his failure is mostly graceful, and I wonder what happens. Clearly, there is a failure rate. We have seen some of the packages that he's missed and have gone through face up instead of face down. And I wonder how that's dealt with on a real assembly line, or not a logistics line. Like, I wonder if it doesn't scan it, if there's just like a little thing it feeds it off to, that's like a fail feed. Now let's see how it deals with this yellow one. I don't think it sees. I don't think it like visualizes anything outside of the, and there it goes. So
the time is going to build up. There's easily 30 packages down.
Yeah, exactly. Eventually they're going to run out of packages in the on the conveyor belt. So, but it's interesting because it's so, a human would notice it and just very quickly like just flick it onto the conveyor belt. But it's clearly the bot has, it's got a very specific sequence. It like looks at it from 5 sides, and if it doesn't see it, it just puts it on. So,
and like if you overseeing the bots, in this case, you could have like 10 bots doing this, and one human just walking around, picking up the loose packages, putting it back on the conveyor.
Well, and hopefully eventually they'll figure out how to deal with this stuff, right? It doesn't, it just probably takes more training, where you do a whole bunch of those edge cases where you have them kind of falling off, or maybe if you miss it, maybe if you flip it and it flips over when it goes onto the conveyor belt, and you can reach over and grab it and flip it again or something. So, I just have a feeling they just have to do more training to get all that to work. So think about how much data this is. This is 4,377 iterations so far, right? This is, they just run this all the time, and they're just collecting this real world data. And of course they're seeing the ones that are dropping off the conveyor belt and the ones that are upside down. So very interesting.
Okay, so Brett had a post a little while back. Let me just bring it on screen so we can go through it very quickly. There we go. He says, few interesting details around the Figure.03 live stream. We previously showed this task running for 1 hour. Let me just blow it up a bit. Here we go, so you can see clearly. Today we're pushing for 8 hours straight. High odds something breaks. The use case is small package sorting. Figure.03 must detect the barcode, pick up the package, and reorient the barcode face down onto the conveyor. Robots have to reason purely from camera pixels. Human average, roughly 3 seconds per package. Figure.03 is now around human parity. The robots are fully autonomous, running Helix O2, the AI stack, our in-house neural network running entirely on board Figure.03. Example, AI inference is done on device, on the bot. Multiple humanoids are networked together and communicating with each other to maximize conveyor uptime.
Oh, cool.
The system is designed to run 24/7. All right. A robot will work until battery is low, roughly 3 to 4 hours. So that's the response we were looking for. Then autonomously request another robot to swap in to minimize conveyor downtime. It's a multi-robot coordination with autonomous failover strategy. If a robot detects an issue, it will self-diagnose itself. As an issue, it autonomously walks to maintenance and requests a replacement from the fleet. No humans in the loop. Wow, that's
crazy. Wow. That's so crazy.
Okay, yeah.
That's a lot of useful information, actually. Really, really.
Okay, but there's one thing he left out of his post. When did that post go out, Royden?
A couple of hours back.
Yeah. Oh, a couple hours back. Because he can put an addendum to that post. The addendum is if you want to learn more, join over the horizon at 4:30 ET, which I think is like almost 15 minutes from now.
Yeah, it's about 12 minutes from now.
Yeah.
Join what?
Over the Horizon with Royden D'Souza.
Oh, there you go. Yeah, that's exactly right.
Yes. So, I have it on good authority that Brett may be joining us in the next 15 minutes. So
wow.
he might have like 5 minutes.
This is going to be interesting.
But we'll have a couple of questions for him. Okay, we see another Figure 3.
That's pretty cool.
There.
Yeah, we need to. Wow. Well, suddenly I'm nervous. This was just like a just chill kind of a thing.
Yeah.
That is. I'm looking at.
This is going to be exciting.
Post. Yeah. So this is. So 3 seconds per package. I don't know. It's hard. It's really hard to average this out at this point, just watching it. I mean, you can go 1,000, 2, 1,000, 3.
John, it's 4,450 packages.
Oh, there we go. Yeah, that's true.
So,
although it's not so how much do we, that's
around 23 per minute.
Yeah, so it's about 3 seconds.
Yeah.
3 seconds, 23. If
Wow,
it's
that's right.
Post, I asked Grok what the average human speed was, and depending on the packaging and the facility, but in the UPS it's around 18 to 23. So it's human speed according to Grok.
Per hour.
Yeah, I mean, over an hour it was like 1,300 packages for an ordinary human. Right. And this is 3 times 1,300, so it's more or less the same. Yeah. And I mean, probably a higher rate of mistakes and
yes.
But yeah, I think that the 23 is pretty much what the industrial engineers will use as their number when you're designing, because people, there are going to be the exceptional outliers are there, but pretty much that's probably the norm. Then right there obviously will be people that be a lot slower, but you're just saying, okay, just assume they're at 23 and they can sustain that. Okay. So that's our worst case. You would design around that.
Right. And I think the other thing he said that it does not come as a shock to me, but it might come as a shock to some folks, is that it's running entirely on board, which it pretty much has to. If you imagine this thing with Wi-Fi connections up to the ether and having to get instructions back, there's no way it couldn't react to things fast. Oh, I think it just failed on that.
No, it got the package right.
It did. It must have flipped it over.
So now it's seen that, and now okay. Yeah. So those are the ones that kind of slow it down. So that's where it loses that 3 seconds.
Right.
That's a little bit. Okay, a little bit quicker. That it was able to assess where it was, but now those sort of allow it to pick back up.
Right. Yeah. Actually the soft packages, interestingly enough, are easier for it because there's only 2 sides. And it's a little bit, it can pick it up one-handed instead of two-handed. So it can actually do 2 tasks at once, as opposed to the box where you have to use both hands. The 2 hands is the coordination between the hands is quite remarkable too, by the way. Yeah. That's something that a couple of years ago would have seemed completely unattainable. Now it just does it over and over again. It's just like, yep, I got this, both hands. And then the downtime. So battery and multi-robot coordination, autonomous failure. I really, I don't know. I'm wondering what we should ask him, because I think the full autonomy with failover strategy is probably the most interesting. Is the fact that it does not need, it doesn't need a human to ever intervene. A person doesn't have to watch and go like, oh no, the battery's low, or oh no, it just had issues. I mean, we've seen it calibrate a few times where it's able to just autonomously, whatever, if it's drifted or something like that, it's able to autonomously get itself back to what would you call it, default state, I guess.
Yeah, it seems to be almost hourly. So I wonder if that's almost timed in there, or if it really is something starts to drift.
No, because remember that it did it twice pretty fast, and one time it was kind of facing the wall. So I don't know exactly what was going on, but it seemed to have a problem. That was a longer calibration than the previous one. So
do we know the loading or the charging time? How long?
I think it's about an hour.
No,
something like that. An order of an hour. Yeah.
So 2 robots would easily be able to handle this. I see that there's 3 there, obviously.
Yeah,
but
I think it's an hour to do a full charge. So normally they probably bring it down to like 10-15%.
Right.
And then they can charge.
Did you see it just smack that thing?
Just smack that. Yeah.
It's very aggressive. It's very aggressive. I like that. Yeah, we should definitely ask him about the training, what the training regimen has been.
Yes.
That would be really useful to find out. So, and also he's wearing his little gray uniform. So I would assume if he was working for Amazon, you could put a little Amazon like yellow reflective jacket on.
Plenty of nice uniforms, no doubt about it.
I guess that's one of the other things that's really upgraded about these bots over the past couple of years is they're thinking about them more as products and less as research platforms. Should we ask him about Figure.04 and see if he'll give us any Easter eggs? Because I know he's super excited about 04.
The only Easter egg was that somewhere in the background was a picture from a previous design review. But I think the design review didn't have anything in there, which is a previous picture.
I know. That's why I was like, that's a disappointing Easter egg.
Because there was a picture in there, but I think it was like a Figure.03.
Yeah.
Extremely blurry.
Right.
Yes.
Yeah, it was very, very blurry. So it also looked like it might have had pictures like previous. So it's like did one of those little things where it went back forever. All the design reviews forever and ever. So
yeah, I was trying to figure that out. It was that whole mirror thing. What I see.
Let's see. Where is that picture? That's gosh, he's posted a lot today. So anyway, but so it's very cool watching him go. So and I think I wonder if for humans the same thing is true, that the soft packages are faster, I would imagine, because you can do two at once, like flick at once, and the harder packages are take more time. So is it, Scott, you would know this, in a factory, is it standard for the conveyor belt not to have a railing on it? Because it seems odd.
I mean, normally they would. I'm not sure in this particular case. It may be that they don't actually at that particular facility. But normally you would probably put something on there to keep these packages from falling off. I'm not sure why it's not there. That could be a good question. Is it because I think it's a clone of the customer facility, and the customers may not have it there for some kind of reason. Right.
Yeah. I mean, it doesn't have to be a tall railing. It could just be like the one that's on the silver part. It's just odd.
Yeah. It doesn't have to be much. I'm not sure why you wouldn't, because I'm sure it's the same problem with humans as well. So you put it on there and it just bounces off, and why not put up a little guardrail? Right.
Yeah, exactly. So interesting. All right. I wonder. So you said it happened relatively early, within like the first hour it swapped out? Because I'm curious whether
6 minutes.
Oh, okay. So he's probably
going for a while already.
Yeah. No, but that means he's probably got another hour or so to go, at a guess. So
that's what I think. Yeah.
Okay. Yeah, I was hoping we could catch him. Like, I was like, if Brett was on when they did the swap over, that would be really cool. So
you never know. Maybe he will ask them to do a swap over.
Yeah. Oh, this is interesting. Okay, so so that's cool, because it doesn't seem to care about what happens on the conveyor belt, but it definitely cared that the feeder got kind of jammed up, and it kind of fixed that problem. It went in there, and that's interesting. Yeah, so it's like it's okay on the left, but it doesn't pay attention to the right. After it's done the sorting thing, it's like forgets about it entirely. So there you go, Figure. I feel myself rooting for it sometimes when it's having a problem. I'm like, come on, you got it.
I mean, especially the flipping of the boxes still gets me, or it's still quite impressive that it manages to like spin it almost exactly the amount of rotations to go to.
Yeah, that's true, because you have to press in a little bit, give it the momentum, just keep 2 fingers on it so it spins, and then repress again when you get to the right moment. That's all a lot of stuff that we don't think about, but that requires quite a bit of activity there. So, now I'm watching it. Okay, so I got Brett's post in this one, and I'm watching him go in like stereo now. The robot's going forever and ever. Let me stop that one. That's a little bit much. Very cool.
All right, so I just posted on X asking people to join in, because we're hoping Brett joins us in a few minutes if we're lucky.
Yeah,
yes, exactly. Yes, if we're lucky.
Fingers crossed. Human and humanoid.
Seems
That'll
to
be super awesome.
It's going to be crazy. There we go.
Do you put the index in front of the middle finger or not? When you cross your fingers?
Yeah.
When you cross fingers, yeah.
Index. Oh gosh, I think I do too. Is there a way to do it the other way?
I don't know. Can you?
That's
It was hard for mine.
Well, now we've got your hand model, so we can definitely
Finger
we can
crossed.
examine that. That's funny. All right. Oh yeah, that might get a few folks to come in and take a look. So that's cool.
Yeah.
Very
And
nice.
I think the humanoid hub may also join us. Devon.
nice.
Oh, that would be great.
Oh, that'd be
Yeah.
fun. Yeah.
Yeah.
That'd be really fun.
Yeah. So let's see.
Making room for Figure.
Yeah, exactly.
Yeah, I mean,
he's gonna get.
I think it's going to be relegated to the sidelines.
This is all.
So
very,
we're going
this
on
is very
3.5
impressive.
hours almost.
Yeah.
4,657, 58.
My goodness.
Yes, 58 now. That's a lot.
206 minutes. That's very impressive. That's
Yeah.
really cool. So Scott, why do you think 3 robots instead of 2? Just so that there's an extra, because obviously it can charge faster than 3 hours, so it wouldn't need to.
Oh yeah,
Is
I
that-
think you could probably do it in 2. I don't know if there's another station around there that they're going over, or that's one good question to ask.
Yeah. Well, I'm wondering if it's just at this point they're still looking at mechanical failure being a realistic option.
Yeah,
Where
yeah.
its arm could just decide to fail, and so you have to have a spare. So, have they ever talked about price for these at this point?
No,
I'm just thinking, okay, because I'm just curious, if these things are say 30,000 each, having 3 of them to do a shift is actually reasonable financially. If they're 100,000 each, then 3 would be pretty
yeah. I don't think you want to have 3 doing one task. That gets pretty bad. If you've got that kind of 5-hour battery life, about one. So the thing is, doesn't matter what the battery is. It always takes about an hour to charge, whether it's big or small.
I know,
It's
right?
just the way
It's like
so you would think, but it's much
car.
smaller than my Tesla. They should be able to do it in 5
Yeah.
minutes. Like, no, it's the same chemistry. Takes
Yeah.
about the same amount of time. Now, I think it might go a little bit faster than that, and potentially they probably could do some things if they wanted to get it, more supercharging kind of thing. But
Right.
just assume about an hour, 5-to-1 ratio. So if you have 4 bots and they're able to tend 3,
Yeah.
then you're getting down to a much better, more favorable ratio, whatever it is. And then the bots could cost, $100,000 or something like that. And you're getting enough utility out of it, especially if it can do more than one shift. So if you're running these things 2 shifts, the only question is this a job that has to be done for more than 1 shift or 2 shifts? And how sporadic as it is in the logistics center, is it an all day thing, or is it a feast or famine kind of thing? The trucks come in the morning and we get this backlog, and then by noon we're done, and then there's nothing to do till 3 o'clock, and then you kind of do it again. But there could be kind of pros and cons to that, because with this feast or famine situation, do you have people that are working 12 hours and really only doing 4 hours here and 4 hours off, and they have 4 hours off kind of in the middle of the day? That's really inconvenient. They didn't have to have 2 shifts of people to bring in. The robots, you might be like, if it's 8 hours over a 12-hour span, that works a lot better for me than trying to hire for that.
Right, exactly. And I could also see it being that that the human might get assigned a different task. They're like, okay, so the trucks come in the morning, you sort for 2 hours, and then go off and do
something else.
Something else, right? So so that you would. But I mean, that's. I think a lot of people ask this question of like, well, why not just have a robot arm that just sorts things, right? And so you could do that, but if you have a feast or famine sort of situation, then a humanoid robot could easily be assigned another task when you're in a famine situation here. And that's something that your robot arm is just going to sit idle in the meantime.
Right.
So,
It sits idle, but depending on how you look at it, you're paying it the hourly wage when it's idle.
No.
I mean, in a way you kind of are, because that's CapEx you need to be deploying somewhere else. From the standpoint, but if you hire someone and you literally have to pay them for the 4 hours they sit around and do nothing while they wait for something else. Then you're like, oh man, so I could deploy that a little bit better. So usually what you're doing that other 4 hours is like you're trying to find something for them to do. As opposed to something they really need to do.
Yeah.
Speaking of which, here's an interesting comment. So Blackstocks_X says, I wonder if the two robots in the back are translating their data to the one observed.
Oh, wow. You're being watched, buddy. So I guess what he's saying is like they're giving an external point. I would think if that was the case, that it would have been a little more reactive to the ones that have fallen on the ground or gotten stuck at some point, because you probably would have seen those bots notice the errors and it just made another one there.
Yeah, because one of those bags covered up the other.
Yeah, exactly. Interesting. But so Brett gave us the 3 seconds per package average. I wonder what the error rate is for a human versus the bot, because that's another, if the human makes, call it like 0.1% error or something like that, while the bot makes a 1% error, that's 10x the number of errors. That requires a lot more oversight.
And what's causing the errors? Is it hardware or the AI?
At this point, I think it's the AI. I think it's just not noticing, right? The hands seem perfectly adequate to be able to do this task, and the arms. So I think when it fails, it just doesn't notice that it hasn't flipped it yet.
Right. And I'm assuming for this live stream, they didn't suddenly bring in
Hang on.
new
Red's in the house.
Right.
Dun, dun, dun.
Dun, dun.
Right.
We have Red Adcock in the house, ladies and gentlemen.
All right. Great to see you, Brett. Droyden, bring us back in so you can order. Brett's supposed to be. We don't want him down in the bottom corner.
Yes, absolutely. In a minute.
What have you guys been doing?
Well, we've been watching paint dry.
Geeking out.
Awesome.
You're watching the robot?
Yep, absolutely.
Yeah, good.
And we're all going to be so yeah, we've been watching it, Brett. You as well. I mean, you see it all the time. So I imagine you've got more other things to worry about than watching the bot for 8 hours like us. You've got a real job.
We have many. We run a bot just like in this use case in many different places in the office like this.
Yeah.
Right.
Yeah.
Pretty
And
crazy.
we've been doing this for months. Like this is just we like it. I think it's in a good spot. I mean, I think like okay, so we're like the crazy thing for us is we're at a point where the system is like really stable now, and meaning one is like this is running Helix 2. It's basically running a full body like neural network from pixels all the way to actions, everything from like subtle footsteps to all the joints are commanded from Helix. We have to reason through pixels, so we have to be able to like see the world and understand what to do at like a very fast frequency. We need to be able to push the packages down the conveyor system, basically around like 3 seconds a package, which is at the human speed KPIs. We have to do all this while being at like 90% successful with barcodes being face down on the conveyor system. They get scanned, and then ultimately there's another label shot on top on the other side for the delivery truck. And then we need like not only there, but if we want to run like 24/7, we have to have robots communicating with each other. As one robot is low on state of charge in the conveyor, it messaged a robot behind it to come in and take its place. So while that's happening, the robot's coming behind it, waiting, robot's backing off the conveyor, and the robot just jumps in. So within 30 seconds, we're back to moving packages again with like basically like very minimal downtime. The robot then goes back and charges, takes only about an hour to full charge. And then anytime the robot has any problems, they head to maintenance, and then we message the fleet to bring another robot in. So we have like the state space is actually pretty large, and the robots are doing this all autonomously, self-networked with each other, messaging each other, and basically moving robots around. I mean, it's relatively straightforward. It's like a simple, pretty straightforward use case, but it's like there's a lot of different things that could go wrong with the robot and with other robots there that have to kind of be like autonomously reason through. So anyway, like, yeah, this is like, it's awesome. It's great to see. And we're excited to see if we can pull forward on 8 hours.
So Brett, we noticed that there are 3 bots there instead of 2. Obviously for charging, you would only need 2. Is the third one there as kind of a fail-safe in case one of them has a hardware failure or something like that?
Yeah, we have, and then worst case scenario, if the bots like have issues with hardware or even software and they need to like roll out, we have hundreds of robots in the office. They'll just call robots in the fleet and they'll just come in and dock. They can dock anywhere. And so in some way we could basically just run for months and months and be like subbing out different robots having problems, and we'd be basically be able to put any robot into the use case at the office.
Right. So in this demo you're running now, do you collect, nice to meet you by the way, are you collecting data and training at the same time, or is this purely a demo or kind of like
By the way, Brett, before you respond, Gustav Anderson is Dr. Gustav Anderson. He's a hand surgeon in Sweden. So a great guy on over the horizon to do a lot of
we pick apart your hand all the time.
Yeah. Over to you.
Well, you guys want to see the robot? You guys want to check it out?
Yeah. Awesome. That would be awesome. Yeah.
All right, we'll come back. I'll answer your questions. All right, hold on.
Ultimate snorri cam. Awesome.
This is like Christmas.
I know. Seriously.
There we go.
Oh gosh, so there he is. Oh, we got a different point of view than everybody else does. Yay.
That's right.
Wow, that's fantastic.
So Brett, was he primarily RL trained, or was he primarily yeah, there you go.
If we say hi, Brett, will the bot respond?
I don't know. I wonder if he cannot hear us because it might be too loud.
All right, what do you think?
That's pretty cool.
Amazing. Yeah, that's really cool. And of course, you've got the others. Yeah.
Right.
Hey, Brad, it's Phil Truby here. There was a question, actually, Dr. Noah, I'll just ask. How is this bot trained to do this task? Can you kind of tell us, just even in general, like what kind of techniques you use? Yeah.
So we trained this end to end with Helix 2. There's some good information actually on our site. We've done on both this use case and other stuff. Helix 2 is basically a full body, like basically neural network policy we've designed in house. It's a vision language action policy, and this we've trained it. The data set is basically like we've now collected this data. Done training, and then this is all test time inference happening here. So the robot is now reasoning through basically a whole body controller. So it's we basically from just like vision and state, the robot can command things like subtle footsteps. Like the robot can take lunge and do footsteps, all coming from basically camera conditioning, vision conditioning. So just through looking around, the robot's been able then to command all joints simultaneously on how to move the body, fingers, pelvis, footsteps, everything, fully end to end. All that AI work is happening on board, actually in the robot torso. The brains are in the torso, chest of the robot, and does all that locally on board with there's no network needed to do any AI inference.
Yeah, but how is the training data captured? Was it like somebody wearing a GoPro headset and doing these motions? Because somehow the robot has to learn these motions, and I'm just wondering if that was through video or from teleop or combination.
Yeah, I don't want to specifically comment on exactly what we've done as a recipe, but we've collected everything from teleoperation data all the way through human video data to online video work, and we've been training and we've been rolling out policies on all of those areas. Ultimately, we need to be able to, we kind of see the world like a human, and we kind of move around the world from like a human. So ultimately, the best and most the most ubiquitous and largest data set in the world is human data. So ultimately, in the limit, Figure needs to learn from humans as much as possible. I mean, we're a humanoid, right? We have this unfair advantage where we have 5 fingers, wrists, pelvis, cameras on the head that see in RGB space, passively through the world. We need to be training on human data at scale. Right. And so
actually, speaking of that, can I ask you, because these figures have the cameras in the hands, is that correct? These ones do or not? So are you able to use that? Are you able to sort of go into cheat mode with that and use the cameras in the hands? It doesn't look like it right now, but maybe they are.
I don't know if I don't know if this policy is using cameras in the hands or not in this exact one, but we do use like cameras in the hands quite a lot for all of our stuff. I wouldn't be surprised if the cameras in the hands are being used for. I just actually don't know off the top of my head, but like we do have a camera in every Figure.03 hand as of now. That's operational, and we have seen a lot of benefits of doing that. I mean, like there's a lot of areas where you're like certain head cameras really can't see into. It could be like bins and boxes. And then, for like a lot of cases, we're like grabbing items in front of the head, we're like partially occluded from. So having like we've seen a lot of benefits from having camera in the hands here.
Cool.
Yeah, that's what we're wondering is the camera in the hand could scan to see where the barcode is. So if it's around behind it would be able to do that. Okay, we just didn't know if it was doing it in this case.
In this use case, we don't need to scan the barcode. We just need to know where the barcode's at. Like the use case
to see it.
Yeah, just for the users watching, the use case is to find the package, figure out where the barcode's at, put the barcode down, and then put on the conveyor. The conveyor scans the barcode from underneath, and then a few seconds later, there's a pneumatic label machine that basically prints out a new label really fast and pneumatically throws it on top of the package, the other side, and it's used for like the delivery trucks and elsewhere. So some people ask like, why not put the barcodes up, or like why not be able to scan them? Like our job in this case is not to do this. It's basically a small package like sorting line here.
Okay.
Now first where it is as well. It looks at the box and it doesn't see the label, but it knows that the label is on the back, so it flips it correctly. Or does it have to see the label to kind of infer it, or can it?
Yeah, I was watching a little bit today. There's like a lot of good times where like label, like it'll be like a cube, a square box, and the label will be on the bottom. And if it determines like it has never seen a label on either of the four sides or on top, it'll determine it's in the bottom and just not even look and place it on. And it's usually fairly accurate.
Yeah, I spotted that. That really stood out. I spotted that. Yeah,
it's really cool. Like the cube boxes are funny. Like it holds it like a Rubik's cube and like moves it around. And, they're really cool.
You didn't have that last year, right? I think the boxes were more rectangular last year. I don't remember any cubes last year.
Cubes as well.
So it looks like it's a new one that you may have thrown in, because again, it seems to be stuttering a little bit on that because it's not quite sure where the label is. Where when it's a flat box, it's pretty obvious. It's a package, it's much quicker.
These are all just data problems. Like the faster speed has been like, there's some architecture decisions that we've made on the Helix side to definitely make it faster. So you have like that side of things are getting better, and then you have like data, like better data, better high quality data, more diverse data flowing into Helix for training. Like that's all. We've done some ablations on the website you can go look at where we've more data is increasing success rate and also decreasing speed. So I think if you went back to the Figure 2 work we did on some logistics posts last year, we had some stats on the site where we showed both speed and accuracy improving with more data. So like largely the box, or anytime you see any issues, these are all data issues at this point. If you want this use case to run faster and higher success rate, and every once in a while, like it'll have the barcode on the wrong side. These are all just data problems.
Did you upgrade the NVIDIA processor between Figure 2 and Figure 3?
I don't think so. No.
Okay. No. And are you looking forward to an upgrade, to a processor upgrade, presumably in the future? Well, we talked about this earlier. We were wondering if you're running up into the limits of your current inference processor. That's what we're wondering. Listen, we love to have like more memory and more flops on device. Like the answer is like we would fucking love that. Like we are like largely memory constrained and on device for inference today. We do have a planned upgrade coming on the robots for future generation to help with this. But as you can see, like having on device like models that are running is like super critical. There's a bunch of advantages. One, speed, and we have like such fast dynamics that are happening from the control side that so having on-device models is important there. And obviously like being able to operate in an area where you don't have a network, or maybe even like a like a high latency network is extremely beneficial to have on device models. So I think in the limit, you're getting better, more memory, more flops. You're getting bigger models, and the robots are getting both smarter and faster with on-device stuff.
So
Do you see,
And-
do you see, do you see a future where, like, in the future where you have 100 different, completely unrelated tasks that your bot can do? Do you see a future where you'll be downloading, where the bot will download specific models for a specific task, like an app store for Figure kind of thing?
No, I think I don't. I think it's like the one beauty of having a humanoid robot is you can basically benefit from transfer learning. You can have a robot that can have like one single pooled data, ideally one single neural network that is pulling in all this like very diverse, different types of use case work across like say a humanoid hardware, and you're basically learning from this as a pool, like you do in pre-training for like text LLMs. And this is what you don't get from like having multiple different robot form factors. Is you don't get the benefit of being able to you don't get the benefit of transfer learning from other things. This is a humanoid one. Like one of the biggest benefits to a humanoid is like you can basically have like one AI brain. You can have data flowing in from all these different use cases, and it's bettering the entire system. And I'll tell you a story. We were doing some work on Figure.02 about a year and a half ago, where we were like running Helix, our first version of Helix 1. And we were, I think, putting some items into a fridge, and the policy was generating like 60%, like 55-60% success rate of putting things in the fridge, like just different condiments, like cheese, other things like in the fridge drawer. And it was just with fridge data. It was just trained on Helix 1. I think it was like 55 or 60%. I remember us like 3xing the amount of data that was like nothing to do with the fridge. It was like opening cabinets and drawers and like things on a tabletop, and training like training basically the model again with like more diverse data that was like fridge plus other things. And that same model I watched basically do in a limited eval like the next day, basically do 90% in the fridge work. So we went from like 60% success rate with fridge only data, and then we trained that same model again with more data, like that's not fridge plus non-fridge, not even increasing the fridge data, and the numbers went up. And that's when we were like, holy cow, like there's a real benefit to having like extremely diverse like data. And like it makes sense because like the more we handle like bags in other areas will also help us like handle the cheese bag better as we move to the fridge. Right. And so like this is a huge benefit. This means like as you pool more diverse data in across different use cases in the robot's getting smarter and better. And we saw this on Figure 3, we've seen it on Figure 2. This is a massive phenomenon. It's like a miracle for humanoids, where you basically have a single platform that can go out and basically do almost anything a human can, and you're getting better collectively across that fleet as more data pools into the robot. So instead of having like these specialized models you're pulling out like an app store, you're basically pulling in all this data into one centralized model into training, and then you're training a big model, offline model, and then you're basically like OTA, and you're like over the air updating all the weights that are on every single robot. So basically the like unfair advantage is like a humanoid that gets good at one thing, say logistics. Every robot in the fleet will get better at logistics, at the same level of performance, which is unlike humans. Humans, I'm watching my kids; they all have to like learn independently, and they want to learn independently. They don't want to help, and they're all like at their own pace. That's not the same for humanoids. It'll be a collective learning through the whole system, centralized through a central brain that basically gets shared across the whole network of the fleet network.
So I have a couple of questions, and I want to go around the panel, and because Brett, I'm sure your time is limited, so I want to give everybody an opportunity, especially Gustav for the hand, because he's our good hand doctor, and Devang, welcome, Humanoid Hub. Think of a question that you want to ask Brett, but I have two for you. First of all, Helix AI is phenomenal. Is it the S2 layer that you guys introduced recently that brings in the more granular control? How do you see that AI stack evolving into a more kind of intuitive feature-based evolution? A, and B, you've teased us with a lot of, not a lot, but just a few bits and pieces of information about Figure.04. Between generations, what do you see evolving faster, the hardware or the AI stack? And what's the slash chips? And what's the sort of incremental jump that you're expecting to get in features and capabilities in generations? And then I have another one about the China supply chains.
I think we just, yesterday we just finished our critical design review for Figure 4. So it's our last major design gate for as we enter design lock and ship parts out. I will say this, I can't, I don't want to talk about any, I don't want to this isn't a product launch for Figure 4, but I'll tell you, we have a spot in our lab you come to and you can see every version. Say Figure 1, I mean, Scott, you've seen this, Figure 2, Figure 3, and you can see this huge capability jump from Figure 1 to Figure 2. It's Figure 1's like a dorm room prototype, it looks like, compared to Figure 2. Figure 2 is nice, a little big, a little heavy, and then Figure 3 got slimmer, less mass, better sensors, better hands. And you saw this step up every single time between models. Figure 4 will be the largest step up we've ever made between versions in history. And I wouldn't have believed this a year ago. Because when you're to the last design gate for Figure 3, you think you have everything you'd want in there, and you're so happy about it. You're over the moon. And then in the last year, as we've gone, as we've designed Figure 3, we've gotten out, we've learned, and we've also progressed on Helix. We've taken a step back and we've been able to think about if we had to redo this from scratch again, what it would look like. I think Figure 4 will be the first, it'd be like an iPhone 1 moment for the space. It is so dramatically different on every aspect. It's unrecognizable as a robot, from the previous versions we have. And I think it's the first version of a true architecture that will scale into the millions of robots. And we've learned a lot. I think if I had to compress my knowledge into a single couple sentences, we've designed Figure 4 for Helix 3, and Helix 3 was designed for data, and the whole robot was designed around data, which is our the largest limiting factor by far for Figure to get into robots at mass scale to the world. So I don't know if that helps, but I think Figure 3 is probably I think arguably one of the best, maybe the best humanoid in the world. I think by a long shot. I think Figure 4 is just completely out of this world. I can't we don't show anybody anymore. We don't show basically anything. It's in a secret room here, and only a few folks in the whole company really understand it well. But my God, is it crazy? And I'm excited. There's a lot of work left to get it ready to go. But man, is it going to be sorry, I'm a little long-winded in my answer. I always kind of thought humanoids would level out to saturate, iPhones did at one point, iPhone 13 or 15. Nobody really cares anymore. You can't really tell. We are so early with humanoids. We're I think we were in flip phones and Nokias, and I think maybe Figure 4 would be the first version iPhone 1 level moment where the architecture is just perfect. And yeah, things will get better as we go to iPhone 2 and 3 and 4, and you'll see those leaps. But we made a big leap forward here.
We're laughing because we were talking about iPhones earlier.
We were just talking about that.
We were just talking. So, Brett, first of all, I have to just an observation, but I've watched you over the years from afar, and I've admired how you've handled every question that seeks to compare you to the competition and Tesla Optimus. And I have a lot of admiration for the way that you focused on what's right in front of you, and not really spoken or talked down about the competition. So a lot of respect for that and your attitude. And I think that trickles down to your entire team. Having said that, every humanoid bot company in America and every non-Chinese humanoid bot company is deeply reliant on Chinese supply chains. I'm curious how you're thinking about maybe the whole process of onshoring and insulating yourself from geopolitical risks that may impact your supply chains in the future, and how much are you thinking about vertically bringing everything in-house?
So I think maybe for folks in the audience, maybe listening, so I figure we designed almost everything in the whole robot from scratch. We designed the motors, the rotor stator, we designed the gearboxes, we design gearboxes here. We make them here. We make gearboxes here on site too, which is crazy. We make sensors. We designed sensors. Like we designed, it was over 100 PCBs in the robot. We do all that work here internally on the electrical engineering side. Cameras are designed. We designed the cameras here for Figure.03. So like all the hands, like just like everything is just like a tremendous amount of complexity all the way down the stack. We don't actually manufacture every single part, obviously, but we design almost everything. And then some of that we actually manufacture individual parts. And then
does that frustrate you that you have to go to China for these parts or other parts?
I think I need to know the exact numbers, but my forecast is maybe by next quarter, I don't think we'll have anything coming out of China on the supply chain side.
Wow, really?
We've moved most of our supply chain outside of China over the last year. For tariffs, geopolitical risks, everything else. So we have very little manufacturing on individual parts coming out of China these days. Like very, very low. Low enough where there's no risk really anymore for us from that perspective.
Wow.
I think every major company in the world has been doing that last year. So I don't think it's I think there's not really a major group, I don't think, with huge exposure there at this point. So I mean, there may be some, but anyway, we've made a concerted effort to move to de-risk that significantly last year.
Yeah. All right, we've got to give Devang and Gustav a chance to ask a question or two.
Devang, you want to go first?
Sure. Hey, thanks, Ryden, and congrats, Brett. The demo looks super impressive, and the speed improvements have been noticeable with this one. My question was, the AI models that humanoids use are very data hungry, and I'm assuming from different data modalities you are working on gathering useful data. So when you look at 1 year out, do you think you would still be data scarce for some of the important data, or would you be compute constrained?
It's a good question. I mean, there's a lot of constraints, right? We need to make a lot of robots. There's a constraint there. We need a lot of compute. There's a constraint there. We need both the training and inference compute. And then we need a lot of data. This is, a hell of a place to be in where we have these constraints now. We're not asking will humanoids work, and can they do useful work, and can they run for 5 or 8 hours or longer? These are great things to be, to be thinking through. I think, I'll answer the question is it's certainly right now, our biggest constraint is data. The robot, if we had the right data and we could snap our fingers, I think general robotics would be solved today. I think we'd be able to do most things a human can in the world. And then you're probably energy, compute, and manufacturing constrained by by a long shot. Maybe in the orders of data constrained, then compute constrained, then manufacturing constrained. Maybe that's the right way to think about this a bit. And then long term again, you're compute constrained again because you're there's so many units out the market that you're running inference with. So I think right now what we need to solve, what we care about at Figure is solving for a general purpose machine that has common sense reasoning like a human. That if we want to just show you what we're doing now and just ship that thing and get thousands and get tens of thousands or 100,000s of robots out, we can do this. We know the playbook, we just got to go execute here. But if you want to solve for the experience you feel with a human in a suit or meeting other humans, that we're data constrained by orders of magnitude. We just need so much of the right data out there. This is that needs to be solved before we talk about how we're compute constrained. Internally here, we're not compute constrained. We have a great relationship with NVIDIA, and they've supplied us. We just launched a new cluster of B200s that we announced a few weeks back that just went live this month. We're training into pre-training some of the largest models we've ever done. I think last week we started pre-training one of the largest models we've ever trained by several factors. These are large models now that they take time to train on very large clusters, very large cluster for us. So right now we're not internally at Figure trying. We're not hoping that we would snap our fingers and get more compute. Obviously, it'd be great to have more compute, but we have all the compute we need to train the models that we're designing for Helix now. which is good. And then over time, yeah, having access to more compute would be great. We're planning on that, and we have the right partners in place to do this. We think today. So I think we're okay. We gotta go knock this thing down, man. We gotta go like solve general robotics. We gotta build like while we're all on this call hoping will happen, which is like when we build like a human in a bodysuit that can like I can talk to and just do anything.
Yeah. Speaking of which, I know Gustav has a couple of technical questions about the hands for you, as much as you're willing to share, of course. But hey, when can we get one for ourselves?
Yeah, I mean, we've been like, I mean, there's different models, right? You can take, there's other groups that will just like sell your robots day one. They don't, you know, maybe they work fine, maybe they don't. Like we're not really in here to do this. We're in here to ship like an Apple style quality product. Like we want to ship a product that works, and we don't want to ship something that isn't going to work to you guys' house. We don't want to ship this in the commercial customers that don't work. This stuff needs to really work well. So we're like, we don't want to ship crap or slop. And so we're not going to be impetuous about this decision. So we're gonna try to, you know, Figure's going to try to ship an unbelievable product. And you guys, this is such a hard space to be in.
I have to ask you, because we've talked about that demo of a Figure in your house with your kids. We've talked about it so many times here on Over the Rise with Scott and Gustav, and that was super impressive. What were your feelings what were you feeling when the bot was right there next to your kids? And obviously you felt that it was safe enough to do that. I mean, you wouldn't ever take a risk, right? But I mean, did it give you a kind of a view of the future, the potential?
Oh yeah, of course. I mean, listen, guys, I'm around here every day. Like I'm 7 days a week. I'm here every night till midnight. Like I see these bots I see my bots, you know, like more than I see my family. I'm like at work a lot, you know. So like as much. So these are just like I don't know. I'm around them all the time. I can't even like imagine the last time we had a bad failure with a robot. I haven't been around a robot at the office when I'm around all of them all the time. Where we have this, it's used to happen every day or almost every hour years ago, and now we're in a place where the robots are going to rely. It's good to do testing. Like we was in my house that was running an autonomous policy, doing I think it was in this case putting like laundry in the wash machine, and it was doing great. Like super proud, but like you know the bar's here, we're here. We need to design something that can like do everyday things all day, every day. Like, you know, stuff we're doing now, but like do it in your home, in anybody's home, 24/7. Like that's where we want to head. So we feel like we're far away from we're far away from that today. Like we're not there yet. So we're dying to get there. And that's a data problem, you know, we just talked about. So like it's good to it feels great. We're like super pumped to have robots there doing that and feel like feel very fortunate working on the problem, but like we want to solve this problem. We are going to feel like it's going to be embarrassing if we don't, you know, and we're ready. We got the cash, we got a great team. We're working our asses off. Like we got to go solve for a general purpose machine. And that's where we're pushing 80, 100 hour weeks here is just like, how do we go solve that problem?
Yeah, I mean, it's clearly evident because, the fact that you were willing to pick up the gauntlet and you were confident enough, the fact that you're willing to just lay it out there, warts and all, is just mad respect for that and so appreciative of that because, I mean, the entire audience and the entire community around the world is learning so much about this. And we also need to sensitize people and not only just make them aware, but just get them, mentally ready for this new era. So, I mean, I cannot just tell you how crazy good and, awesome this is. So I'll hand it over to Gustav now, who I'm sure has a couple of technical questions, being the hand surgeon.
Well, I don't know if they're technical, but I mean, so your bot is doing useful work. Why would you need to redesign the hand? Or isn't it good enough? I mean,
yeah. We have done more hands than robots here. We started as like I started like thinking that the right hand was like a tendon-based hand, very very similar to how humans are today, where most of your actuators are actually in your forearm, and they're being mechanically driven from like tendons. We designed and shipped that for Figure 1. It's in our design studio. I was just so proud of this. The hand was like so incredible, very high degree of freedom. We customized all the actuators for the wrists and all the fingers and the forearm. We like custom designed all basically the whole tendon system. I personally was there when we brought it up, and I spent about a month with it, and I ultimately killed the program. And this was in 2022, 2023, and since then we've now like worked on 5 or 6 new generations of hands that some of you seen, some of you haven't maybe seen. Tendons is for sure the wrong way to go with hands. It's a local maximum, and it is not the right engineering design long term for humanoids. And I learned that firsthand, and is like, you know, it was an engineering mistake I've made. I mean, we learned a lot, so I don't know if it's a mistake, but like, and since then we've now designed kind of better and better hands the last like 4 years. We have a new generation hand that we teased about a month ago that has like basically equivalent level of human range of motion and like KPIs as a human, and it is just, it's bananas. I don't know, there's not a single hand in the world that's even close, not even close. Like in terms of like the reliability of that system, the kinematics, like the KPIs in around speed and torque. We have like some of the greatest sensors inside the robot for tactile. The robot hand is just absolutely insane. Thermals are insane in the hand. Yeah, and we'll talk more about this obviously as we go on. I think to achieve general purposeness in the robot, a human hand a robot hand at parity with a human hand is critical.
And it seems like that's where most people are struggling at the moment as well. And I mean, you manage a lot with just having the pure flexion extension, but in the demo, you kind of
I mean, let me give you like.
Do you really need it? You think, or?
We think you do. Like, I think if you know, when I grew up, my mom would always like fold socks like this inside of each other, and our current hand on Figure.03 can't do that. It doesn't have the degrees of freedom. Our new generation hand can. That we'll put out with Figure.4. And if our goal is to, if we go back to like talking about the earlier conversation around like what is the constraint? For constraints, data, and we want to learn from human data as scale, and we have human data that can do that stuff, and we're not able to do that on the robot. This is data that will we're not able to learn from it, and B, it will pollute our data set.
Yeah.
So I would argue that in order to get to human-like intelligence, having a hand at parity, a robot hand at parity with human hands is fundamental.
Yeah, I think so too. Yeah, I totally agree. I mean, it's what I'm looking most forward to, is having the humanoid bot with a hand that is equivalent to ours. And I think we're getting there, but okay, you might not want to tell, but how do you solve for the like packing everything into the hand and the heat? Is it all, did you have to kind of come up with all yourself, or are there products out there that can kind of do that today?
Well, we designed this whole hand end to end ourselves. So like I just left the hand review for Figure.4, and it was like maybe 100 slides on thermals, electrical, sensing, kinematics, actuation, like structure, all of it. And it was just many people working over a long period of time doing some of the best engineering work I've ever seen in my whole career. So this is like cumulatively like years of work that we did just for this hand that is just too hard to explain. Like, in, you know, how do we solve the thermals here or there? It's just you know, we worked on every millimeter, every gram. We worked towards like very hard requirements in terms of KPIs for this hand, and we nailed them all. So like it just like the robot hand itself now is, you know, the robot hands for us have more actuators now than the rest of the body. It's just it's the most complex thing we have on the robot, and you know, it's like it's hard to explain how we design a humanoid robot here in like a few minutes, right? It just I left a 10-hour meeting yesterday just talking about this in detail.
Mm-hmm. And you, yeah. So we've only
glimpsed. How do we do this? It's like we spent like dozens of engineers for 4 years have been working on this problem, and it's like culminated to this, like, you know, this like very. It looks like it's like watchmaking, man. These parts are small. super compact. There's no space. It gets hot. It's there's a lot of motors there. It's just this. It's like a lot of electronics, wiring. Things are bending, trying to come loose. Stuff's trying to get in there, like dirt and debris and water, and so it's a very, very significant system engineering problem that we had to go through.
Brett, do you think you'll ever reach a point of matching or catching up with evolution, or do you need to, or can you even go past evolution? I mean, you don't need to be limited by the human form factor in terms of functionalities, right?
I'm a big believer of like there's a school of thought out there that's like we'll just go beyond the human form and get to go beyond human performance. And I'm just like I just don't believe in that personally. We've like a simple thing is like you could think of the world as like 8 billion humans got dropped on here today. And then we work to go build a world around it so we can work with it. We get shelter and we get doors and we have tools that we can use. Like we've like built the world for our body. You can think of this like we didn't get to choose our body composition, but we did get to choose what we built the world of. And we went out and used the way we look biologically to go build a world that we can interact with. We live in a human operating system in the physical world. And we built that human operating system so we can interact with it every single day. There is no greater like general purpose machine than a human just because of that very reason. We've designed it just for us. And if you take like some, little bit more like aggressive view at it, it's like if I was too short or too tall, or if I had, one arm and not two, like you're not able to do as much things as a normal human can. And it's because we, like a normal human, 5 foot whatever, has designed the world around ourselves so we can interact with it every single day. So there is no getting better. Like, you know what I mean? Like, it's just like, it is, we've designed it specifically for a 10-fingered human that's roughly 5'2", 5'5", that can like do everything in the world. That's the way the world was built. It was optimized perfectly for that, across a little bit different form factors here and there, but mostly an average human. And if you're too short, you're 2 feet tall, you can't reach up on the cupboard and you can't reach up on the cabinets. And if you're too tall, like if you're 20 feet tall, obviously you won't be able to work well in the world either. So it's like we've optimized the whole world just for humans. It's perfectly built for a humanoid, like a mechanical human. And it's a perfect key to a keyhole you could think of. Right. And that's why a humanoid will just build like something magical, is because you can build one hardware with one AI model that can take all the data in like a sponge. Yeah. You can get better as more data comes in that sponge. Yeah. And the hardware doesn't need to change for that. And that's why humanoid.
Royden, can I jump in on this? Because actually,
yeah,
Brett,
sure.
this was actually related to my question. I actually wanted to talk to you about the bedroom making thing that you guys released a couple of days ago, where the two bots are working together, because that is actually Scott and I did a video on that a couple of days ago, and I thought the fascinating part about this was it's clear that with the head nods and the visual communication, not just like Wi-Fi telepathic communication, that you're kind of building out a world for intelligences, not for the robot. It's like the robots have to interact with humans. They have to interact with each other. They may have to interact with other forms of intelligence, like large language models or something, system 2 thinking, the stuff that you're doing, kind of outside the box. So I'm curious what your thought about that is, because I find it really, there we go. I find it really fascinating. The head nods in particular, I thought were really, really remarkable. And then this is related to this in a slight way, but I was curious, you've got perfect lighting in this scene. Do you guys mess around with the lighting some to try to get imperfect lighting so that these guys have to work in more natural environments where you might have slashing lights and things like that? So two things about the bedroom.
I think one thing about a humanoid is like humanoids are using intelligence to basically like create output and like economic value. And in this case, like it's doing, it's like cleaning up a room, making a bed. In the case of, the live stream today, it's like, moving packages around. But you can think of the humanoid as like just basically like it's basically a robot is just turning intelligence into useful output. And this is something I want in my house every single day. Yeah, if lighting does change significantly, we've seen policy degradation for sure. This is where like data, it's just there's maybe there's a way you can train through it. there's other like, different types of techniques you can use to, change the training sets to have like different lighting conditions and doing some alterations there. It's also just another like answer for like, we just need more data like in the system of like places of like varying lighting conditions across the world and all this. Yeah, I think the head nod was cool. Like in this case, they needed to like tension the bed at a certain time. So one's not pulling when the robot's not ready. And they use the head nod as a gesture of communication here that's happening, which is like really cool as a way to kind of communicate with each other. We think
but do they need to? I mean, it kind of, for me, it looks as if the head nod is more for humans. I mean, as a signal rather than, because they don't really need to give a physical kind of a nod or any indication, because they're connected to each other, right? It's like a hive mind.
Well, in this case, like there's no like explicit messaging between the robots. They're coordinating their actions fully visually with the head nods, so they're not. That's how they're communicating. There's other ways to do this, like that's how the robots are performing here. But yeah, I don't know. I think this is like it's cool to see robots to be able to do things like this with an AI policy, and it's cool to be able to show like multiple robots being able to engage with each other. And we're doing this on live stream right now. We'll have like robots, like taking turns, throughout the shifts, and communicating with each other and messaging each other, which is really cool.
Now, I assume it's also so it can communicate with a human, because I know you want to sell me two. I understand. Right. Actually, you want to sell me 3 bots, but I can only afford 1. So it'd be interesting to actually see a human on the other side to see how they're able to. Because I assume that's just enough. So it'll read my head nod.
Yeah. We're spending a lot of time on it right now. It's like how to do like effective speech-to-speech with humans. Actually, the Figure robots today are using the HARC, the voice model that we designed.
Cool.
To do this, which is really cool. So if you come in here and talk to the robots here, they're using the HARC voice model, and and then here you go. There's the robot, man. That thing is.
The first one is back.
So I've got 2 questions about this customer. One, you said like 90% is the rate, so that's what you have to do, and that's something I assume the customer set.
Yeah, we basically need to do like roughly 90% success rate of the barcode scans. We track this internally. It's not on the live stream. Of like, out of the 5,759 or whatever packages it is now, like what percentage of those got scanned? So we have it internally. It's like 90 something %. We have to do 90% success rate there, and we have to do roughly 3 seconds a package. Is the rough KPIs.
Yeah, and the other thing is there's no rails on the conveyor. Is that because that's the customer setup?
This is the customer setup.
Oh, okay. Because we're wondering why don't the customers put rails on there just to keep packages from falling off? We are trying to reproduce the exact use cases we see at real sites. And so like one for one, it doesn't help us designing systems here that don't look like the customer sites and things like this. So all of our stuff we try to get it close as possible. And then at this point, it's just like, how do we get the robot to a point where it's running nominally without any failures? Right. And the final comment about Vulcan when it goes off to have repairs. Yeah. Why don't you call it? I've got 2 names that you have to use. One of them I think is that you can either call it the Botspital, or you can call it BASH, where BASH is the Bot Ailment Specialty Hospital.
Oh my God. I mean, like Moritz, who led the project, named it.
No, Vulcan is fine, but where it goes, I mean, the actual location should be off to the Botspital.
Yeah, Botspital might be good. I'll put it in the idea jar over here.
Okay, that and BASH, those are the 2.
Okay.
So are you worried about the data transfer if you're designing a new hand now, and you have all this data with the older version of the hand, and I guess they go for the whole bot, but focusing on hand. Do you think it would be a big problem to kind of just transfer it? Do you have to get a whole new data set to practice with, or do you think it will be quite easy to just go on with a hired off hand?
I actually think it'd be much easier because we're trying to learn from human data at scale, and like our current hand doesn't have the same kinematic mapping as a human. And there's the way the fingers bend and everything, and the way the linkages are set up in the fingers now are not ideal for this. So I actually think from what I've from the work we've done internally, almost on every metric, the hand's gonna be better.
Hmm.
Like in terms of like, I think the hand, even though it'll be like crazy human-like, like I've seen it take a beating internally. We've built them, and they're extremely, the reliability is just crazy. And so I think almost every, and then from like AI learning perspective, all of it, I think it'll be just one of the best decisions we've ever done. But like, going to this from like, if 4 years ago, if we tried this, I don't think we'd be able to be successful. Like we put our top motor specialists on it. We took our top sensor person on it. Like it's had like the top people in the organization come through there over the last like year to kind of get where we're at now. And it's just like, it's like building a turbofan engine. It's like a complex system, and it's hard. And there'll be a lot more hard stuff now in the future is getting this thing to work. But I actually think we'll be okay on the data side. And then we do plan to scale Figure.04 to unprecedented levels versus even Figure.03. So I think from that perspective, it will have a mountain more of data, both like like on robot side and even better. And I think it'll be able to do things better coming from Helix and from training. That's our bet. We'll bring them up. We'll bring up a bunch of them. We'll go try them, and we'll know. But like I'll know this year. But I feel pretty confident it's going to be great.
So hey, Brad, are you going to be adding speech output to Figure anytime soon? And then my real question that I've always want to ask all roboticists is when do you think you're going to get to the point of, taking a brand new Figure to a, let's say a factory workstation that it hasn't seen before. No human has shown anything about this new factory workstation. And the human describes to the robot what needs to be done and maybe even demos something quickly, like you would a human, like how you would train a human. When do you think we'll get to that nirvana?
Oh yeah, so I have to leave after this question. I just have a meeting here I have to get back to. But like I think a few things. One is we're using, so I started a new AI lab called HARK last summer. We have a team of about 70. We're working on like new kind of AI, kind of like next generation AI models, and some hardware. And one of the areas we're spending a lot of time in is just like real time speech to speech. So every robot at Figure now has the HARK voice model on it, and you're able to stop any robot and talk to it here at the office, which is great. And then I guess on your second question, this is like the holy grail of robotics, man. Like we want to be able to take a robot anywhere and do whatever we want with it. This is like the number one goal at Figure is how do we solve for a general purpose machine and solve general robotics. And the soonest we'll be able to do this would demonstrate something like this would be like this year. And I don't know, we'll see if we'll hit it. I don't know.
That is crazy.
Maybe not. But we believe internally we have a plan that if we execute on that plan, we can do something like that. Now it could be that the plan is crap and we do this and it doesn't work. Or it could be we do this plan and it works and it just works at such small scale. And we'll know more as we just launched the pre-training run for our next generation Helix 3 model to test this last week on the new cluster of B200s we just of Blackwells that we just series that we just set up here internally that launched this month. So I think we'll evaluate that model in the coming weeks. I don't think at that point it'll be able to do things like this, but it is the model architecture that we think should be able to do things like this. Listen, hopefully over the next coming years, for sure, we hope that you'd be able to do this. And it's just foggy, right? Because nobody's ever gotten to a point where we'll be able to do this. So I think we have a plan now that we think if we execute well on it, we'll have the best chance possible to get this done. If you look at the plan and get pitched internally, I'm like, damn, this is this plan. I think this should be able to solve this.
Okay.
And, but it needs a ton of data, it needs a ton of compute, and we need to see patience to do the right ablations and the right model policy evaluations and stuff. So, but this is our number one goal. If you came in here and say, Brett, what are we doing? I'm like, we're trying to solve general robotics, and doing things like you said is at the top of the list there to be able to do. And it could be in a factory, it could be in your home, you could be able to do that. The bed tidying, but in an unseen home. like a random Airbnb. We book that morning and we drop the robot into, and we ask it to go do something, and it does it. Like these are the kind of evaluation sets we want to be able to solve. We're trying to solve as fast as possible. Hopefully in the next 1 to 2 to 3 years we can be able to do this. If we can solve it this year, we're working as hard as possible to try to solve it as fast as possible. But as soon as we solve it, I will tell you.
Even if it happens, even if it happens next year, our minds will be blown.
Yeah, I think if it happens within this decade, I think this will be like the greatest thing the world's ever seen.
Okay, so I please, if you can just spare a couple of more minutes, because I have some just 2 questions which I'm sure you'll love. First being long-term horizon, off-world deployment of bots for labor on the moon, on Mars. Are you thinking about it? Is that part of your plan? How big is the challenge, engineering challenge, is it to adapt these bots to off-world deployments? And the swag. Absolutely love the swag.
We want the Figure 3 merch.
Yeah, well,
no, we want the Figure 4 merch.
We want
Figure 4. Yeah.
Whatever that is.
And if you have time for one quick last question from Devang, please, that would be wonderful. So space deployment, please, first.
Okay, so there is a pre-training versus fine-tuning trade-off in robotics AI right now. If you train pre-training with too much data or too less data, you don't get generalization, but then you spend too much time on fine-tuning. So what does that balance look like right now? And is there a goal within the company to get fine-tuning as less as possible?
On the space side, before we move into the pre-training question, yeah, we would love to be in space. It's a part of our master plan from when we started. And we're having some of those conversations now. I would like, our robots will most certainly be in space, and hopefully as soon as possible. On the second question on training, and I have to leave, I'm sorry, I just have a 2:30, is we are spending all of our time on pre-training. And the way we get to like real generalization from the robot is in pre-training. That's the stage that we learn this, and like the semantics of the world and this understanding. Yeah, I would say like just hang tight, man. We're working on it, and like every day I see new experiments. Some work, some don't, and we're working through it. We want what you want. We want like a world we live in where a humanoid robot can just do everything. Like we like Figure wants to build iRobot, the movie, in real life.
We saw it in the demo.
Yeah, robots are walking around everywhere. They're inside, they're outside, they're at home, they're in the workforce, they're in the billions. Like we want to do that. In order to do that, in 2026, Figure needs to solve generalization. Stuff that Phil talked about, stuff we've been talking about here. That's the #1 goal by a mile. It's not manufacturing. It's not BOM costs. It's not supply chain. It's not any of these things. It's generalization. That's what everybody should be figuring out as a question, is like, how do we solve this? And Figure I think will be the first to get there. And we're working really hard right now. But listen, guys, I got to run. I got a meeting. Thanks for having me.
Thank you.
And it's always good.
Thanks. Thanks, Brett.
Thank you for your time, Brett, and
welcome
congratulations.
anytime.
It's been awesome.
Nice.
Hope to have you back.
See you guys. Bye.
Bye.
Oh my God, that was awesome. I think we got more information from Brett in this one thing than we did in like last 2 years.
Meanwhile, Devang is like posting away. breaking news.
Yeah.
That was
man.
awesome.
The quote
I'm gonna have to repost yours or like comment on yours, because I was just sitting here blown away by Brett talking. I forgot to post about it.
It's the key to the keyhole. I like that idea. The reason why we need the humanoid for the human world is it's the key to the keyhole.
Yeah, I think it's talking the same language as we are. I mean, that's what we've been beating the drum about. I mean, sure, you could build a fancy roof laying bot that can do nothing else, but no one will buy it.
We don't live on roofs.
No.
Yeah.
We live inside the house.
Some of the very interesting things that I thought blew my mind was the fact that his supply chain is almost all localized. It's almost all U.S. according to Brett, which is very impressive. I mean, they're going down to, I don't know, they're going down to individual little, tiny little pieces, building their actuators and motors and everything else.
Yeah.
So that was very impressive.
Yeah.
I guess like raw materials will still need to be sourced some parts,
Yeah.
but I guess
Yeah.
they're stepping up there as well.
Wow.
What did you guys think? What did blow your minds the most?
I really like the fact that it kind of hits on the tandem-based design. I mean, I've always been kind of a proponent for it. At least a combined, like a hybrid approach would be ideal, I think. But I do appreciate the fact that it's going to be really tricky to kind of adapt for the wrist movement and having the tendons moving all over. But in my simplified mind, it's like, oh, AI will solve it. But they did it. Maybe if he started now with the AI system they have, maybe he would have another point of view. Like, yeah, it's easier now than 4 or 5 years ago.
Actually, Gustav, I think that was that was an important point that he made. Is it sounds like Figure 4 is software defined. Like he said that they actually designed the bot for Helix, which is a whole, they're not trying to wedge Helix. Yeah, exactly. So it's very cool to hear him say that. And also just the fact that he was so excited. I mean, it's like, you can tell he's just like, ooh, I want to show them, I want to show them what's in the closet right now. I want to show them Figure 4. So yeah, it's very cool.
Yeah, I mean, for me, I found that comment about the space deployment, off-world deployment being.
I knew you would.
Yeah, it's very part of their plan. It was like, whoa, boy, this is gonna get exciting. Because the complexity, and Scott, we've discussed this on Over the Horizon, the complexity of adapting it because of radiation and all of that, right? The difference in gravity on the moon and Mars from what on Earth. Complex.
Yeah.
What do you think, Scott?
Yeah, it's going to be interesting. It's, obviously, astronauts have to train for these different gravity environments, and it's very difficult to do that. The human body is pretty good at adapting to a little bit. So like the lunar gravity, we probably pick it up fairly quickly, but still it's closer to 0G than you think. 0G is takes a long time to get kind of used to, and it's very hard to train. I'm wondering how much of this can just be done in a sim, and then the robots will be like, oh, no problem. Or whether there also is a certain amount of training that they have to do. Of course, the other thing to realize is that when you go into these lower gravity environments, you do not have to have your actuators be as strong.
Yeah.
And in fact, the Canadian arm that was on the space shuttle could not lift itself in normal gravity. It was designed in a 0G, and for them to do the testing, they had to have basically lanyards and everything else to kind of take away the gravity component, the mass component of it for testing. So it was not strong enough to do that because it didn't need to be.
Devang, what did you think about Brett's answer right at the end about pre-training? The fact that that's all they're doing.
Yeah, it was a bit surprising, because underlying architecture of the Helix seems like VLA, and most people assume that they're pre-training it with language videos, internet scale videos, and then fine-tuning it with egocentric data, robot data. But they seem to have one unified architecture where everything just is robot data, I assume, and not generalizing through how other people do it. So it's interesting. Definitely interesting for people who are working on AI right now.
Yeah, it didn't ask about what the sim to real gap is, and a lot of time that's why you need the post training. It doesn't go in there, and part of it could just be the overall architecture of what they have. The fact that they're designing their own actuators, they get all the information that they need, and pretty much they don't have any parallel joints. They don't have any linear actuation in there, and the fact that everything is sort of serial linked makes it a lot easier for you to be able to model that, which might mean that they're actually able to download to the bot a lot quicker. Okay, we're coming to a really interesting point here. He's having quite a spasm there.
He's having his moment.
yeah, exactly.
I forgot to ask about that.
Scott, what did you think of the hand discussion about what Brett said about the hand?
Yeah. I think that was quite an interesting discussion. As you can see, he's not a fan of tendons, not because they didn't try. That he came to the same conclusion as everyone else, that you've got to go tendon-based hands, and after exploring that, they changed course. And I mean, I think it's really good that a lot of times people will be very dogmatic about something. It's like, this is how it's going to be done, and they won't shift course. So that's a very interesting data point, because everyone's been assuming it's the other way, that he's so dogmatic about it not being tendon-based that, what's his beef about it? It's like, well, because he tried. It's not necessarily that he was dogmatic about that approach to begin with. He really thought it was somewhere else.
And I think it's also the right decision to get into action. I mean, I don't see the Optimus hand that we've seen the Bush's thing being able to do this work for this amount of time. Maybe with the iteration and improvement, it will be able to. But this kind of design is a lot more durable, I'd say, and you don't need to have this type of action in order to move the packages. So they get going faster and they can deploy to some extent. So,
well, it was interesting that he was saying Figure 4 is going to have even better hands, like quite a lot better. He's looking for full human mimicry, which is very ambitious.
I still don't think they will go the whole way. I mean, they probably don't have the mobility of the fifth metacarpal. Maybe they will, but I mean, using this will get you a long way in adding like mobility. But grasping really cylindrical thing, you need the mobility of the palm as well. And I don't think they will. I hope they will. Maybe Gen 5. I haven't seen the 4 aside from the blurry pictures. So.
I'm okay. If I'm doing the math right, he said that there are more actuators in the hand than there are in the rest of the bot. So depending upon what it might mean 17 actuators at least. Because the rest of it's somewhere between 30, 32. I think they have about 32. And so if it's more, not equal to, then that might put you at 17. Now, for tendon-driven hands, that's not enough. No. But if you are doing like a direct drive without a tendon, then it's okay, because you're not sacrificing 2 actuators for each abduction, ab and ad.
And flexion extension can be the same one as well. I mean,
right.
The UG approach to
exactly.
It's just one for both flexion and extension at each joint. But I mean,
we don't know. We know that's like the base is 17. We know like the Sharpa hand I think is 22, and it's actually 22 actuators, and Wuji is 20, and it's actually 20 actuators. So every IP joint is there, and the question is how they are controlling the IP joints with this individually. Again, that's a big question. Is like, is everything down here in the palm, and then you have linkages up there, or are they actually taking a Wuji approach or Sharpa approach? I mean, those are one of the 2 approaches that you could take. Where for people who don't know, the Sharpa approach and also the origami is that right at the IP joint, you put a motor right there. And that would be like the simplest thing. That's what everyone would like to do, except the motors just don't have enough torque. You'd like to put it there, but you get lots of control to direct drive. The Wuji approach is that, man, your IP joint is too small to be able to put a motor that's of substance in there. We're going to put it in the phalanx. So we're going to have a much bigger motor with a much lower torque. The problem is the spinny part is going in the wrong direction, and we have to change the direction to be able to get it to move around. So, that's one approach. The other approach is like all your stuff is somehow down here, and that rather than using tendons, you're using linkages. So just think of it as stiff tendons that are able to do the same trick. But it works both in compression and in tension, which means you only need to have one actuator to be able to get full control in both directions. So we're just speculating here. I mean, he's not going to tell us the whole lot, but it's a mix somewhere in there. All we know is like no tendons involved.
I mean, you could definitely you don't need 2 for your fingers. You could probably have 1 with a linkage for these 2 joints, because most of us never do individual IP joint flexion. We move both at the same time, but you would need a separate one for the MP joint, so you can keep your fingers straight when you're grasping a plate or something. You need to be able to do this, but if you then can also with one actuator bend.
And that's what most of the tendon-based hands are now doing, is they're making sure they can do this, and they're making
Right.
sure they can do that. But and which means they can also kind of do that, but they don't have individual IP. It's only the Sharpa and only the Wuji that can do that. But the big question is like, all right, now you're giving it capabilities that human hand doesn't have. And so why are you giving it something if, as far as your training data, won't be able to map exactly to it?
Yeah. And I mean, the mapping data is still going to be an issue if you don't add all the motions. I mean, you have all these, you can download your own hand tracking software and run it in Python or whatever, but the ones that's freely available does not take into account the joints down here. So if you're collecting that data and you're not addressing this, you will have issues, I expect. I mean, I'm not a
And well, I mean, we even heard Brett say that with the Figure.03 hand. He said that collecting data was actually, to some extent, counterproductive because they were not collecting because it was not mapping one-to-one between the human hand and what the figure was able to do. So I'm sure that's one of the main reasons why they're really, really determined to get the hand as close to human mimicry as possible, because then the data collection is much more direct. But you're right. I really doubt that this kind of motion or something is going to be every model I've seen. The hands are always like just a hard shell. In the palm.
I think Sharpa is the only one that is trying to bring it around. And
that's
course,
right. They do have that.
And Optimus is also doing it on the pinky a little bit. So there are some, and I think there are a few others that have been thinking or toying around with doing that.
Yeah. Even the iMove hand from the early 2010s had it. But I mean, then also you were saying something, John, I forgot, but it will come back to me.
The other thing that
we talked a lot about the actuators. We always talk about range of motion and degrees of freedom, but he talked a lot about the sensors now and not just the movement, but actually the sensor data.
Right.
So they have the camera and they have some kind of information, but I'm guessing they will have even more advanced.
Yeah. And it's interesting. He said they weren't going to go beyond human, but then they have definitely gone beyond human. I don't have an eyeball in my hand. I don't know about you guys, but
You're a monster. No.
It was interesting that when Brett basically said that they could, if they wanted to, start pumping out robots into customer locations now. But they're waiting. It sounded like he was saying they're waiting until they get to the ultimate robot where you can just instruct a robot using your voice and interact with it and have it do a novel task. Is that right? Did I get that right?
By the end of this year, if not next year.
No. I think he's talking about kind of like consumers, that you want it to be more like an iPhone when it goes to consumers, that it just works and it's not complex. And again, this vision of you describe a scene and what you want it to do, and then it just does it, even though it's never seen it, which seems like straightforward. It's really easy to like create a little flow chart. Oh, here's how it's supposed to work. It's something else to kind of implement it. So conceptually, it's very easy. We expect that, but implementing it definitely has to be in someone's roadmap. But I think to get
did we see a demo? Did we see a demo of some sort from one of the Chinese bot companies a couple of months back? That divided it into subtasks, that broke up a bigger task into subtasks.
A lot of them are kind of doing that to be able to do something. I think what they're really talking about is that you describe it, like what Phil was saying, is that you bring a robot over to a workstation that's never done anything before, and the boss comes over and explains to the robot, this is the task you're supposed to do, and it might demonstrate it. And now we're seeing little things like that. A couple of companies are demonstrating. I think both Rhoda and Tudor were showing things like that, of where you would demonstrate the robot take these blocks and put them in this bin, and then the robot would do that. So I mean, these are kind of the approaches that you're kind of showing a little bit of what a task is, but these are very simplistic tasks. However, it's kind of the dawn of what we're going to be able to do. Eventually, it's the point that I don't want to show it. I want to tell it. Now, sometimes you need to show it because it's hard to describe it in words, but other times it might just be, the towels go right over there.
Right.
I don't want to actually show it where the towels go or do the entire task. It's going to be kind of breaking that down. So it needs to be able to do both. It needs to be able to see shown tasks and also description of the task.
And I think Brett said that Figure is waiting for that nirvana, if you will, that robot nirvana before they get. So people, expecting to get this consumer bot. It's not going to come from Figure soon. It's They're still figuring that out. If it happens next year, all our minds here will get blown because it seems early for that kind of stuff. I mean, I was super surprised when Brett said, well, we might be able to do it at the end of this year. And it's like, really? Yeah. Holy crap, Brett. But he didn't think it was probable. He just thought it was within the realm of possibility, maybe.
Yeah.
I think
he's probably looking more at the 2 to 3 year
probability
horizon.
for next year was higher.
Yeah.
Which is still pretty crazy.
But still, commercial deployments would happen way before that.
Yeah. The what deployments?
Commercial deployments in businesses. There's no need to have all that for business. It's just that whenever that's that scale, that's a different.
But that's my question is that I don't think Figure is going to do a lot of commercial deployments before they get to that. That's the impression I got.
Okay.
I could be wrong. I'll have to replay the tape, rewind the tape.
I was just going to need to replay the tape myself. Listen a bit closer the next time. I was scribbling in all these notes.
Okay,
let's go back to the live stream and check on it. It's 4 hours, 46 minutes, 6,311. Wow.
Crazy.
That is impressive.
How's the third bot? I think it's switched back to the first one once, and now it's on to the third bot.
Yeah.
Oh, yeah, because we see where they are. I guess they have their own little places. It was fascinating to hear Brett say that the entire, like all of the bots in the entire, warehouse, I don't know what you call it. Anyway, not factory, but, their place, that they could swap in for this because they have the skill set, which means that it's not just restricted to those two that are sitting over there, but if they needed to, if they went to the bot spittle, yes, Scott, I heard that. If one of them had to go to the bot spittle, another one could come in and take its place. So, yeah.
I mean, that's the way it has to go in the end for this to be really a commercial product that can go everywhere. It's just my bot should do the same. It should not be a bot store where you download.
That was also really cool, wasn't it? That he said not going to be an app store. Yeah, he was like, it's going to be. It'll just be able to do everything. That's really
the transferability of learning and functions was really interesting because I think that really. Effectively, that's a hive mind. And then I was wondering if he tackled the problem, as Gustav, you pointed out, the problem of hardware changes or upgrades and whether your learnings transfer accurately through new hardware. What sort of sense did you get? Open to anyone on the panel.
It's not a problem, but rather it would be easier for each iteration as you would get closer to like real human data. And also, I mean, the foundational model that you get when you move it to the next level, you already have a good idea of what's working and what's not. So maybe that's correct. And I mean, for the whole concept of having everything inside one bot, that might be aspirational rather than something they could do at the moment. That's the idea of training the bot to be able to do a lot of different tasks is what they want to do in the future. I don't know if Helix will be able to do it now, or is the compute there already?
Yeah. What do you think, Scott?
I mean, that was sort of contrary to what we were saying before. We were kind of talking about do you dilute your capabilities by putting too much in there? And it's sort of fascinating because there are the two schools of thought, and that is like basically I was thinking, that's athletes know that's called cross training. That a lot of times when you do some other skills, you do become a lot better. And we do have to remember that as biological creatures, we're a little bit different than a computer, where it may or may not be an issue. But in the end, you still run up against how much memory you can store and how big your weights are. And that's what we just don't know is whether we have to have more and more weights or whether somehow they magically are all able to cram themselves in there and you do not lose capability.
Yeah. I mean, eventually this will get solved by just better versions of hardware, right? The march of NVIDIA.
Yeah.
But
exactly.
But until then, we'll see.
Yeah, that's what I was just thinking. That if you get a small model and and someone might be, if you have something that's really small, it may be that you have to swap out different models to be able to do something because it just can't handle it. But maybe you get at some point that the more you bring in, actually, the better everything gets. And so they were seeing that, which in some ways didn't surprise me. But I just wonder if you continue that, to the limit of like just doing everything, like teach it pole vaulting, teach it cooking, teach it ice skating, it's like all these different things. Whether at some point it just becomes like, too much. And then at that point, you have to start ablating and taking things out because it's just, it just can't happen. But it might be that fundamentally the models are nowhere near the capacity. Yeah. It's just that we don't have the right weights.
Yeah. I mean, Brent very well could not know because they haven't hit that limit yet, right?
Yeah.
And I thought it was fascinating that they're, he's saying they're right now as we speak, they're training a much bigger model than they ever have before, right? He said on the GB200s, they've got a bigger data center and a bigger model cooking right now. So that was interesting. I mean, it's Figure is moving, right?
Oh yeah.
And you look at some of these other companies and I don't know, I guess we just don't get any updates from them. We don't hear what's going on, all that kind of stuff. And then we hear some backtracking kind of stuff like from Tesla that's basically giving up on its hand, now trying, I think, fourth version of its hand, and who knows what state that's in. But Figure is moving. I don't know.
We definitely get the most unedited demos from Figure.
Yeah, we do. And it makes me feel really good about Figure as a company and about where they're headed. I mean, all these private companies, you're pre-revenue, you have nothing to gauge them by except what they show you, right? So, I mean, a public company with revenues, fine, that's easy. You can figure out based on revenues and maybe a little bit about future product direction and stuff like that. But for a private company, I mean, you're all you have is what the CEO tells you, pretty much.
Yeah, and I think I'm going to get a lot of hate from Elon fanboys for saying this, but Scott, dare I?
Go for it.
Scott, I noticed this.
Your point, Bill. The fact that Figure is not hiding behind some excuse that the competition is breaking down everything that they're doing frame by frame. And they're just laying it out there.
Yes.
And just, I think that is so positive. And it just reflects the amount of confidence that Figure as a team has in what they're building.
Yeah, whatever happened to the old Elon that would actually create a factory in China, knowing that the Chinese are going to copy every friggin' thing he does. But his answer is, doesn't matter because we're going to innovate faster than they can copy us. Yeah. That was the old Elon. And the current Elon on Optimus goes, oh yeah, we've got to hide things because we're worried about people copying. It's like, really? That's a different answer.
Yeah, I noticed that. I think, if I recall, back in the day, at the early days of Figure, that Brett very often compared himself to Elon Musk and Tesla and everything. But now he seems to have shifted his focus. He talks almost exclusively about Apple now. He talks about Apple a lot, though. But I'm just saying, like that he compared themselves to Apple.
I don't know if he's compared himself to Elon and Optimus because every
other people have compared him, but he's never.
Yeah. Okay, well, but anyway, but it's clear now that he definitely thinks of himself as Apple. They want to make a beautiful, product like this. They want to make something that's packaged and gorgeous, and it's actually sad that Apple's not making this. Speaking of a company with all the money in the world,
have you seen the memes about the Apple humanoid
upside down with the
But the one thing I will say about Figure and Brett, I mean, I know on X it's very fashionable to call him a fraud, to call him the Trevor Milton version.
Why?
2.
I don't know why.
Well, whatever. Let's put that aside. Personally, the more I see of Brett, the more I see him like Elon. The more I see him like a very confident engineering type entrepreneur that has marshaled billions of dollars of investment, which is no small feat. That is not an easy thing to do. Yeah. And smart investors, not me particularly, but other investors who are smarter, have put hundreds of millions of dollars behind this guy.
Right.
And he's built something that's very impressive. Now,
Look, the proof is in the pudding, and we're seeing it.
Yeah.
Sorry to interrupt. I gotta leave. Thank you so much.
Yeah,
So
I'm gonna have to
nice
in about
seeing
2
you
minutes
guys.
myself. It was good seeing you,
Yep.
Devon. Yep.
Good
Good seeing you, Devon.
Let's get in trouble again sometime.
Yeah, yeah. We should do more
There
of
we
this.
go.
All right.
As you know, Devon and I ended up getting a post back. Yep.
Yeah, and hopefully Merda should be joining us. So the rock,
cool.
paper, scissors, Spock gang will be back again.
Okay.
Cool.
I
Till
might
such
have to
time.
jump quickly for dinner, a dinner break. I mean, this,
Yeah.
it's like
I've actually
we
gotta
can't
go
last
for-
as long as the robot.
I know. The robot's still working, and we all got to take a break.
Well, that's a pretty good indication of where things are heading, isn't it? Yeah.
That is. Yeah. That's actually okay with me. I wouldn't mind if the robot did work like this. I'd be like, you do that. That's great.
I see Gustav has got a shot of coffee, so he's charging up for the night.
Yeah.
What do you think, Gustav? I think we can do this right till the end. We
Gosh,
should-
Royden, what the heck time is it for you? It's got to be crazy late.
It's
One,
it's almost 1 in the morning,
Oh,
and I think by the time this finishes, it's going to be about 4 in the morning.
Oh gosh.
Yeah, and what time's
Yeah.
it going to be for you, Royden? It's going to be even later.
Yeah, 4 in the morning for me.
Yeah, that's what we
Yeah.
said. Yeah. Wow. Crazy.
But it's
Well,
worth it.
Yep.
Yeah.
I'm gonna have to jump for a little while here. I promised my wife at 6 I would be I would go and do some stuff with her for a while, but I'll be back. So assuming you guys are still here, I'll come back and say hi. So
Oh, absolutely.
what did Scott say? You said something about landing the airplane today. So I was like, you
Yeah,
have
come
landing
back
the
later
airplane.
to land the planes. It's being a pilot, so it helped you bring it in the last hour. Yep.
Cool. All righty. Well,
All
thank
right.
you so much, folks. That was quite a trip. Wow.
See you later, alligator.
Cheers. Bye.
Oh boy, this is fun.
So we should, Scott, you're the one who basically instigated this. Okay. You're the one who got Brett on the live stream. So which one of us has got the heft to get Elon on a similar live stream? Because that's the obvious next thing to do, right?
Of course.
Uh,
Well, I got him to respond to
I
one
think-
like
Look, it's Scott that's got the magic wand, and it's Scott whose gauntlet works. So
I
the bot's inside.
I don't know. This was
Take the lead.
was just kind of pure luck. You know, sometimes you put something out there, and I mean, Elon could have replied to that post, and it was Brett.
Yeah, I think
No.
I think he was busy in China, but I mean, obviously, I mean, you were invited to Figure headquarters to actually see Figure, well before the rest of us saw it, before Figure.03. So obviously, you're on his radar. I guess Royden, you're going to have to find somebody who is
He was
within
on Elon's radar.
yeah, Elon's inner circle here.
Yeah.
But anyway, but yeah, it's interesting that Optimus isn't. We aren't seeing anything of Optimus. We haven't seen anything from Optimus for a while, and it doesn't sound like it's in the offing either, right? Well, I guess the last quarterly statement he said, originally I believe they were going to show Optimus 3 around April, beginning of April, but here we are mid-May, and we haven't even heard.
Yeah, it kind of moved.
It was actually end of last year, wasn't it? Initially.
Let's be careful. We've already gone over this, so Phil, expect some backlash here. So if you remember, the original Gen 3 was supposed to be, I think, the end of 2024 almost. There was something. It's like when the new hand was coming out, there was going to be something, and it was like, no, it's but then after all the turmoil last year, it was going to be more kind of the end of last year. It would have been December, something like that, because there were like a lot of design locks, very much like what Brett has talked about. We got the design lock, we're moving ahead, and we seem like we keep hearing those every 3 months, and it keeps moving ahead. There was an affirmative statement back in the fall that it was going to be kind of February or March. There was actually a statement February or March, and most people said that's end of the first quarter. Okay, so we know that means end of the first quarter, and gave like a little bit of wiggle room if it happens in April. That's all right. There were some things about the most epic demo of all time on April 1st that had nothing to do with V3. Some people thought it was supposed to be the Roadster. So that's another one.
Yeah.
It's like, when's that one happening? Because we keep on waiting for the flying Roadster. That was supposed to be April 1st. So here we are in middle of May, we don't know. And so the statements on the earnings call was that the earliest would be at the beginning of production, where the beginning of production was going to be late July, early August. So, but it hinges on the production schedule, and the production schedule hinges on the teardown of the SNX line and then the rebuild of this new one. And so there can be any sort of things there, which means that could slide. So the earliest, and this is really what it's looking at. It's like more middle of the year, and it's getting like that's starting to get pretty close to early fall. And
when I heard that on the earnings call, I said in my mind, I said September at the earliest. We'll see.
September is the earliest. And the other thing is that when you heard that in the earnings call, you were probably also looking at the after hours, and it went like just like that, like right at the moment you saw that come down. So I agree, and no one pays attention in August. Everyone's on vacation, so usually if you really want to get the attention of everyone, you would do it there. So I think it's also more likely.
So I think I'm vying for one of the few people that has the longest Tesla product on pre-order, which is my Roadster Founders Edition. 8 years, I think I'm going on now. You're
a patient man.
I'm a masochistic man, I think.
As soon as you get it, I'm flying out. I mean, when Neil made it, it's like I'll let you drive it first. I just want to be the passenger.
Absolutely.
Well, you let him fly it first.
But I gotta say, that first quarter Tesla conference call that we had recently, it was a little bit disappointing in that there were some pushed out numbers, right? Reality was setting in, basically there.
I think the disappointment for me was the way he pushed back on like any sort of idea of the run rate for Optimus.
Yep.
Where it was like, he said it was something that was impossible to do, and you don't understand how difficult it is. Whereas exactly 12 months before, he was like 5,000. And so I don't understand how you go from one to the other. And, maybe it's kind of realizing that, it's not going to be the numbers everyone expects. And it's not going to be, at best, it might be low thousands by the end of this year. At best. Not maybe cumulative, but that's going to be tough to make. To get there, because if production ramp up is until middle of the year, you've only got like 6 months left to kind of do that, and you've got to be getting that ramp up to right now Figure is an hour per bot, and but it seems like they're just running one shift, and based on that, you're looking at right now they might make it to about a little bit over 2,000 this year. So that's what they can do with a run rate like that. So assuming Tesla is able to do the same thing, an hour per bot, there's not enough runway left for them to get 2,000. They might be able to hit 1,000 by the end of the year, unless they go to multiple shifts, or unless they drop that down significantly to like 30 minutes a bot or something like that, which they could. But Elon has also stressed that the ramp up will be slow. He's pointed that out more than once, that the ramp up will be slow.
Look who joined us.
Oh, there.
Oh,
fresh from his tryst with
Can
royalty.
your robot hand do this?
Right?
The ultimate test.
Very good to see you guys. Very good to see you. And I'm sorry that I
we missed you.
earlier. Thank you very much.
Did you listen in on the Figure, Brett, talking?
I think I missed a lot actually, but I wish I could, but unfortunately I couldn't. So yeah.
He was with royalty.
Yeah, actual or not.
We were with royalty. Yeah.
He's not exactly royalty, right? This is
by marriage.
Prince Daniel was the gym trainer of the princess of Sweden. So yeah.
But the princess is the one next in line to become the heir. What do you call it? Like the heir of the throne.
So, while you were with Prince Daniel, we were with King Adcock.
I can imagine that. I missed that part. And he certainly is a king. So sorry, I'm not updated yet. Is the robot still running? Maybe that's the most.
Let's have a look. So this is the
there
third.
6,600. Oh my god. We are sitting in a historic moment, right?
Exactly.
Okay.
That's why we're doing an 8-hour stream. Right till the end.
I think the stream is going to be historic at this rate. I mean, good Lord.
At least for over the horizon.
Not even for over the horizon, also for Figure, also for the whole robotic community, and the whole industry maybe. Also for the, I would say, parcel management industry.
Days are numbered.
True.
Yeah.
So Roy, I just sent you a post you might want to put up.
Yeah.
So we forgot to ask him, we talked about this previously, but so they're ramping up now, and we see the exponential growth of the number of bots they're producing each month. But when V3, which is going to be like a big redesign and everything, do you think they'll be able to keep the numbers up, or are they going back to like one a day, or how fast can they ramp this?
It doesn't make sense that they would do a major ramp up, Well, we were just trying to figure out when we're going to see V3 from Optimus based on Elon's statements. And Phil and I are like kind of September timeframe.
No, I'm talking Brett. I'm talking.
Yeah, I know. But if we look at V4 and versus V3, assuming a V4 is at like the same place that V3 was around this time last year, then we're looking at almost a similar time frame, September, October, somewhere around there, when we might see V3. Maybe it goes faster because they had a lot of training and everything else they had to get it up. So we have no idea how much more. And maybe there's still a lot of hardware. So it could be that's the earliest, or maybe it's a little bit later. So depending on how successful it is, if this is going to be the future, then you probably don't want to build, 100,000 V3s, and maybe you don't even want to build 10,000. That might be the limit of what you want to do. And the only reason you'd scale it is because you want to get that training, assuming you can actually take that training and bring it over to the next version. So they may be in the same situation right now that Tesla was when they decided not to scale, because they said, this bot's not worth scaling. We've got a better one in the design pipeline that we're going to do. So it could be the same thing. So I don't know if they're, if they continue at this rate, you're looking at a couple of thousand. If they continue to ramp up a little bit, they could be hitting 5,000 this year. But I would think it would cap at 10. And maybe at that point, V3's coming, or V4's coming in, figure 4, and then just change over to that.
Yeah, based on how far ahead they are in the design lock of Figure version 4, I wouldn't be surprised if they're not going to go all out on building Figure 3s. They're going to build enough of them to do various training. But I mean, Brett already told us on this pod that the hand, in particular, the hand kinematics, don't really translate that well between version 3 and version 4. Right, it's going to take some new training to figure that out. Mm-hmm. So given that, they don't want to go for, and they aren't selling version 3 to customers either. This is all just being used for internal training. So they're only building enough for themselves. And
we can sort of back that up from the white paper that they had on BotQ, where it was like, where are these bots going to go? And it seemed like a majority of them were going to be going for in-house research, also for the training, a few, I think, customer proof of concepts, and maybe also a couple of, so the way the wording was like, more of it's still internal. And that's consistent with kind of what Brett is saying, is that be patient. We're not going to release a crappy bot. We've got to get it to that iPhone. And once we get there, then we've got something that's worth putting out.
Which bot was it in the White House?
It was Figure 3.
That's what I thought, because there was a tweet you just put up, Royden, which was you got it confused with Optimus, and it was a Figure 3 in the White House.
Yeah, it was Figure 3.
Yeah. So we haven't. The Figure 3 that we saw in the bedroom demo, that was the last time we've seen a Figure 3 walking, is in the bedroom demo, and that was pretty fluid. Mm-hmm. And I agree with that. Whoever the commentator was that the White House Figure bot wasn't very fluid. But that's the difference between a month frankly, in training land as far as bots go.
To that point, if I mean the movement of the bots today, when they've approached the bot at the sorting post, has not been really fluid as well. So,
And
it had this like, or at least when
there was some of that in training, and I think the other thing in the White House, you got all kinds of security concerns. There's probably something, whatever the policy have, it just does this, does not going to do anything else.
Actually, to that point, do we even know if the bot in the White House was even autonomous? It might not have been autonomous. It might have been totally teleop for all we know. Right?
It could have been,
in which case, it would make sense that it was awkward. Because I'll bet you the White House security goes, "You're putting an autonomous bot in the White? Are you kidding me?"
So again, and whoever the teleoperator is, there's like 2 Secret Service guys like over his shoulder looking down what he's doing. It's like, absolutely. And the other thing is I don't know how well they were able to train in that situation, because remember, did they have access to this space the night before, an hour before? And if they did, it probably wasn't full of the people that were there. It's like, did you get a lot of White House staffers? Like, you got to sit here and pretend to be this particular person and be in there. So that's what I kind of wonder, is like how you do something like that, and they just sort of make sure that nothing is going to go wrong.
Yeah, that doesn't look that bad to me.
I mean, it's pretty smooth, actually, to be honest. Yeah. Is that the French First Lady right there?
Yes.
We saw this running sequence before, and they were really nice. I think both Optimus and Figure.03 had this running thing where they kind of ran back and forth. It seemed a lot more smooth than this, but I guess that's kind of like a scripted program. So,
and it's possible it could have been trained with different waypoints that they would have put down. It's like, there's where you got to go, which means your slam had better be working well.
Oh yeah,
you should have. I didn't see any April tags there. I mean, I was wondering, let's put a bunch of them around here just so the geolocation is done.
I'm going to say something controversial. I mean, I think Macron should be a bit worried because the French First Lady looks really impressed.
Bad joke.
So, well, okay, let's move on to something that Brett has just posted. This is interesting because for cross-body reach, the policy lifts its arm to avoid hitting the metal chute. Nice try, Scott.
Okay, so someone out there was trying to troll the whole thing and saying that this is teleop because we can keep on seeing the operator is like adjusting his goggles or something like that. And you see, that's the reason why. The other thing you got to remember, and this is you see what I just did with my glasses there? It's like that you have to make sure that you get this stuff out of training policies. So a lot of time when the teleoperators are doing stuff, they may have some mannerisms that end up becoming part of the data. And that stuff will just kind of emerge sometimes at the worst time. You're going along there and suddenly it says, oh, I've seen kind of this before. Now, in that particular case, they probably have been training it that you've got to move the hand away. Because remember when the bot's going away, it's kind of going up with its hands like this to make sure. So that's to make sure that they don't hit the chute or anything like that. So if you see something like that, that's the reason. And every now and then, if you do see the bot sometimes do a strange maneuver, it could be just something that was in the training data. And I know this from having talked to some others where they had accidentally had a run where they were trying to adjust something that kept on going wrong, and they kept on going over and adjusting a thumb that wasn't working around. Rather than having a person come over do it, he was doing it himself. And then the next day, the bot's out there doing this stuff, and it also going over and like touching its thumb for some reason. And they're all trying to figure out why is it doing that. So imagine you had egocentric data and the operator's doing this, and every now and then his glasses are slipping and he does that and it does that. And then you're looking at that and suddenly, the bot puts its hand up there. So you've got to make sure that you pull that stuff out. It's going to be heavily curated. That
it's a fascinating move, really.
Yeah, and it doesn't matter. I mean, fine, part of the training data, whatever, but this is autonomous. I mean, give me a break.
This is autonomous. It is.
As Scott said earlier, this is way too fast for teleop. Teleoperator would not be able to keep up and be able to do all those very fine, fast finger movements. We just don't have that technology.
Right now, they would not be able to do 8 hours of teleoperate. I mean, come on.
So I wonder how much of training on edge cases went into that move.
Oh, it's quite possible that they already learned from before that the hand kept on slamming the chute. Oh, we don't want it to do that. And so, part of the training is like when you come around like that, the hand's got to go up to get out of the way if you're trying to grab a box in there. So again, because even with the training set for the bedroom scene, that was taught with humans at first, right? To go through and show what's going on. The humans were instructed to do a head nod. That was part of the instruction set. So the same thing here. If you've got to go over and do something, get your hand up like this to make sure it doesn't bump.
Yeah,
because if you're reaching
Yeah.
around something and you can't kind of lean over enough without toppling over, you kind of take support of that, right? I don't see it taking support. I see it more, an outstretched arm is more of guarding rather than leaning on that barrier.
Yeah.
It would be human to lean on it and reach across.
Yes. And if you don't put your hand up here, you run the danger of that arm bumping into the barrier.
Exactly.
And that you don't want that.
That's what they learned. It's bumping in there, so we want clearance.
Yeah. There was a big deal in like computer graphics when like characters in games reacted to their environment. So there were these games like maybe 2 generations of consoles or computers ago where the characters would kind of lean on rocks. You didn't have to animate all the individual leaning and everything. And that was like 10 years ago. So how hard would it be to emulate that into the bot, kind of like touching something to lean on it? Is it too much compute? Or because, as you say, I would expect it to kind of lean on it. If
they will. Once you get the whole body control, that's going to be the trick. So like when you're trying to get up into cabinets and stuff like that, a lot of times that's what we have to do. We have to lean up against things. You have to get your feet in a certain position. And to get that covered, you might go ahead and do it. So I would imagine you're going to start seeing more and more of that.
Yeah. And the again, I'll go back to Elon and his Grok Imagine, the physics, the fact that to do good image generation or video generation, it has to really understand the physics of the world and be able to have characters lean up against rocks and be able to simulate that properly translates right into a robot imagining what the next couple of seconds is going to be like and what happens.
Well, that's where ray tracing came from, right? Understanding the physics of light and bodies.
Yeah,
but for video games.
Yeah.
This is in reverse now. Yeah.
And
on my Amiga.
Yeah, Ray, don't get me started on the Cook Torrance model for ray tracing.
Go for it.
One of my professors at university, Ken Torrance, was the Torrance of the Cook Torrance model, which came out of Cornell. And Rob Cook he just got a master's for that, believe it or not. Came up with a way of really being able to figure out how light worked for ray tracing. And it's something you kind of work backwards. You go to a pixel and try to figure out where all the light sources are. And Professor Torrance was an expert in the field of heat transfer. And understanding how they work and applying it to all sorts of different situations, because radiative heat transfer is very important, especially for satellites and things like that, being able to model it correctly. And they already knew how to do all this stuff for just normal heat transfer. And they're just like, well, what if we move it into the light spectrum? And that's what they did, is they went in and started modeling everything. And they used pretty much all the data they had with all sorts of different properties of different materials. And there's this famous cover on SIGGRAPH in the early 80s showing a bunch of different vases, however you want to say it, where everyone was like doing a ray trace of a vase and they always look the same, or vase, and they're always using like Phong modeling and stuff like that, which is like a really crude empirical way, or Garot shading, to make it look like it was specular. They took it right down to literally first principles, and you could say what the material was and it would look like it. And this is what shocked everyone. It's like, what? You can actually put in the properties for steel and aluminum based on what its radiative properties were, and it would look real. It's like, yep. So yeah, so that's what happens when you go down to basic physics, is that you can go ahead and do that. And I happen to be sitting in like his class taking his advanced heat transfer. And like the end of the semester, he suddenly gave us his lecture for like 2 weeks. He said, don't worry, this won't be on the test. And we were so glad it wasn't, and we're trying to figure out what it was. And then like 2 months later, I see the paper in SIGGRAPH. It's like, oh, that's what it was about. Okay. But yeah, pretty impressive stuff.
I want to actually open a discussion that might be a bit different from this one, from the high level. While I was actually running to this live, I got an email from someone who I really admire. It was Ben Katz. Old people in robotics, such as Scott, probably know Ben Katz. And we were just discussing about the event that's coming up, and he said, I will join that event. And Ben Katz, to me, is one of those old roboticists who have been in the area for a long time, and they have shaped the industry, basically. What I was thinking about Figure at the time was that we had a wave in robotics that maybe it's not the right word, but business people started entering robotics, such as Elon and Brett Adcock, whose the background was not robotics, but then they joined robotics. And now we see all this kind of practical, pragmatic, revolutionary works in robotics only because of the business mindset that they had. And this was something that we were missing in robotics for many years, right? In robotics, we were always trying to just make push the state of the art, try to make innovations and everything, but they are trying to push the practicality. So I see a lot of comment that people are saying, oh, is it teleoperated? It's doing that, it's doing this. I think that doesn't really matter. What happens in the big picture is that we are now witnessing something that is we haven't really seen in robotics for a long time. Because for a long time we were saying, oh, the issue with robots are reliability. And no, look, we are seeing a very well example of reliability in 8 hours of work, that even the people who are actually in this live chat, we couldn't stand to, maybe the main 4 guys could stand, and also Phil, very nice to meet you. But not everybody could actually join this whole 8 hours, but the robot was doing the whole shift in 8 hours. So I think that's one of the things that we should admire tonight or today for Americans, that we are seeing something great in robotics only because of some people who were different from the original roboticists who joined robotics. So I just wanted to just bring this point and say, maybe this is the result of the work of some, don't want to say diversity in robotics, but a new perspective in robotics that you're seeing it now. And I don't really go into details. I don't say if it's teleoperated or not. I can see stuff that I can pick up on, but I would say in the big picture, this is just spectacular, amazing work. That's all I can say.
Yeah, no, it is great.
It is
and I wonder, well, in fact, I don't have to wonder, a lot of these people, younger people, I mean, like the 1X CEO is younger than and Brett's pretty young, and Elon's getting up there in age now, but Bernd, thank you. They were all influenced, all of these guys, all these CEOs are influenced by sci-fi fundamentally, right? They all talk about, the books they read when they were 12 years old about the sci-fi future with robots. I mean, that's what they're trying to do, right? They're trying to bring us into...
Yeah, but those books from Asimov, like I, Robot, were born when I was still a kid. So my generation, we read those too. For some reason, it didn't have the same effect.
No, I understand. But nonetheless, they're inspired by sci-fi.
Yeah,
no, I know. Asimov. Yeah, Asimov wrote his first, I think, first book, which was a short story called Robbie. I think it was in 1942. I think is when he wrote it.
Yeah.
And by the way, Robbie still holds up. It still holds up as a good short story about a nursemaid, about a little, a 5-year-old's friend, basically. And it's a nice story.
Yeah, but I also think this whole entrepreneur thing, it's quite new. I mean, or maybe it's just that I'm too young.
But I mean, 5 or 6 years, basically, yeah.
But there's been a lot of entrepreneurs. It's just that the technology wasn't there. So you can go through the classical. I mean, there were a lot of people that were trying to help.
Let's argue that the mindset was not there. As a roboticist, you don't have the mindset of scale. You have the mindset of building something that impresses people. but only one unit. But if you build hundreds of units and it can work hundreds of hours, that's a very different story than being a roboticist building that. I'm sorry for cutting you off, Gustav, but yeah.
No, I think it's like similar in medicine, because previously in medical research, you had to have someone who came up with a nice idea by accident or by doing something else, and they, oh, we can apply this. But now there is this mindset, or these entrepreneurs who just, and sorry for saying it, throws money at the thing. They're convinced that I will solve this. And in academia, we could never do that. We could, okay, I can get a grant to pay for 1 or 2 years of this project. But it's like, okay, we can afford everything. We could throw money at it. Like this Neuralink, for instance.
I was just about to say, Neuralink is an absolute case in point, yeah.
Yeah, we've had these interfaces for over 30 years, probably, people working with this. But now we have like this, it's out.
But I wonder how much it is,
money.
How much it's a function of throwing money at it, in addition to bringing the right team together and giving them the right focus.
Yeah, but I mean, you could never do that in a research environment. You could.
That's the job of an entrepreneur, to put a team together, right? To build a company and everything.
That's where Elon is great.
Yeah, and I mean
the teams that he puts together, the way
in the early 2000s. I mean,
so Elon, so you know who kicked off the humanoid robot revolution, the modern one, because we had Asimov like 20 years ago plus, but it never went anywhere. So the latest iteration of all this was in fact Elon, and he could have kicked it off, 10, 15 years ago, because I'm sure he was thinking about it 10, 15 years ago. But he waited until he actually said these words. He said, now is the time. So what had happened is that AI had gotten good enough so that you could actually take on humanoid robotics. So you need it's a combination of things. You need the entrepreneur to actually do it, but you need the technology as well. The technology had to mature.
And I mean, at the end of the day, everybody's standing on the shoulders of giants that came before, right? So
Sure. But the Neuralink was a good example, right? We had the Utah array, I think is what you were talking about, the 100 pin, literally 100 pin thing, which they smushed into some poor person's brain, usually for epileptics. And that didn't necessarily require any new technology. That one just took Elon to say, well, we can do better than that. And they have, right? I mean, you just had to try it and then devote $100 million to the effort or whatever he's done to it.
And I think that's what kind of inspires me, is that I see the opportunity for a lot of other fields as well. When it comes to, of course, AI will help. Cancer research will probably go off on a totally different level, because we have all this protein folding software and AI kind of doing the work for us. But I mean, without the massive amount, someone needs to have the capital and the interest and the inspiration to go there. And I don't see that we had that before the 2000s, even if there were a lot of money. But
it's also the risk on tolerance, right? The appetite to be risk on.
Yeah. And that is new, I think.
Well, we had that before the 2000s. I'm sorry, but I mean, how do you think Intel got started? Intel was a company that started in the 1970s as an outgrowth of Fairchild Semiconductor engineers, and they were absolutely a VC-backed company. Apple was a VC-backed company in the late 1970s, I believe, or at least 1980, thereabouts. And that was the heyday. I mean, I remember when Sequoia backed Apple, that was, so we've had, and credit to the United States financial system to have a very deep venture capital system, even back then, and it's only gotten deeper since then. In fact, it's gotten so deep that it's gotten ridiculous in that if you want to have make a lot of money investing in companies, it used to be that you would pick like a Tesla, you would invest Tesla when it first went public. Nowadays, you kind of have to invest when they're private, because the VCs and the private money financial system is so deep that companies are going, oh, I don't need to go public, right? The only reason I went public before was to get access to tons of capital. But now you don't need to. You can stay private for a long time. And most of the profits end up accruing to the people that can fund the private companies. So anyway, the point being is that the U.S. financial system has just gone more and more and more sophisticated over time. But it was like that a long time ago. I mean, venture capital as an industry has been around for a long time in the United States.
Yeah, but where would we be without ImageNet? None of this would have happened.
Well, on AI, sure.
Yeah,
on
exactly.
the AI side.
That's the difference, is that without ImageNet, it's still classical robotics. That was the main thing, is like, once AI got up to that phase around,
it's just heuristic code.
This was obvious that this was going to be the future. But
without it, look at Boston Dynamics, for example.
Yeah, they never went anywhere, really. I mean,
yeah. I mean, to Mirdad's point, there's like a rather famous quote. I don't know if you saw Scott Lavalley's quote back in the fall. He was interviewed in the Register. Mm-hmm. And it pretty much explains this problem. Okay, so basically, he spent 7 years at Boston Dynamics as the hardware lead on the company's 3 humanoid robots, Petman, Atlas 1, and Atlas 2, and competed in the DARPA Robotics Challenge. Now, here's him being quoted. Then we got bought by Google, and Google wanted us to turn a profit, Lavalley said. And we all looked at each other and went, we don't know what this is good for. We've just been a really well-funded research lab for so long. We're just having fun here. We're not trying to make this profitable. So, I mean, that's right to Mirdad's point right there. And that everywhere in a lot, because there were kind of 2 levels of robotics. There was these really classical robotics, like you see the manufacturing robots everyone's putting into. And then there's people that were trying to do research in the next generation robots to come along. And the thing is, they were kind of, if you were a classical roboticist, you never mentioned humanoids in polite company, because everyone was just really skeptical of it. And it was just kind of the stigma. It's like, what? You're one of those? So even if you're a fan, you just didn't do that. And it was like, these other crazy guys can work in the labs. Those Honda guys at Asimov, oh, that's really cute. But, if you're serious, you're going to be going over here working with the traditional stuff. So it really wasn't until Boston Dynamics started, I think, to change it a little bit. Mm-hmm. So it takes R&D and stuff like that to do it. So they suddenly brought that into it. So, I mean, we keep on thinking it's like, oh, it's 2020 when, or was it 21 when Tesla came out with it. No, it really goes back to the early teens. I mean, these things were viral for years, remember? I mean, not just this one. The other one's like running around. This is much later. Running around the woods, everyone was just going crazy about.
But this is all heuristic code, by the way. This is not AI.
That was all heuristic.
AI stack.
But what it did is it planted the seed in a lot of people's heads. Wow, maybe we can do this. Now, of course, at that time, we couldn't really do it because that had to be hydraulics. We didn't have the actuators technology there to really be able to do a fully electric robot, which is exactly the way the industrial robots started out the same way. They started out hydraulic. And the other thing we didn't have is we didn't have the smart. Now, we were starting to get the compute in a way. Everyone was thinking like, oh, our CPU is a lot faster, our code will run faster, all this other stuff. And it's getting better and better. And then suddenly, the ImageNet stuff starts having, and suddenly the whole, and then by the end of the teens, everyone's like, wow, maybe we could. And they weren't waiting for GPT. I mean, they were seeing it because classical robotics has been trying to do sensor-based stuff for years. By having camera systems. So camera systems have been around for a long time to help robots identify different parts and locate them. But the way they were being done was very crude, very, 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 very crude. But you still could kind of do it. And now suddenly you had this AI unlock, and everyone in classical robotics was like, oh, wow, man, we're going to have smart cameras now. So that already they're seeing that as an unlock to be able to get things going. And then everyone's thinking, well, wait a minute, maybe even the hardware form factor can change a lot. And it's not just putting a smart camera on the end of an industrial arm.
Absolutely. Yeah. Scott, to your point, I can say that I always try to clarify this one, that humanoids were built to study biomechanics. They were not to do anything useful. I'm talking about 30 years ago, right? So they were built to just see how human body works, how the balance works, how the locomotion and control system works. But it's only the past few years that we saw that some people started to utilize the systems. And Phil, to your point, I'm trying to slightly be careful to not to overhype who was the starter, because some people might argue that maybe Unitree was the main starter, who actually tried to democratize these systems and make the robots so cheap that everybody could be able to now think about putting the application layer on it. Because before application layer, all the concern was just about the technical layer. And also many people can argue that, yeah, maybe Optimus is not the best robot out there. I'm sorry if I offend Tesla fans, but it's just that it's a very, very complex mix of gradual changes, basically, we see here. And Scott is totally right. It's like something has changed here in the past few years, and we see this clear cut between the modern robotic and classic robotics. Because 10 years ago, when I was in a research lab, we were not talking about classic robotic and modern robotics. We were just talking about, oh, the people who work on humanoids, we don't take them so seriously, and that who work on actual working robots, right?
Yeah, no, it was when Elon said it's time for humanoid robotics was the actual time. I mean, Unitree didn't come out with a humanoid robot until about 2023 or something like that.
They had exactly. Yeah.
They had robot dogs before that.
Yeah.
But so you know, Elon hit that I think inflection point. And by the way, to Elon's credit, he started the Optimus program, I believe, before ChatGPT came out.
Yeah.
So you know, before the rest of us, you know, woke up to the fact that holy shit, real AI is here. He saw that it was coming, right? He knew it was coming.
Well, he knew it from full self-driving that it was coming. And I think the other thing is his bitter pill was the Model 3 ramp up. Because they were told you could automate the whole thing, and they went out and they started to do it, and they found out there were so many things they couldn't automate. And so if you remember, it was something like the soft panel lining they're trying to put underneath with a classical robot. And of course, when I heard that, I'm just like, oh boy, I can understand why. But they learned the bitter lesson that flexible automation doesn't like flexible components, and that everything has to be stiff and rigid. And I'm sure after he came to that, he was probably just thinking, it's like, why can't these robots do it? What's going on? It's like, why are all these things that has to be done by a human form factor? We can't figure out how to do it. So it probably planted the seed and said, why don't we build a humanoid now?
That one thing, it was called the fluffer bot, by the way.
Yeah, the fluffer bot, yeah.
Yeah, the fluffer bot. And that was interesting for a whole bunch of different reasons, because what that fluffer bot was trying to do was in the battery pack, it was trying to put a piece of noise abating foam or fiber or something like that. Think of a felt sheet or something like that.
Exactly.
Like a felt sheet. And it was for noise and vibration. And so they were they were banging their heads against the wall. It wasn't working. The automation wasn't working. And then at some point in time, Elon got so friggin' frustrated. He said, well, why do we even have this? And so he started walking around the factory going, who is the person that said we needed this in the first place? And he couldn't find anybody who would actually take responsibility for this sheet of things. So he said, fuck this. I mean, let's try it without the piece of felt there. Let's do tests, A/B tests. And it didn't make any difference. And it was like, oh my God, what are we doing here?
It was like some guys that said, well, we need it because the harshness vibration guy said we needed it.
Yes.
It's like, no, we needed it because the thermal guy said we needed it. And they're like all pointing fingers and like, wait a minute, you mean we didn't need it? No, you didn't need it. But still, whether they need it or not, it came down to the fact that there are still things you cannot do with automation.
Right.
And and the answer was, why not? And a lot of times because the form factor is wrong.
Yeah. So I mean, here's my example I like to give to people. It's it's an iPad, right? This is my thing that I write all my notes on and stuff like that. And the thing about an iPad is that it came out in 2010. I had the equivalent of the iPad from a different manufacturer, God only knows who, in 2000. I bought one in 2000, 10 years before the iPad. Mm-hmm. But it kind of sucked. Why did it suck? Because flash memory was not a thing in 2010. You actually had to have a hard drive, like an actual spinning hard drive in the unit, and it was slow because of that. It didn't boot up fast, and I used it, but it wasn't it wasn't an iPad. So when the iPad came out, the technologies had matured to the point where you had flash memory, and an iPad was like this instant on, perfectly functional, fast thing. So you really do have to wait till technology gets to the point. And so, I gotta say, my dear mother, who has passed away now, I gotta say, you were wrong. I'm sorry, but the gamers had it right all along, right? Because we wouldn't have AI, or at least we wouldn't have this version of AI if it weren't for all the friggin' gamers, just pushing the whole industry forward to get better and better and better graphics. And that's what the whole AI is based on.
Since we're on the subject, let me just bring up this video that Gustav shared.
Yeah, and this is perhaps a similar vein, but not. I also had a phone in the early 2000s, way before iPhone, that did exactly what iPhone did, but it never got to you. So this is a
Sony Ericsson P900.
Yeah, exactly. But this is also a robotic hand. This is a myoelectric hand with a worm drive gear to control the opposition of the thumb. The thumb is fully actuated to go into an opposition, and this hand was designed in the 60s, so it's over 60 years old. So, I mean, I'm
jumping to dinner. I will be back in maybe 20 minutes.
No worries.
I mean, it's easy to say that, oh, look at this really impressive hand, but come on, this is a lot older than me. And the figure video that we've been seeing all day is basically this hand. It's just that it's been put on a bot and not a human. This was an early concept for a human like prosthetic to have a myoelectric hand. So it was controlled by your stump, basically controlling the actuators in this bot hand. So it's still available I think it's in it's called the Belgrade hand. So it's probably in the museum back there if you want to go visit it. So, I mean,
yeah, if you look at like what DLR did, something around 15, 20 years ago in Germany, they created amazing dexterous hands. And they were as good as maybe roughly as good as today's hands, but they were not really reliable, and they were like very power consuming and everything. So we had all this technology way back, but I think now what has changed is the scale and capital and reliability and all those factors.
And maybe as Phil is going on to like the intersection of developing technologies, kind of like the iPhone. You couldn't build iPhone in the 90s because you didn't have the size of the microprocessors or the LCD screens or the LED screens. But when all these technologies kind of converge, you can produce these products.
Yeah, true. So for anybody listening to this right now, we did have Brett Adcock in about 2 hours ago, something like that, maybe an hour and 40 minutes into this ridiculously long pod stream, and it's worth listening to that. If you're listening now, keep on listening to us, but go back.
We're going to go right to the end.
yeah, we're going to go to the end.
But I'm going to clip it up and post it as a video separately. So watch out for that. Subscribe to Over the Horizon, and I don't normally do this, but hey, click the like button.
Yeah, no, and the Brett Adcock segment is very illuminating. He said a lot of interesting things. There was a bunch of good questions asked by everybody that was on the call at the time.
Yeah. Things we haven't heard him say before.
So there's this question from Christian Franklevars. Sorry if I butchered your name. Is it sustaining pace? Let's take a look. You had done the calculation, Gustav.
Yeah, so I asked Grok very early on, what is the human pace in these kind of settings? And depending on what type of packages you're using, it differs. But in a UPS setting, which I would say this is like postage packets, not too big packages, it was going from 22 to 25 packages per minute. And up until 2,000 packages, it kept a pace of 23 packages per minute. So it's right in the Goldilocks zone or whatever you want to call it, just right.
Yep.
Yeah,
I just did
it, and it's been doing it for 6 hours now. Sure,
I just did the calculation. It's 21.8 packages a minute.
Oh, slowing down a little bit, but still, yeah, it's. And as we were talking about, the accuracy is not perhaps as good as a human would be, but a human would have had to go for a lunch break or a pee break.
How much was it in the beginning, Gustav? Was it about 22 or 23 per minute?
22 to 23, depending on when you checked. So in the beginning, 22.5 and then 23.
Okay. So here's a viewer question. And Mehrdad, I guess you'd be the best one to
No worries.
take this. What's going on with Japan's robotic development? They always seem to be the leaders up till 10 years ago.
It's a very good question, actually, because there are two countries. One is Japan, the other is Germany. I've been witnessing, 12 years ago, I was in a robotics lab in Germany, a robot called Lola. And Lola was the state of the art in locomotion back in that time, from Technical University of Munich. They stopped at some point. Same as Japan. They stopped at some point. The best progress I see from Japan nowadays is on the companion robots, social robotics. They have great progress out there. They have robots such as Lovot, L-O-V-O-T, if I'm right. And these robots are mostly on the elderly care, children interaction, and those kind of things. But on humanoid level, they stopped at some point. And to be honest, actually, in less than 2 weeks, I'm going to Humanoid Summit in Tokyo. So and we have a lot of Japanese guests there. So I would like to really ask them what happened.
We should do a few live streams from there, Bharat.
Absolutely. We'd love to. And the one funny thing is that I was talking to somebody from a venture capital, a very big venture capital in Japan. I can't mention it. It was a Kawasaki venture capital. And I asked the exact same question: what happened to robotics or human robots in Japan? And he said, what happened to Japanese technology was that at some point we were not fast enough to be on board with software and AI. So Japanese people are great at hardware, but they are lagging a bit on the software side. So maybe Scott actually had a very good point. He said that one of the reasons that we have all these humans nowadays is because of the AI and software developments, which I kind of very much agree, actually, because although we had a lot of hardware, like Ben Katz's example was the guy who kind of invented QDD actuators, which the actuators that is running today's robots, but on the hardware side, but also on the software side, if one country or one company cannot really advance on the software as much as hardware, it will lag behind. We had Osimo back in that time that was even running, which running is a very complex task for a robot, but then we no longer see much from them. It's funny, actually, there is a Japanese company I'm in contact with. They are building a humanoid robot, but there are two founders. One of them is Norwegian, one of them is Dutch, and they are living in Japan. So they're not even Japanese. But yeah, to that question, to be honest, I don't know. Maybe in two weeks I will get more answer on that. But it's a very interesting phenomenon. What's happened in robotics? I have another example. 13 years ago, there were only 6 countries. 6 countries. You can validate this on Robot Guide on IEEE. 6 countries who could build human robots, who were involved in building human robots, and China was not even one of them. And US was not the best of them. But today, China and US are leading. Europe is lagging behind. What happened during this 10, 12 years?
But was China making the parts in the supply chains?
I'm not sure, actually, because we were using a lot of Maxon motors, which were from Germany, and dynamic cells. And dynamic cells, some parts of it was built in China, but dynamic cell from nowadays is being sold by Robotis, and I think it was American, the company. So even the supply chain was not so much dependent on China. It was mostly concentrated in Europe and US. But things has changed, and we have seen this. So yeah,
it's interesting. And sometimes I wonder if it's, I'm not going to say person-based, but in some ways it is. When it comes to these research labs who made these really impressive hands maybe 15 years ago, sometimes you see these publications of a really nice dexterous hand and you say, oh, this is going to develop into something really impressive. And then all of a sudden this postdoc or this PhD leaves that lab, and then that project is never seen again. And I can kind of think that's the same thing perhaps in Japan. So you have these individuals or these groups of people within the company. It's like, okay, we're going to focus on this now to show our capabilities in manufacturing or whatever. And when they leave or when they retire, then the project just goes away.
So very good.
Do roboticists retire?
What?
do roboticists retire, or do they just dismantle?
Because I mean, there were these really impressive hands that I've saw many years ago, before I even got interested in this whole robotic humanoid field, way before Elon showed Optimus. I was like, what happened with these hands? And then you meet people like, oh yeah, I worked in his lab 10 years ago, but he went on to another position at another university, and I was only teaching, so the project kind of died down. So it's a bit sad that it's so connected to individuals and individual projects, and not like the whole country rising up to it. And maybe it's coming back, but it's the same with Elon. It's like he's one individual who has a vision and has a lot of capital, and he has a lot of drive, what do you call it, like he's pushing this at the moment. But if he finds something else to do, maybe it's a risk of Tesla dropping the ball on this as well.
Absolutely.
Yeah.
We need entrepreneurs to push this through. Researchers wouldn't do that. Researchers, they have other concerns, right? PhD students and postdoc students and like scientists in the universities, they don't have enough budget to scale anything. They just want to push the boundaries of their science, right? That's their job. And
they're also risk averse to an extent, right?
They have nothing to risk. I mean, there is no funding for them to kind of push it. So they can sit at home and like 3D print a new model, but then that's the end of it. They're not trained in like raising the capital, I think, at least not in medicine. It's like you work within a group and you have a project that you get attached to, and you get some ideas. Perhaps you get some funding from your local or national funding agency, but we're not trained in attracting the VC money that perhaps the US is a lot better at kind of supporting.
Yeah, the other thing that happened, the other thing that happened with Japan, by the way, is just economic comparative advantage. Japan ended up being really good at manufacturing early on, and they stuck with it, right? So that they realized that as a country and as an industry, they were really good at manufacturing. So, and they weren't as good at software, right? Software ended up being a United States dominated thing.
Right.
So I think that's just what happened. They just specialized.
So I wanted to ask you a question, Phil, about what Brett mentioned in Merdad. You missed out this thing, but it's interesting. It really stood out to me. The reliance on Chinese supply chains for parts was increasingly less at Figure.
Yep.
And that really stood out for me because that was a clear sign of confidence that. So there's so much of talk about Elon looking over the horizon, looking at supply chains and kind of insulating his supply chains from geopolitical risk. And it seems that Figure is doing an equally good job, if not a better job at that. What do you think, Phil?
Yeah, no, Brett was very emphatic about the fact that he uses I think he said almost no supply chain from China, and to the extent that he does rely on China, it can be easily replaced if it needed to be. So, and to some degree, it's not surprising if you think about it, because they are building every piece of the robot themselves. They are not importing, motors. They are not importing stators or.
I'm not sure
anything.
if he said they're building, but he said they're designing.
Oh, they're building motors. They are.
Okay.
Yeah. And again, that's not surprising. I mean, look at that hand. That hand's very small and yet functional, and all the motors are in the hand. I mean, there's a lot of very precise stuff being built there.
There's another example that we just saw with a box, and Figure bot just flipped around, looked at the other side.
Around. Yeah. So and Brett also said that he didn't think it was anything that unusual. He basically said, hey, look, the U.S. manufacturing in general is insourcing. Like Anduril would be an example of a startup manufacturer, right? Which for defense reasons, security reasons, obviously is insourcing. But the point being is that you can insource in the United States. You don't have to rely on China. It's just that it's probably harder and it's not as easy as doing it in Shenzhen, right? But then you have to be local to Shenzhen to really benefit a lot from that. Anyway, the point being is that I think this thing about China being the manufacturer for the world might be oversold a bit. It doesn't have to stay that way.
I totally agree with your point, Phil. I just want to add something on top of that. So the way I see the world is divided, when it comes to humanoids, is divided into 3 different sections. So we have US, we have Europe, European Union mostly, and then China. So what has happened is that US or most of the human robot companies in US, they are having very high valuations and they get a lot of capital. So when you have so much money, when you raise close to $1 billion, of course you can manufacture whatever you want. But if you are a startup in Europe, in France, in Italy, in Spain, in Denmark, then you have to source your bill of material from somewhere cheaper, because your valuation or the money that you raise is 1/10 of what US companies raise. So that's one issue that I see, that is like, Brett probably said this in a position of raising a lot of money, but most of the humanoid companies out there who are rising now, they don't have that much capital basically to be able to manufacture everything in-house. So he's talking from the strength of power, maybe we can put it like that. But most of the companies I work with, and I'm a consultant at humanoid companies, they are actually have to be reliant on China because they don't have that much capital. And I think that's like the simple equation. If you have a lot of capital, of course you can build everything in-house. If you don't have capital, you have to be reliant on China.
Sure. Yeah. So anyway, so that figure is good for U.S. manufacturing, and it'll take time, right? It takes time to build a manufacturing plant. I mean, exactly. Elon's building his what, 10 million a year or maybe higher, I don't know, Optimus factory in Giga, Texas right now as we speak. The foundations are being poured literally as we speak. But that's a giant factory. It's going to be a couple $1 billion. So it takes a lot of capital to do that. It takes time.
And to be fair, Phil, I mean, we don't want to sound as if we're anti-Elon or anti-Tesla or anything. To be fair, you don't put that sort of capex in if you're not confident about your product, if you're not confident about Optimus, right?
Quite right. I mean, and that's what I was saying earlier this year when we were seeing the Cybercab line being built. And we knew, because he was very consistent on this timeline, that the first Cybercab production would happen in the beginning of April. And based on lots of third-party people input, it was like, yeah, it really does look like April is going to be the timeline. Well, what does that mean? It means, assuming Elon's not an idiot, and we all know he is not an idiot, it means that if he's built a high volume manufacturing line to start production in April, it means he's pretty darn sure that robotaxi is going to be a thing this year. Now, it turns out that there was an extra step we didn't really realize in robotaxi, and we should have realized it. If we had thought about it for more than 5 seconds, we would have realized it, in that whenever you have a new vehicle embodiment, like the Cybertruck. So when the Cybertruck came out, its full self-driving version sucked in comparison to the other versions, right? The Model S, the Model Y. And why is that? It's because the truck was so much bigger than the Model S. The poor model that was running in the Cyber, and I ran Cybertruck. I don't have one, but I borrowed one for like a weekend. I ran the heck out of it on FSD. And you could tell that the model thought that the truck was a lot smaller than it was. It kept, on small country roads, it kept kind of running off the road a little bit, right? Yeah. The tire would get up on the gravel. Living on the edge, it would ride, and it's because the model did not realize that the truck was as big as it was. So right. you need special training, and you need miles, lots of miles, to train the model to make it understand, in its core, that the size of the car that it's and the dynamics of the car that it's manipulating. So the same thing's going to happen with the Cybertruck. The Cybercab, is that the reason they're pumping them out right now is not to put them into robotaxi right now, but it's to train the friggin' Cybercab model. And so, robotaxi is happening. It will happen towards the end of this year. Anyway, all that said, to say that when Elon builds a factory, he's sure that it will be used appropriately and on time. Because otherwise, it's like $1 billion mistake. It's like it's a minor problem. It's like getting towards existential problems for the company. So the fact that he's building an Optimus factory right now, as we speak, in Fremont, which will be relatively high volume, and then building the giant one in Texas, which will be huge volume, that's very confident, inspiring. I mean, that's somebody who's confident. I mean, we're sitting here on the outside. We say, well, Elon, you haven't really shown us anything about Optimus. And it's true, he hasn't, but we do know, actions speak louder than words, and his actions are, he's spending a couple of $1 billion on this thing. Yeah, no.
Thank you for saying that, yeah.
He's spending a couple of $1 billion.
The reason I'm saying that is that there's another thing that Elon said on that Q1 earnings call, was that something he's been saying consistently is that it's going to blow everybody's mind because it's going to be so human-like, right? So my question to you across the panel, take a look at this. Okay, now this, I just pressed the wrong button on the switcher. So how much more human-like than this can you get?
Than this? Yeah, a lot.
It's pretty human-like already.
Well, it's riding its imaginary bike now and then. But just before we go on, and I'm not gonna take away from. I agree with your point. He's not gonna build $1 billion factory if he doesn't believe in it. But you had the battery factory in Germany being built many years ago, and it hasn't churned out a single battery. So there he kind of like bet the money that, we will have the technique ready by the time that the factory is built. But I don't think or maybe they're starting now, but it took a long time for them to actually build 4680 in the German factory. So it might be that, okay, if we build the infrastructure, it will be there when we have the finalized design.
Gustav, you're right. Your point is right. And it wasn't just the German factory. The 4680 wasn't ready in time. It was also the US factories as well. And in fact, they tried to put the 4680 into the Model Y, and then they realized they couldn't build them properly and fast enough and everything else. So yes, companies do make mistakes from time to time, and this one wasn't a mistake from that they weren't ever able to do it. It was 2 years late. And by the way, that 4680 delay probably delayed everything. It probably delayed the semi-truck. It delayed the Roadster. It delayed a whole bunch of programs. But they've recovered from it. So you're right. Just because they're building that Optimus factory and it'll be ready by the end of 2027, doesn't mean that Tesla will necessarily be ready by then. But anyway, Elon thinks they will be, and he's got a couple $1 billion to think it will be.
So Scott is back. Let's do a quick round the panel poll. So Scott, my point was Elon's other statement about the delay, while he said that he doesn't want people copying and analyzing it frame by frame at the Q1 call, he's also spoken about just how human-like Optimus 3 will be, right? So my question was, okay, we're looking at something that's already very human-like here with the Figure.03 bot. Each one of you, please, what to you would be the form functions or the design or the features that would perhaps be a lot more human-like to be mind-blowing enough in Optimus 3? What raises the bar as high as Elon is kind of pumping it?
Okay, can I just take 2 notes here? I was listening in while eating dinner.
Okay.
That we can come back to. One that Mirdad was talking about a little bit earlier about the hardware and software stuff and how important that is. And one of the points that Brett made about the version 4 coming up is that they're actually building the AI and the hardware together. And they've always been kind of separate. And the real key is that you think about building hardware meant for the AI and AI meant for the hardware. So that was like my big takeaway and how important it was. The other thing that Phil is pointing out is very interesting is that I had always wondered when FSD was coming out that Tesla had 4 models at that time. And it seemed like every new version came out and it had no problem. So it handled the S, the X, the 3, and the Y. And maybe it's because those embodiments were pretty close. But then, the Cybertruck, it didn't work too well. And I was like wondering, it's like, Is it something to do with the fact that it's like, this new architecture, this fly-by-wire or drive-by-wire, four-wheel steering? Was it just that it was heavier? Was the vehicle dynamics so much that they had a really hard time tuning it in? Took them a while to do it. That makes you think, do you have the same cross-embodiment problems as you go from one humanoid model to another? And how closely you have to make sure, if you want to save the previous generation's training data and bring it over, where there's also going to be a mismatch, and how difficult that was. Because, I mean, come on, the 3 and the Y, they are pretty different. And definitely the X, so if you go between the 3 and the X, it's like, wow, they were all able to work. And they had way more training data for the 3 and the Y than they did for the X. So there was kind of, it's rather interesting that they're able to do it there, and that it kind of, so that means no one quite understands exactly what it's like to do cross embodiment. So I just kind of want to bring that. Now, your question was, what are they going to do to make it more human-like? And I guess part of it is the silhouette, right? So if we look at the Figure.03 bot back there, if you look at the waist, you could say, oh, that doesn't look like a human being. And we've seen like a bunch of the other Chinese bots as well in Figure, that you can tell it's not a person in there, because there's no person could actually fit in the suit. So a lot of times they're going around, everyone goes, that's a person in a suit. It's like, no, they're not. Look at that waist. It doesn't exist. And of course, the other thing, you look at the elbows, you look at the wrists and everything like that. There's all these mechanical things that are kind of sticking out and behaving and looking a little bit funny. There he is doing the shimmy again.
Imaginary bike.
Back and forth. And
I think he's just doing the shimmy to show off.
Recalibrating right there.
Yeah.
So, I mean, those are the things that from the silhouette, you wouldn't be able to tell the difference between the two. That's going to be the first thing. The other, of course, is the motion has to look fluid and human-like. It cannot look at all mechanical or stiff. And then, depending on how far you go down that tree, it also can't sound like a robot. So when we heard the Figure.03 video with the bedroom, they had the sound on. You could actually hear the bots, and they make a little bit of mechanical noise. Partly the way they walk, they stomp a bit, and you also get a little bit of the whining sound from it. So I mean, those would be little things. And the question is, does it look like a human in a video versus does it look like a human in person, where you begin to notice it's a little bit different. Even the Xipeng robot, when they came out with what I call Iron Maiden, almost looked like a person in a suit, but you could definitely see these protuberances here and there where you could tell, those are where the mechanical joints are, those where the actuators are. They were kind of sticking out. And even though they tried to put cushioning and everything around there, you can only get it so far before it begins to actually look more robotic than it does human.
So my big thing is, that's interesting on the hardware. My big thing is speech and interaction. So we haven't really seen super smooth speech interaction between a human and a robot.
I like your point. Yeah, absolutely.
Yeah. So once we get that point and having the robot interact and actually do things based on human speech, I think that would be a big thing. And Tesla has all the ingredients for that. And it's interesting that Brett said that that's the next thing they're going to be adding to Figure will be that capability as well. So,
And the question is kind of going back, what makes something human is its face and its hands. And if they look very human-like, then we will relate to that. And earlier in this live stream, we were talking about the attachment you might have to these bots. And when you have that particular face, even though you will enjoy kind of having it do these things, I'm not sure that you get quite the same attachment. Maybe the speech will do it, but already people can say when they look at the Sunday bot, it looks like, it looks very adorable. They love the look of this. They could become attached to that. The same thing with Neo from 1X is like just the fact that it has eyes and stuff like that. It seems to have a little bit of personality that those will be the bots people will probably have a harder time giving up because they'll make that attachment. And the question is Figure 4 going to kind of go on that route? Are you going to see the same thing from Tesla, where it's more than just what is basically the robot from Lost in Space, which is a bit frightening, right?
Yeah.
Will Robinson
is extremely important, and it's not just the hands and the head, but whenever we see, if we talk to a human or we see a human move in an unnatural way, sure, the shape and the look is very important, but also how we move. I mean, I have parts of my education is introducing students to dissections and the dead human bodies, and going into a room where the human is lying in the bed, quite almost directly you understand there is something wrong in this room if the patient or individual has passed away. And it's not that the soul has left the room or something, but we subconsciously we see the movement of the rib cage when we're breathing, and like slight movements. And if you don't think of it, you hardly notice. But when you go into a room where someone has passed away and they're lying deadly still in the bed, you notice that. And it's the same with like all these unnatural movements. We react to them very quickly, and it's of course for the hands, but also for the shoulders and elbows and knees and everything. As soon as this bot goes into this riding the bike position, it kind of breaks the magic. So this uncanny valley of moving very naturally, I think is really hard to achieve, even if it wears a ski mask or whatever. So the hands will be really important, but also everything else, just like how we're looking at things. And if it's just standing perfectly still as the bot in the back, I mean, they look dead. But then when it was like kind of waking up from its charging, they were like, oh, now it's straightening itself. So I think these things, that's going to be a long time off, because we don't have, even the guy walking in the back, sure, it's walking, but you could directly see just from the silhouette that that's not a human, it's a bot. So I do not expect us to see, oh, you won't be able to, you will think that it's a human in a suit. No, you won't. It will move. The only one that has kind of really tricked me, aside from these AI ones, is the Chapang or Xpeng one. There I really thought, okay, this is a female in a suit. That's the only one. Otherwise, all of them, it's so obvious that they are bots.
Yeah. What I can add on top of that, I really appreciate the point about HRI or human-robot interaction. To me, what divides a robot from a human is dealing with uncertainty and edge cases. When I was looking at all these parcels that were coming up here, I saw that there is actually a loop. They are the same parcels going on and on. What if one of them, the label is scraped off? Or the size of the package or the geometry of the package is a bit different from the other. That's where human shines, basically. We human are very good at dealing with uncertainty, but robots, they're just good at dealing with whatever they are trained for. So to Royden's points, if I want to say more human level behaviors or actions or motions, I would just see, oh, what if actually one of the boxes drop on the floor? What would the robot do in that scenario? How would it deal with that? What if one of the parcels is just a shape that is not box, not a plastic part? Actually, yesterday I received a parcel about it was a ski, some ski basically, and it was like a very weird size. Like even at the airport, they call it unusual size parcel or something, right? So how does it deal with those kind of edge cases, edge scenarios? Because that's where everything actually matters. That's what defines us.
Yeah. The thing is the question of how much curating of these packages is sort of done ahead of time, and that those special parcel things like that, they usually go somewhere else. So the assumption is like no skis are going to come down here. But you're right, there could be like an interesting Valentine's Day package that's like shaped weird that comes down like, whoa, what's that? Normally they always require it goes into some packaging. Now, there is one good point that you sort of make here about everything circulating around and around and around the same packages. And that is, these packages are starting to get worn down. Mm-hmm. And that means your training data is training on packages that may not really exist in the wild, as far as how they're either scuffed or how they may soften after a while or something like that. So a lot of times this is happening. I've already talked to another company that was doing something with a part, and they were putting in there and said, yes, but the part stiffness is changing over time because it was a flexible part. Mm-hmm. And like, yeah, you're right. So, but you should probably be always training with a virgin part each time.
Mm-hmm.
because, you know, whatever rough edges are on there or whatever stiffness it has, that's what you're really going to be encountering. You're not going to be encountering the one that's already broken in. Now, with these packages, I have a feeling they're not going to degrade very much no matter how many times they go around. But that's one of the things you have to be kind of concerned about is your training data degrading if you keep on using the same part again and again and again.
Yeah,
and
and to
throw a bunny in there or something, like a soft toy or something. You have him on speed.
Yeah. Now realize that Figure really doesn't actually care about this logistics training at all. All they're trying to do is they're trying to train the base model, because they're not going to be putting one of these bots into logistics customer this year, right? I mean, they're trying to gather data for like a very general robot embodiment. So this is just one of many tasks that they're doing. So yeah, I don't know. It and you can kind of tell, right? Because it's making mistakes, and I don't know. Anyway, yeah.
Oh, get that one right for this time. Those cubes
Did
are
it
always
finally?
tough. They finally get
Actually,
the cube right.
my concern is that it doesn't make any mistake. So that's where I become suspicious. I'm like, I've seen many robots demos and many robots doing things autonomously, and they do make mistake. Agility robot, as Scott, I think you said in the chat that Agility had this demo of a few hours actually with the, and one robot, it was dropping the box in every 2 or 3 hours. It dropped the box 9 times, and it's a mistake. It happens, right? And we understand that an autonomous system would make that mistake. But here is everything is very smooth, so it, you know, when like everything's so perfect, it makes you suspicious that there must be something something being very well trained for. So I don't know, Gustav. Surgeons also make mistakes, right?
Oh,
Never.
that's why you have insurance.
True.
I mean, yeah, we talked about that. To err is human.
Yeah.
But for the robot, there is no mistakes. I don't know. Maybe that is what will differ in the end. I mean, when they move like us and they talk like us and they interact even better than the best of us, they are too perfect. I mean, I still think that in a few years, you won't go to a psychologist. You will just talk to your AI. It will know you better than any human being can ever do, and it will know exactly what triggers you and what comforts you. And just going through your Facebook profile or whatever, it will know exactly how to talk with you. So maybe that's not really what we need, but yeah, we're not there yet.
Yeah, it's
because this guy does not react when it drops the bag. We've seen that many times. It just doesn't give a.
True. We have passed 8,000 units, 6 hours, and so far, this is historic moments that we should give it to them. But it's interesting. I don't know if you noticed, if to Scott's points, things wearing off over time. I've been active in the robotics construction industry, and one thing I learned there is that when we say the environment is unstructured, it doesn't only mean that every day the robot will be introduced with the new things. It also means that the same things that robot has been introduced to are changing over time. For example, if the robot was getting used to, oh, there is a wall here today, and the next day the wall is having a different texture or a different finish. Before it was just bricks, now it's concrete on top of it. Now it's I don't know, another layer on top of it. So here I see the variety that I see in the environment here is something that could be programmed, although some of the packages are just very, very flexible. But I don't know. And also the point about the human-robot interaction and the human likeness, the exact same robot is going to be used at home, right? They just change the fashion, as Brett also showed a few weeks ago about the fashion and everything. And I'm wondering, how do we see that feature, like a general purpose robot, like the exact same robot, that is now very optimized for factory working also work at home. And
Yeah, I don't see any problem with that. It should work just fine, and that's the whole thesis about the economic argument about the one hardware platform being able to do everything. But by the way, have we only seen one swap out? Was there another one?
No, I think there's been at least 2, maybe 3. There might have been one we didn't see.
Yeah.
But
The guy on the left started, and then he swapped with this guy, and then the guy on the left got back to work, and then the guy on the right did some work, and now it's the guy in the middle again. So there's been multiple swaps, and we only seen one live. So we talk too much.
I like how you're referring to them as guys.
Yeah. Well, I mean, it kind of, I sort of wonder if there might be 2 slightly different versions for commercial versus home use. And that is like anyone who knows that if you go and buy certain fixtures at Home Depot, they may look like the same fixture, but they're actually a cheaper version than the one that maybe a contractor or professional would have. So supposedly they're exactly the same, but one is actually fully cast metal and another one is like plastic on the inside with metal on the outside and other things to do it. The thing is whether the industrial grade version, will be the higher end version, will cost a little bit more. And then you just find a way to make the one that comes at home. And you may want to. So I'm just thinking of the hands for an industrial robot, I want burly hands. I want a worker who's just like tough and rough and is just able to handle the task. But I don't want my butler to have burly hands. I want his hands to be manicured. So it could be that you'll see slight differences like that, but it doesn't mean you would change the degrees of freedom or anything like that. It might be kind of the same. The question of height, I don't know if we're going to see that you would be able to get them in slightly different heights. If they do, I would almost wonder if they'd just be discrete. You can get a 5'6" and you can get a 6-footer, but nothing in between because it's going to screw up the training set.
Yeah, it's going to depend. It's going to depend on the AI whether or not we can do that for different embodiments. The other thing I wonder is whether you can have interchangeable hands, right? You could have a drill hand, for instance.
Well, I mean, we don't want the Inspector Gadget for the reason that becomes very costly because my house is already replete with drills and other sort of hardware and equipment. I don't want to have to buy another one. And the same with my kitchen. We've kind of talked about that. I've got everything in the kitchen, all the utensils, all the appliances are up there that you need to cook a meal. I expect it to come into my house and cook a meal and not have to suddenly have drawers full of these weird appliances that I can't use.
Scott and Gustav and Royden, if you remember when we were talking about Sunday robotics, we had this discussion about the robot cleaning the toilet and then going and emptying the dishwasher. So I feel like putting gloves on the hands should be some sort of requirement or something, because in the home setup, we have a lot of tasks that the hands will touch somewhere and then touch somewhere else, and we don't want that to happen. So I haven't really seen that in any other robots that they pay attention to the how do you say,
hygiene. The hygienics or sanitation, the hygiene. And if they're going to be working in a restaurant environment, they absolutely have to be that way. Which is like something I've always questioned about the Optimus popcorn ball. It's like right on the edge and probably what the health department would require, because you do need to clean that thing down. Its hands are coming in contact with kernels. Kernels could be getting caught in the mechanism. Kernels could then be festering. You could have all kinds of other things. You need to clean it down. Now, all you have to do is go to BurgerBots in Santa Clara, where they set up like some automation. I was there last year, and it's using traditional automation for the final assembly of the burger. It's really fun to watch. You should go there and do it. But they're using standard ABB robots, and all the end-of-arm tooling that they specially designed for these things are made out of stainless steel. And they meet all the NSF standards and stuff like that. And the conveyor systems they have in there are specifically designed for food processing, which means that the surfaces are something that will not get, they cannot develop anything on there because it would be stainless steel. And the other thing, they get washed out all the time. So they have this huge maintenance schedule that they have to go through to maintain. And you're gonna have to do the same thing with the bots that are going to be doing food preparation. Now, is it the same as for humans? The humans, like, well, you got to wash your hands and you wear an apron, you do a few other things that that might be what you have to do. But I have a hard time getting those latex gloves on and off. And I wonder what it's going to be like for the robot.
Extremely complex. Even the fashion that this Figure robot had, I'm not sure if the robot itself can put on the vest on itself.
Yeah,
that's an extremely complex task because, again, you cannot model the fabric in the simulation, right? I mean, you can, but it takes a lot of computation. So how would the robot deal with that? I don't know, really.
That would be, because we were talking about a post Brett did the day before yesterday showing two of the Figure bots sitting in a golf cart. And it was like, okay, what is Brett showing us here? What I would like him to show us is how they actually get up there. So I'm assuming it's like, well, the flexion will have to be able to sit down in there. But again, a lot of us, if we have like a shoulder injury, it's really hard to dress ourselves. So do the robot shoulders have enough flexibility to be able to put that on themselves? Or could they dress the other one, but just not themselves?
True.
Maybe the clothing will be designed in a way that they can put it on. So it's like Velcro over the shoulders, and like pull it over and then just your arms.
We needed another 5 minutes with Brett. I really wanted to ask him. I was like, what was the point of that? What's going on there?
Hey guys, I got to go again. I'll see you later.
Okay,
It was great to meet you.
Thanks, Phil.
Great. Thanks, Phil. Come back if you can.
I will try.
All right.
So we have to make a poll. What will you can calculate it, but what will the final number of packages be at the 8-hour mark?
Oh, good question. I would bet on 9,000.
Let's go. Quick head math.
Okay. Boy, I didn't look at the last thing to do my cheat to figure that out. So it's been doing a little over 1,000 packs. So it's possible that, it's going to be way more than 9,000.
Oh, that's. I'm sorry, I thought this is 6,300.
All right, 9,001. You know, I guess I'll go for the 10K.
Yeah,
I'll go for the 10K.
Thank you for
wait, I'm texting Brett.
Rock, what do you think?
Make sure it stops at 10K.
I'm out. I say 10,450.
10th. Is that you or Grok?
Yeah, well.
He already knew what the answer was when he asked the question.
10,500. If it might have a big
I'm going to say 10,420.
Oh, I'm over you.
10,420.
Yeah,
10,445.
yeah, too much for a round number there.
10,445. Yeah. Rounded off to 10,500. No, but it's been doing an average of 1,300 per hour, so it should be
1.5 hours is left.
So 8 times 1,300 should be over 10, I guess.
Yeah, it's gonna be over 10. It could be getting close to 11, then probably going to be above 10.5. Yeah,
but it might have a major mishap, but I don't.
You never know.
Since it's been going on.
Set up a poly market for that right now. Come on.
We should. So is this a third bot?
This is the one who. Oh yeah, it's the third one.
Is this the one that started it?
No, it was the one on the left who started it.
But they've been switching positions.
They must have switched it just a few minutes ago because it was the middle one doing it a few minutes back.
No, it's been like this for a while.
Yeah.
Okay, maybe I saw it correct.
But what do you think, Scott, about the overheating of the actuators? It should be a serious problem now, but I don't know.
I mean, for the ones that are there, they've done a lot in their design to get rid of the heat, and part of it is the exoskeleton. So the exoskeleton is basically all the loading goes through an exoskeleton rather than endoskeleton, and the exoskeleton is made out of aluminum, and aluminum is a great conductor. So they're able to pull a lot. So that's the first part. The other will come down to the actuation strategy, and that is the fact that they're using harmonic drives. So in some ways, that means the motor doesn't have to spin as hot to be able to do that. And the other planetary drives don't have as good a back drive ability. So that means their holding torque can be a little bit better than a planetary, which is just going to go on you. So I don't know if they have internal braking, but I think what, the combination of the two makes it a little bit easier for them to be able to do this without overheating. So I've always kind of joked that the one way to get rid of your overheating problem is not to try to dissipate it, but to not have the heating problem in the first place. So you try to build your design around that, thinking, okay, what are the sources, or why are we having heating problems? And then let's build our actuators so that doesn't happen.
Now we see the robot actually in this a few seconds you were talking, I saw it made 2 mistakes actually. I was suspicious that the robot might have another camera in the environment, which is fine in the industrial setup, but there might be another camera from top or from front that is giving the robot feedback. I'm just guessing. So look, this box that right now the robot is analyzing, it doesn't look at all the side of the boxes. It only look at some of the sides. When it finds the label,
and what it seems to be doing is that we talked to Brett about this. Is it's kind of inferring sometimes that certain kind of packages, you could tell, oh, if it's not in the top, it must be in the bottom. So the assumption is it's either on one side or the other. When you get a cube like that, it's a little bit confused, and see, it screwed that one up right there, and that it didn't get a glimpse of it. Maybe it thought it did. So in some cases, what it will do is it will infer, if it is able to see 5 of them, that, oh, it must be already on the bottom. And so it kind of glitched there a little bit. Oh, and that one, it hit it too hard. You see, there was a problem. It had it perfect, but then it whacked it. And then it took over. So those are the ones that I don't remember seeing those in the training set before last year. Last year, I remember the soft packages and the one like that. And that was the one that they usually get right, because it's either top or bottom. It's rarely on the sides. And so it was kind of able to infer really quickly. And it's a question of how it's making that decision. But those cubes have been the ones that have been the hardest.
Yeah, but Brett said that if it didn't see the label, it checked 5 sides, and if it doesn't see the label, it kind of expects
it assumes that. Exactly. It assumes that. So right now, it might either be looking around or saying, oh, I don't think where is that thing? Did it get it that time? Oh, okay. Now it's kind of figuring, it's like a Rubik's. Okay. So no, oh, very good. So that one, it solved it. It knew where it was. It just had a hard time manipulating it.
So it actually only changed places 3 times. So it was first the one on the left, then the middle, then the left, and now it's the one on the right. So this is, I miscalculated it. So this is the first time that this bot has been working, and it's been going on for quite some time. So the first,
okay, a second in his hand. Oh, recovery, good recovery. So those are the things that are going to be slowing it down, is that it thinks it has everything right, it goes to move its hand and it gets caught. It's like, got to go back,
Yeah. And is it just me, or is this particular bot a little more confident / aggressive?
Goes faster, but less careful. Less careful, yeah.
It's interesting, because the second one was like losing lots of packages, because it seemed like it was sweeping it in. And I wonder if it was because it was like too aggressive with its hand, or if its body position was just off.
Probably just the body positioning, I think.
Yeah.
Or at least I
remember it was tossing lots of them on there. And this comes down to that none of these bots are identical. Yeah. They're really close, but their sysids are just a little bit different. And then you sort of wonder what they have to do to kind of retune them in, that you get really the same results each time.
In which manner do you think they're not identical?
Oh, just like the actuator break-ins and stuff like that. So they're not, I mean, their manufacture is close to identical as you can make them. Yeah. But in the end, they still don't quite have the exact same actuator parameters as much as you want.
I see.
And then it changes over time as well. It's like these things wear out, they start to heat up. So there'll be a little bit of drift. I mean, even your sensors will be off a little bit, your cameras. I mean, I learned the hard way with like the first Tesla I had. I didn't realize that there was a major problem with the camera. It wouldn't drive at night. I'm like, I just thought FSD didn't drive at night. It just turned out it's like it needed like a camera calibration.
Sorry guys, we're seeing a very interesting scene here. The robot is trying to reach that box, but not, right?
Yeah.
Oh,
let's see.
Yeah, and I was like, okay, it gives up. And then I wonder if it realizes that if it pulls one of the other packages, it will just let the dam break.
I wonder how much of a gap there is between its body and.
Okay, finally got it. Finally got it. Man, it's just all right.
That was good.
It was lucky that the whole dam didn't break, because sometimes that's really screws it up, is when that whole pile
Also
comes
the
in.
Yeah.
weakness on the fingers. Yeah.
Yep.
But those, I mean, remember when Brett took the camera right there and walked right next to it and showed us? There wasn't much of a gap between this particular station and the body of the bot.
And we couldn't see any packages on the floor, so I wonder if someone had kind of crept underneath and cleared it out, or he just moved the camera down enough. But there was no bags on the floor, but it had easily dropped like 20.
That messed that one up. See, again, the cubes really are the ones that throws it off.
Yeah, especially the big cubes, right? The smaller
cubes,
cubes, it seems like it's easier because it's only 2 probabilities. It's on the big top
exactly.
side.
That's easy. Yep. Okay. Sometimes it overdoes.
Yeah, but bigger cubes that are like equal, they are complex. I can understand.
Yes, they are. That one, that was interesting. We don't know whether, I guess it saw the other side that there was nothing there, and somehow it assumed. Or maybe it was because it wasn't a cube, it's either top or the bottom, because those could be. Okay.
I'm telling you guys, there must be another camera in the environment.
No.
Look.
If there's another camera, there is. It's the one that's showing us the live stream.
I guess there's a camera.
I don't think I don't think it's in there. I think if there is another camera in there, it might be the one that's just doing the evaluation, or whether it did it right or wrong. But I don't think it's telling it what to do.
But
or is it the bots in the back that are charging?
It would have to be connected to the camera in some way.
But Brett said they're not communicating.
All the inference is local.
They're just communicating with looking at each other. They're not communicating brain to brain. So we asked that for the making the bed. The bots are not talking to each other without us hearing it. It looked at each other when it's nodding, then it starts. So I'm expecting it's the same thing here, that it's not communicating with the other bots. It's just using its own information, unless he was not giving away all the.
Clearly with Vulcan, it's and I guess maybe the reason they call it Vulcan is because wasn't Spock a telepath?
Yeah.
So they're able to talk wirelessly, and I think there's 2 ways. I think they might be both Wi-Fi and 5G, depending upon what kind of connectivity you have and you need. So that's there. So there's a fleet manager that knows where everything is and its status. But yeah, I don't know that when you have a task like that, where they probably could, but my understanding is they didn't want to do that. They intentionally wanted to do it through body gestures, with the idea that you could be coordinating with a person.
Yeah, with a human.
And the idea is that the person will quickly know that you just kind of nod when it's doing something and it will cooperate.
By the way, there is in fact a Polymarket
there is
post. It's a poll, but it's
What's it for?
No, it's I don't see the poll, but I see a post. It says Justin, the robot appears to stall mid-shift as a backlog of packages piled up on the conveyor belt. Let me just see if there's a poll.
There's no gambling market on that.
There's no gambling market. I think they're too busy with Trump in China.
I really like if they intentionally make some edge cases and disturbances in the environment to see if it's behaving the same. Because I would like to see, for example, somebody just, I don't know, one of the boxes is stuck and see what happens.
Brett kind of showed that, and I've seen some other examples. When Brett was out there, one of the packages came out, he took it and he just threw it back.
I see.
So you can, and I've seen some other. I think when Mark Benioff was there, he also
Benioff did that,
and it's like this guy's just able to get away with his videos everywhere, because I was able to go in there, but I couldn't get my cell phone anywhere. I basically had to leave it at the desk, and so he did that, and at the same time he was tossing them and throwing them back. So that's a type of disturbance, I guess. And the other I wonder is if you start bumping into the robot, how it recovers.
So let me play devil's advocate here.
I love that. Go ahead.
Yeah. Okay. Because we've asked the controversial questions about Tesla, Elon, and Optimus. Everything that you're seeing in this video is something that it's a function, it's a role a set of tasks that Figure has been trained on day in and day out
For a long time.
for a very long time now, right? Do you think they could have chosen something more difficult to demonstrate this? Because the obvious question is going to be like, look, you've released an 8-hour plus.
Okay, once again, there you see holding the hand up to keep it from hitting. That's was very clear. To get the hand out of the way. It was not something else. So, yep. 6:39.
I was expecting it to do some other task when they kind of presented this. It's like,
by the way, look who we have here. Marwa's in the house.
Great to see you.
I'm like the only one that's on normal time. For all of you, it's like what, midnight or something?
Looks like I've been awake for 3 days.
And this is the thing, is like Mara is like, whatever I'm doing, suddenly an email comes back and I'm like, wait a minute, what time is it there in Belgium?
Well, hang on, Marwa, are you in the Emirates or are you elsewhere?
No, I'm in Brussels.
Oh, okay.
Yeah.
All right.
Yeah.
So I thought you were in my neck of the woods.
In a few minutes, but yeah.
But it's 2 a.m. there for you, right?
Yes, I will.
I see. Almost 2 a.m. Yeah,
Almost
quarter 2. Yeah.
All right. So here, back to the question. Do you think Figure's taken the low-hanging fruit with this demo? I mean, do you think they could have been a little more ambitious?
Yeah. I think again, I think I was expecting multiple bots maybe moving in the warehouse and just moving around, similar to, I think, a Boston Dynamics demo, just getting stuff on and off and walking and just folding and recovering. And also, I think, I don't know if you saw that, but in the live stream, this movement, did you saw that, Scott?
Which movement? Oh, where we're just.
Oh,
yeah. We know what that is. Yeah.
What it is?
You see, there's a chute over there because we just saw it a second ago. There's a chute over there, and that the arm will hit the chute.
Yep.
So when the robot was turning around, it will get in the way. So when it does that movement, that hand goes out of the way to make sure it doesn't bump into it, and then it comes around and goes back down. Yeah. I know there was a lot of comments on that and whether it was something else. If it didn't have anything to do with the chute, the other possibility was it could be in the training set that you could be picking up mannerisms of people who might be adjusting their headsets all the time or doing something like that. But it does not mean that this is being teleoperated. It's autonomous.
Yeah. But to Marva's point, one thing that I always notice about robots, and I've never seen any robot doing that, is locomotion while manipulation or loco manipulation. Basically walking and grabbing something while walking, or using the fingers and hand or dexterous hand while walking. That is a very, very complex task, and I've never seen any robots.
What does Scott call it? Walking and chewing gum at the same time?
Yeah, something like that. Yeah. But I mean, going to what everyone was hoping it would be the bedroom scene. And who knows? Maybe that's going to be the next thing, because the big question is, Ben, who unsets the bedroom? Who messes it up? So could you have like 2 sets of bots, one that goes in and just sort of like messes everything up?
I think Brett's kids should do that.
And the other ones come in and clean it up and just see that for 8 hours.
I mean, I don't know. Brett put his kids there to jump around on the bed, and then the bots came in.
I'm trying to think.
Safe, of course.
What would you look at for 8 hours straight?
I mean, you wouldn't spend 8 hours, setting the bed, would you?
No, just moving around, holding. I think it would make sense if realistically BMW, like for example, what do you do at BMW? Like 8 hours, just show that.
Mm-hmm. Yeah, that's so those. But I think the expectations for everyone is we always have to set the bars low. That if you can't do this, you can't do the others. And it's like no one is really showing too much in live. Yes, we've seen videos out of China of assembly that's been going on in Unitree. I think Robot Era was like releasing a few things, but we haven't seen enough to see it's live. Maybe they have streamed it over there. It just hasn't made it over to this side. So from that standpoint, it is like really the first time we've seen something, even though it's very simple, it's not zero, and it's the first step to get to the other. But we would like to see way more, complicated tasks. But you're not going to deploy into these factories doing very complicated tasks right away because it's so much more to get there. There is a value unlock on a lot of these low-hanging fruits. And this may be the lowest of the low-hanging fruit. It's still complicated in a way. And I think there's some other operations that potentially you could do that will also have a good value unlock.
I'll tell you what. The ultimate test will be if you can deploy Figure.03 in your McDonald's simulation or your McDonald's automated plant.
Oh yeah, exactly. I mean, and that's what we're talking about, is being the complicated one. And in some ways, what makes that more complicated is that every one of these things you're going in, first you have to be able to do it. And not only have to be able to do it, you have to be able to do it at or below the current cost of doing it. And so if it's a really simple task, you're competing up against minimum wage. So in some ways, what you should be doing is going over the high hanging fruit, because those are the people that get paid the big bucks. But it's just too hard to get there. So you're in some ways, your entry point is really difficult. And if you can get this, you unlock the others. Now, McDonald's, people don't get paid a whole lot to McDonald's, but that is a challenging task. I mean, people don't realize that there's a lot going on there. You think, oh, you're just doing one thing. Like, nah, they're doing lots of things. It's like they're moving from one thing to the other. It's a very chaotic environment. They have no idea what's going to happen next. It depends upon orders. There's quite a bit. And I mean, just imagine everything from, taking the orders to preparing something, to going back to restocking things. And you can automate some of these things. And we've seen people come up with like burger flipping bots. And you would think, oh, that's, great. We get this bot that we hang from the ceiling, comes down, it's just going to take care of that problem for us, right? Well, very good. It can do that. But who puts the burgers on there? The human. Who puts the cheese on there? The human. And even if you do kind of set something up, they're like, oh, it can go and pull something off from over here to put on. Who stocks that in the first place? Who's going back to the freezer and all this? And there is no one that really like sits in front and is just flipping burgers the whole time. That's like a little bit of responsibility. Then it's, then I got to get the bread, and I got to get over there. There's so many steps. And that's why you start seeing a humanoid form, because the human can do all those tasks as opposed to I have to automate each one of these tasks individually.
Exactly. To your point, Scott, I can say the hardest task for a robot, in my opinion, is a task that human is in the loop. Like the task that we are seeing right now is a conveyor belt. It was automation and everything. There is no human in the loop. But maybe the example of burger flipping or just McDonald's automation is a good task because there's a human at least as a customer. Or the example of the bedroom, I would say if a human makes the bedroom messy and a robot corrects it or makes it, like this human-robot interaction part is still unsolved. Like people think it's just solved, but human is unpredictable. Human is not doing the same thing all the time the same. So yeah.
See, I'm already 1/4 roboticist just by hanging out with you guys.
Yeah. Now, see, this is the thing, is that we think humans are unpredictable, but unfortunately we are very predictable in a way, and sometimes subconsciously we're not aware of it. So, for example,
that is very true. That's how we could train robots, right?
Well, I mean, you already know about the coin flipping thing. That if you actually ask, a truly random one versus one that people, the people pick the one that people come up, because we really don't know what randomness is. I've seen this problem when I've gone to these different companies showing their policies for doing sorts of things, and they're really proud of how their policies are working, and they're showing that they're reorganizing everything. And I'm showing it's like you're keeping it within a particular space. And one of them was including like blanket folding. And I was showing like every time they were throwing the blanket back on there, it was almost going back there the same way every time. And I said, oh, okay, it's my turn. I went in and I put it in a completely different way than what but still it would have been what should have been in the distribution set. Completely messed their policy up. It broke right away. And I was like, the thing is, you are not randomizing enough, because you know that this is kind of the one that works, and everyone's subconsciously moving it that way. I also did it at a trade fair. It was the same thing. They were doing like the shell game, moving around. Look, I'm going to move this thing over to here and move it there and move it back and see how we can mess with the robot. And I'm looking at it and say, but wait a minute. You ended up with the thing almost back to where the beginning location, which is telling me that's where the policy works over there. And I finally told him to stop after the first move. It's like, oh no, we want to say, no, that's random. Stop it right there. And then the whole policy broke. It fell apart right there. So
I would actually add that maybe what kind of human we are talking about. If you're on the autism spectrum, which is like 20%, 25%.
This is the problem, is that people who are doing the training of the robots, they because they know how random they can make it, they're not going beyond the bound. They're afraid to really push it. And they're assuming that this is what's going to be. And that's why you have to have an outsider come in, a person who's not seeing what they're doing, and say, I'm going to disturb the bed this way. I'm going to put things around this way, and they'll all be shocked. And I think there's this really funny meme that you've probably seen of the developers versus the testers. And it's a thing where the guy is putting like the blocks in this box with the different shapes. You know, versus like the square hole. Oh, you put the square thing in the square hole. Oh, right. You know, and you put the long one in the square. Oh, great. Oh, with the cylinder, we put it in the square hole. And like the developer's like, no. You know, every step of the way. That's exactly how it is. So the developers have this one mindset of this is how everything's going to be, and we expect everyone to use it that way. And then you give it to the testers, and the testers will really find a way. And I was looking at this like, it's been me in a previous life, because I know what these developers are up to, what their tricks are.
Okay, so Gustav, what's your ultimate test? If you were to decide the test for Figure today, what would it be? What would it have been?
I mean, the test I would devise today, it would manage what I would like to see, but I don't, since my kids can barely do it, but just give them a random Lego set and have it build it. I mean, it doesn't have to, that's just using dexterous hands or their hands. But to build a Lego set is really complicated, not just putting the piece to make it stick, but to rotating. If you have this one piece, it has to fit. You can't rotate it too much because then the next piece won't fit. And then you have this, of course, you have a Lego here. Like you have to add the right amount of, you don't really just have to get in the right position. You have to add the right amount of force to get it there. Otherwise it will bend the arm or whatever. So having it build a Lego set, then I would be really impressed with.
And notice the auditory click there.
Yeah, of course.
Feedback is so
and
important.
You feel that click as well. You feel the force you need, and when it's kind of giving away, you can feel that, okay, it's about to snap into place. That's going to be really tricky, I think. And if it can't do that, it won't be able to do surgery. It won't be able to like build small objects. It will, of course, be able to kind of move big sheets of plate or metal, and that's good. But surgery in 3 years, not before you build a basic Lego set.
No.
Before
Sorry, Barbara, you were saying something.
Gardening, that's even as complex, right? Like gardening, if you want to put a plant inside the soil, like there's a lot of haptics going on there, and yeah.
Oh yeah.
Yeah. Now, Mara, you probably want the bot to be able to take care of your cat.
Yeah, but yeah, I was curious about the packages. I think one of the complaints that the same packages, nothing new. It's all the same. I'm not sure how we are. Yeah, I'm not sure why they didn't change the packages for the same thing.
Well, I think part of it is this is sort of like the common distribution of packages they expect to see, because in many cases if you're the post office, you have to deal with almost any package, even though supposedly you go to a website and these are the things that are standard. You go to FedEx or UPS and others, they're just like, it's got to be like this or we don't ship it. So in many cases, probably within what the customer is saying is sort of acceptable for most packages. And then you get the boxes. And then of course we're seeing it's doing well with some boxes, but the bigger cube boxes, it's struggling on that because it can't infer where the label is. All the others, it takes like, it's either on the top or to the bottom. The other one, it's like, oh, it can be all 6 sizes. So we're seeing that. But I agree that there could be probably a little bit more distribution. I'm assuming this represents what probably 95% of what they typically see. But that doesn't cut it because we know, you know, that last 5% is very important to be able to go into any sort of distribution.
And if you have this package, I mean, if you can hear it, there are things inside of this that's moving, and it really distributes the weight quite a lot. So I can't spin it the way it's doing without dropping it. So, I mean, they have a lot of bubble wrap in most of the packages they send, so perhaps it's not a problem. But if you have this kind of packaging, it really distributes the weight a lot. So I can't spin this, and I'm more dexterous than that bot, but it's impossible for me to spin this using the technique that it's using. I need to use like in-hand motion, and we haven't seen that either. A bot that can kind of move things within one hand, it needs to use both.
Do you need abduction for that, do you think, or you think you could do it just with flexion?
You need, it's helped to have a little bit, but maybe you could just do it with this. Like when they were opening the bottle caps, a lot of them are doing it with just flexion extension. There was some video of that. But if you have or twisting of the bottle cap, I think you could do that basically just flexion extension. But using the ab and adduction will help. But just adapting to the weight moving, that's going to be really hard. Or maybe it's not, I don't know. But for me it is. So...
Oh, interesting flip there.
And actually a question here. What if the robot notices that it made a mistake, that the package is going on the conveyor belts and the label is still on top? Would it correct it, or would it let it pass?
No. I mean, when
sometimes it catches it at the last moment, but a lot of them have gone by kind of unnoticed. And of course, in some cases, like these boxes are a bit tricky, because it will get it right. See, did it see the label? Ah, okay, he's got the label. Now, okay, it was lucky. But sometimes it hits it too hard and it flips over.
Yeah.
And then it doesn't do anything.
Goes with probability.
Yeah, it's
probably an automated return system, so it's not a big deal.
There's something that rejects it because they're saying that they just need to be around 90%, which means that they're also expecting a lot of rejects in the first place. So then it must have to come back around, because it's probably more costly for you to say, oh, stop the conveyor, let me reach down there and correct everything, and just let it go.
I wonder if there's another bot at the end of the conveyor belt that's collecting all these packages and then loading them back on.
Validating it,
yeah. Or just loading it back on.
Oh, okay, yeah. Who's loading it back?
Yeah. All right, so there's an interesting question here.
Here we go. Okay, so this is like a recalibration reset. Okay. Let's go. All right. Okay, so now it's okay. Does it remember that thing?
Yeah.
So it's like it suddenly woke up. It was like it doesn't remember that box at all, and then it had to start over. Oh no! Okay,
that's a mistake.
Yeah. See, that's the one with those boxes. The ones that
it's 2 a.m. for the robots. Also,
it's kryptonite. Yeah, exactly. Now that time it got it right, and I wonder if it actually did notice that the label was there and it could just knock it down, or if it was just lucky.
Yeah. So okay, let me just bring up this rather interesting question that one of the viewers has put up. That's I still would like to hear your opinion about what an interaction would be like with humanoids from competing companies. For example, if Figure.04 opens the door to receive a package from Neo. Talk about bot interaction, not human-bot interaction.
Well, this comes down to age-old.
We've never seen in our lifetime, right? So it's very hard to speculate, but let's see.
Well, the first thing is assuming, how would the communication be done between the two? Right now, I'm not aware of there being any standard communication protocol between humanoids, like we would have for an internet protocol. Maybe there will. Maybe they just start swapping JSON files or something like that in their heads. But then you have to come up with it.
How will this come about, Scott?
It would come down to gestures. It's just that you go ahead and maybe there's some kind of gesture. Oh, there's someone in front of me. And of course, it's assuming the bots know how to do a lot of different things. So let's say I've got a butler bot that's supposed to go to the door and pick up a package that someone is delivering. Maybe it's DoorDash or something like that. And what's the interaction? Now, if it was a human, would it know what to do versus a bot? I'd assume it would know to do the same thing. Maybe would it recognize the bot as being a human? It kind of looks the same and everything like that, and it's handing something, and it maybe knows it's supposed to pick up some sort of package. So
I think
somebody's going to be working on the standards for this, right? Because we're not really far from this point.
Oh yeah, I mean, industrial robots have a hard time talking to each other. Are you kidding? ABBs don't like talking to Kukas or Fanics. It's like they have something completely different. So you have to go through some other sort of standard to get them to work and to talk.
But they will have LLMs before they distribute them. I mean, we will be able to talk with the bot, so the bot will be able to talk with each other.
If they talk.
Yeah,
if they talk.
Yeah.
LLMs talking
exactly.
in rhymes or something or like
Yeah,
that.
yeah. And I think that makes sense because then you don't have to develop any other standard.
Yeah.
You know, the standard should just be, English or whatever that AI speak is that they came up with for high speed.
Or it's just my cat meeting the neighbor's cat.
Yeah, exactly.
Your cat meetings Marva's cats.
Okay, so flipping burgers and again doing the fries there, it could probably. I mean, there's no reason why it shouldn't be able to do something like that. You know, I think it's well within, let's say, the capabilities.
How about the heat, Scott? Heat.
Yeah, I mean, the main thing I'm worried about is the fact it's going to be exposed to a lot of grease and dirt and grime.
Yeah.
And so, of course, they have to be covered correctly. And now a lot of these burger flipping bots, what I think is the value out of these burger flipping bots is not actually the fact that you get a burger that's flipping the bots, but they have a vision system up there which knows when the burger is ready to be flipped. And so it's doing it with infrared and something like that. And I would think, just add something on there that has like a light indicator down there that shows the human when it's time to flip the burger or when it's time to take it off. So basically there's something that's doing the timing and figuring out where they are. The grill,
temperature sensor.
And it can be it's a very chaotic environment, isn't it? That they can end up anywhere, especially if there's like special orders. Someone wants this well done, someone, and kind of figuring out that and keeping those orders together. That's something that a good management system would be able to do if it sort of knows where they are. And the question is whether it's very methodical and like puts them down in a perfect array. It's like you would expect a robot to do, or whether just like, wherever it just happens to be, it just goes. But the environment is probably would be the more challenging thing. I think from the standpoint of the dexterity, it should be able to do something like that. Do you agree? I mean, it's really not that hard a task. It's just the whole combination of tasks that go along with it. It's like flipping the burgers is almost the easy part. The hard part is getting those frozen patties out in the first place, breaking them off, and then getting them on there. And then someone wants cheese on there. It's like, I got to go over and I got to pull the cheese slice off, and I got to get that thing in there. And I need like fingernails to do that or something. You just all these other steps are what are really hard. Whereas like the actual burger flipping, that's easy.
Well, we're in the last hour of the shift, gentlemen and lady.
Wow.
7 hours.
John should be joining us too, and I expect to help land the plane. Okay, it looks like we're over 9,000 right now. So is it going to be like 10,300?
Another 1,300 and we'll be at 10,440.
Yeah, just a second.
Yep.
Is that a new cat, Gustav?
No, I have two, one white and one gray. So this is.
Hold up your cat. That's a monster.
It's just a little boy.
Yeah. Okay, so Marva, we had this. We took bets on how many packages this would sort by the end of its 8-hour shift. And Gustav said 10,450, correct, Gustav?
Yeah.
And I was at 10,420. 420. Merdad was at 10,300, was it?
10,500.
10,500. Marva, do you want to?
I can't make a bit. I really don't know.
You're not allowed to say that.
Oh, you can. You can. You can.
Say something. You can.
It's pretty easy. It's like 1,300 an hour. Just 1 hour to go. So,
by the way, Scott, you didn't give us your estimate.
I did. I just
one
gave you
more than Merdad.
I should have given you a much better number. I said it was going to be at least 10,000. That was about it. But definitely north of 10,000.
You're playing safe.
Somewhere probably between 10.4 and 10.5.
Mm-hmm.
Can you show one of the video? This movement. Is it possible to share or? Yes. Yeah. Okay. Yeah. So I'm not sure why it's doing this. What? I'm sorry. Is it possible to share or no?
You want to share something?
Yeah, the video from X.
Yeah, absolutely.
I'm not sure how to switch, but I shared already. I think you see.
Yeah, just send it to the chat and
just drop it in. Drop the link in the chat, and I'll bring it up.
Yeah.
In the private chat on the right. Okay. Okay, that's it.
Yeah, I think the movement. I was curious about the movement.
Oh yeah, it kind of goes back to.
Oh yeah. So every now and then it gets caught in the loop.
Yeah, this is.
Which is actually a good sign that is not teleoperated, right?
Yeah. So that's like the final.
Is it
1% you get? Oh, okay. That's.
I think it was maybe pushing it a bit, or was it trying to grab it, or
trying to grab it?
I think it was trying to grab it. Yeah.
And then the left hand doesn't know how
because
to
you see the wrist, you see it flipping over. It's making the movement in the wrist. So obviously it's trying to grab it and flip it over because the label is on the top.
Okay. Here, this seems to be a weird special case in that because the left hand is hitting the box or seems to be getting near it, it somehow messes up its reach. So if it wasn't there, it might have been able to get there, but suddenly that's in there and it feels that thing and it so like forces the policy to back off a little bit and it's just trying to decide how to do it. So that, see, because it kind of comes in contact a few times, it seems like that's almost throwing it off.
And as you said, Scott, I think this is the robot in the middle, right? From the 3 robots. Because the last robot that you're seeing now is the robot on the right side. So perhaps this one is a bit more lame.
Yeah. But you can see that, I mean, these are all the edge cases that you have to go through in time and to figure out what's going wrong.
Interesting.
It certainly is persistent, you know, and at some point you'd have to decide, all right, we don't want to hold up the works. We've got to get them down there as quickly as possible. I'm wasting way too much time on one part. Just get it out of the way. So the answer should be just sweep it out of the way. I don't think that's what it was trying to do. I think it was like, it said label wrong, and get the label over. And it's kind of caught in this loop, which is rather interesting because most of it look at it like, oh, it's stuck in a for loop. The thing is, there are no for loops in this thing.
It should reach it. It's just out of. It's just not
right?
calibrated. It seems like
because the thumb goes down. I think it's trying to grab it. I don't think it's trying to push it.
Yeah, but it's like on the side. So it has to have lost its calibration, so it needs to do the bike riding maneuver, I think.
Yeah. Well, again, it might be that it's getting bumped by the other box, which prevents it from being able to get that extra stretch.
Oh, you think it's a vision problem?
And the thing is, this is a really hard problem to reproduce. So ideally, I want to reproduce that exact same situation, except get rid of the box and let's see how it works. Like, good luck doing that, getting the exact same situation, make sure the bot is actually standing in the same location, and everything else. And it's just those things that you have to run and run and run and run and run to see enough examples like this that hopefully it recovers. And again, every single manufacturing situation has affordances for something going wrong. The expectation that it's not going to be perfect. We'd like it to be 99.9999%, but they seem to be accepting, in this case, like 90%. So it's well within the capabilities of what we could probably do with our language models nowadays, or not our language, but over our AI models.
I actually really like this video because this kind of shows that it's not teleoperated, unless if the reach is the problem, right? Is that just far enough that the waist pitch actuator cannot reach it properly?
I think it could, but again, it's when it does it, the other hand bumps, and then it sort of tells it, "Oh, stop doing that."
Yeah, it's the same pattern. Yeah.
Yeah. So it's getting down there, and that box is preventing it from doing the proper lean. Now, the obvious solution is just take a step to the right, and then reach it and get it and get out of it. But it seems that in this case, it's really its feet are planted. It's allowed to move the feet. It's allowed to use the waist to increase a little bit of the reach. but it's not allowed to kind of scurry over a little bit, which would be just, the extra thing that you need.
Mm. Marwa, do you think if there was some sort of suction on the fingers,
Yeah.
to make it easier?
Yeah, it is a really good question because I think I'm not sure about the hand. You don't have, so I'm not sure, but maybe it has suctions or something to stuck it instead of this movement, because I'm not sure. But yeah,
Or
you're right.
Spider-Man gloves.
Yeah, and but it has suction its own downsides sometimes. But yeah, I really don't know if we can have suction in the finger. I think that would be bulky, maybe bulky. You have to have a different, not a hand in that case, but the point is, to be honest, the demo doesn't justify the form factor. I understand if you have an arm robot to do that, maybe, but the demo should at least demonstrate the form factor. That's, I think, the missing piece, in my opinion.
Very interesting one.
All right, let's catch up with what's happening. 7:10.
Do you have in the audience, Royden, how did people bet on the numbers?
Yeah, I did pull up a few. Let's do this again. So if you're watching, wherever you're watching from, give us your best bet of how many packages this bot is going to sort by the end of the 8-hour shift. So our guesses range from 10,420 to 10,500. Let's see. Some of you have said 1,150 or thereabouts. Let's keep them coming. I'll bring them up on screen.
I like the fact that it's very non-linear. Like, you cannot calculate. If you could calculate, it was an automation system, right? But the fact that hard to calculate is funny.
Dr. Know-It-All is back in the house.
Hey,
Welcome back.
Post dinner, I'm charged up. I'm feeling good. So it is very late for many of you out there. Wow.
Yeah,
It's actually very early in the next
there we
day.
go. It's early tomorrow.
Yes, it's.
In the next day. All right.
But
So
I'm also looking at some of the people bringing the comments up, and it's like, well, wait a minute, it's also early for them as well. So we've got quite an international audience here, Royden.
This is very cool. Very cool.
Yeah. So what's your best bet, John? How many packages by the end of the shift do you think it hit?
We've only got 1 hour left, right? 49 minutes.
Yeah.
Do you think he'll hit 10,000? That would be pretty cool, but I'm not positive about that.
I think there's a general consensus that it'll be more than 10,000.
Okay. So he's got, that's right. He should be able to maybe buy 100 or so.
Yeah.
If he had any, if he was a human, we know that he would get motivated and he'd be like 10,000.
So Soul Journey of Life says 10,150.
Oh, wow.
Yeah.
Okay.
And Tony Soros says 10,412. 8 less than mine.
That's probably, I bet he did the calculation. That looks like a pretty good one. I'm thinking it's.
It's a bit sus.
A good guess. No, it's a good guess.
A little too accurate. Yeah, good guess.
I took a screenshot and just asked now, and it was 10,366 based on.
Ooh, okay.
So it's going down.
Going down, huh?
I think he's sandbagging it for us.
Yeah, maybe speeds up in the last third.
Yeah.
Okay, we've got another one. 10,381.
Okay.
Yeah.
Wow.
That's the smallest we've heard so far, right? So was there?
Well, except for me at 10,000, but.
Oh, that's true. No, you changed it to 10,500.
I don't know why.
Zeno Soiro says, 10,431. We've got 10,367.
Yeah, that's the.
These are all educated guesses. Yeah.
Educated guesses. Oh, by the way, listen to all of you guys. Ladies and gentlemen, everybody who's watching, thank you so much for tuning in, whether you're on X or Facebook or YouTube. Let us know where you're watching us from.
Yeah.
Just drop it, either drop the flag of your country or the name of your country in the comments, and we'd love to get an idea of just how international our audience is tonight. All right. Okay, so we've got someone who's clearly very ambitious and says this is 28,800. Okay.
Wow. Okay, it's better pick up the pace real quick there.
I got 10,696.
Actually, it's going to be bringing them around.
Okay, we've got viewers from Oklahoma, the United Kingdom, Romania. Ooh,
Wow, very cool.
nice. Keep them coming, folks.
Okay.
From the great country of Texas.
That is not as much of a joke as you might
It's
think.
the Republic
Yes, the
of
Republic
Texas,
of
isn't it?
Texas.
Come on.
Yeah.
He's not actually from there if he didn't know it's a republic.
Sorry, Robot Tinker Academy. You just got fact checked. All right. We've got Into the Filter also from Texas. Keep them coming. Oh, he's got quite a... Oh, Portugal. Brilliant.
Oh, cool.
Yeah.
That's good.
Cool.
That's nice. Well, I think half of our panel is from Europe.
Yeah.
Sierra Leone, Michigan. Okay.
Okay. Michigan. That is a foreign country.
All right. So Robot Tinker Academy says, hi, Merdat. It's Kimate Richards. I'm sorry.
Oh,
Kimate.
really?
Nice.
Kamate?
You might have
We know
met.
Kamate. I mean, I think we all know Kamate, don't we?
Yeah. All right.
Yeah. Hello.
Hey, Kamate.
Hello. Yeah.
Yeah.
Yes.
That's nice.
Yeah. He's one of the legends out there. Yep.
Yep. We've actually taken a couple of his comments
Yeah.
on screen during the
I met him
the
at
chat
the
today.
Humanoid Summit, and Merdad, I think you and him have gone back and forth many times over the years. Yeah, he knows us all. Yep.
Yeah, that is it.
All right, keep it coming, folks. Give us your estimate, how many packages by the end of the shift, and also let us know where you're watching from. Be great to know. All right, let's check in on the bot. 9,411. About 44 minutes to go.
It's going slower, right?
Yeah, it's tired.
Yeah.
15 minutes. It had only 300.
Is it slowing? Am I? Ooh, is it going to stop at 10?
And
Maybe
then
it'll
also
just it'll give up. Yeah.
It'd be funny actually if it disappoints us.
Yeah.
Well,
Do you think
see,
they're
he's
going to
having
stop
problems with
exactly
that
at the
box.
8 hour mark?
Oh, look at that.
Don't
one.
give
It's
up,
really-
don't give up.
Oh, it gave up.
It just
gave
gave
up.
up.
I wanted it.
It must have a little timeout filter in there that's just like 5 seconds, I'm done. Just go
Yeah,
on.
but we just showed one before that it didn't, where it was literally almost grasping at straws. We just kept like trying and couldn't get it, and I was like, when are you going to time out? Yeah.
I actually found this part of the video, and even before this section and after, it was kind of messing up quite a lot. So I wonder if it was a bad batch.
Bad bot.
Yeah, bad bot.
It's the
Bad
middle.
robot.
Yeah.
I've seen that too, that sometimes it will have like a bad stretch when one thing goes south, everything just starts falling apart.
The middle channel.
Tell the robot, if you're watching this, you're not doing a good job. Probably
You can slow down to 10,000 and I'll be happy.
Could you imagine this poor thing, like, you know, knowing that we're all just like judging it, just sitting out here judging it. Man.
All right, so there's an audience question here, which is from Mr. Only Moin One. Why can't they just talk with the file sharing protocols or networking protocol methods, which is already used for computer-to-computer communications?
Yeah, they probably could.
Yeah.
It's just which protocol you want to use.
Yeah.
I mean, they're already there, so I'm sure something like a JSON file would do the trick.
Yeah. All right. I hope you got your answer, Mr. Only Moin One from India.
Oh, nice. Okay, cool.
Yeah.
Somebody else is up late.
Yeah.
I like the
Well,
robot.
actually,
I like the robot.
I think it's almost 6 o'clock in India.
Oh,
6
yeah.
a.m.
Up early.
Okay.
Up
Yeah.
early.
Yep.
Up early. Okay.
Up early.
Yeah.
So Kimati says we need a robot unit ASAP.
Oh boy, he's organizing them
Strike.
already.
All
I
the
know.
signs. Strike. I don't know. I mean, I think the robot actually might be what is that when you just slow down your work intentionally? So
Bend down? Oh, that's a complete
Oh,
strike.
it's some kind of strike, isn't it? It's
Yeah, it's what is the name of that? Anyway.
Well, yeah. Didn't they have something like that at
what I love is in Britain, I love what they refer to it as an industrial action, which is like the biggest oxymoron I've ever heard of. It's like, wait a minute, there's like no industrial action. How can you call it an industrial action?
It's industrial inaction.
Exactly.
Leave it to the Brits. Leave it to the Brits. They'll figure out some way to make it.
Yeah, Kibati says likely we'll develop something like the Matter protocol, and obviously cars will need to speak to each other. Yeah, but cars are bots as well, right? So you'll need something across form factors, because you're going to be talking to quadrupeds, all sorts of bots in the next 10 years.
And
Bots
there are
on
a lot of companies
wheels.
that are developing operating systems explicitly for that. So, but we don't know what it's going to be. You know, a lot of people are trying to build something on top of ROS, and with mixed results, and others are trying to come up with their own and hoping to become like the Microsoft of the entire. And we'll just see. You know, at some point, it's either there's going to be a consortium that comes together and creates what they think the protocol should look like, which is one way of doing it, or it's going to end up being a de facto standard because someone does such a good job and gets so many people on board, everyone just has to follow along. And
like the Tesla charging standard.
Yeah, typically what you end up seeing is the de facto standards end up being a little bit better because the committees move kind of slow, and they also are against their best interests sometimes. Because you get all these factions that are kind of fighting. It's really hard to get to an agreement. And by that time, you know, the champion is already out there and everyone's using it.
Right.
So, and you can see that through all sorts of protocols in computing all the time, and in other places in industry as well.
Isn't it already pretty hard to connect the Bluetooth of an iPhone to a Windows laptop, right? Like we have all these problems. It's because of the company's strategies, right? If you want to connect your AirPods to a Windows laptop, then it's already pretty
the common denominator in all those is Windows.
Okay, Windows is to blame.
I mean, I can get my earphones work on an Android and an Apple. But it's really hard to get it work on Windows. So I'll tell you. So I think that's what it is.
Okay, so we've got a post. Thank you, Barbara. We've got a post from Dar. Let me just bring it up.
Oh, yeah. This was an interesting little exchange. Did you guys see this earlier or not?
Yeah,
because I'm the last person I'd expect to rush to Figure's defense, and I'm looking forward to hearing Brett's take here. And in any case, all cases I stand with Power, Bottom, Dad, King. But what is this about?
So he was saying it was somebody was adjusting their vision, their VR goggles. That's the supposed.
If you remember the famous Tesla scene where suddenly the headset came off, and so he's kind of equating it to the same situation there. That it looks like adjusting that, and that was the move to avoid the shoot. And we saw that also later on. Actually, like 5 minutes before you came on, Marwa, we also saw it. It was like look at 6 hours and 37 minutes or something like that.
Yeah, look at the thing below, because Brett actually defends this.
Yeah,
right there. Yeah.
Now, this is good that Dar has done it, because I think sometimes there's a lot of FUD or people willing to kind of like jump on something without really understanding what it is, realizing that if it happens to your competitor, it might happen to you too, and to kind of go out there and set the record straight of what's going on. That you can't jump to these conclusions really quickly about being something when it's not. It can't be a knee-jerk reaction. It was well worth asking and say, hey, what's this about? This is kind of curious. But to go so far as to say it was teleoperated was like really a step too far.
Yeah.
And the other thing, I will also come to Dar's defense, which we did like in a previous one, is that everyone was sort of attacking 1X about the idea of having a teleoperation at home. Right. And it was more or less, it wasn't, the messaging was really bad. It's not that what they were doing was going to be always teleoperated. They want to be mostly autonomous in the home.
Right.
And occasionally you will need some teleoperation. And what you have to do is you have to schedule a teleoperator, allow the teleoperator to do it. And everything is kind of known when the teleoperator is going to go ahead and do that. So when the 1X protocols for being able to do that, I am very, very comfortable with. They had explained it to me very thoroughly. Unfortunately, their messaging to the greater public wasn't as good. perhaps because it's not something you can do in a simple soundbite. It's one of those things like, oh, that looks really good. And I was like, I agree
Maybe
with
they
that.
should come on to Over the Horizon and do a live stream.
Yeah.
I think they could do an 8-hour live stream.
Yeah.
Come on, Jared, take up the
Bring it
challenge,
on.
Star. Bring it on.
Bring it
Oh
on.
God, not another one. Oh, what have I got myself into?
You started it.
Yeah. Okay.
Yeah, for everybody. In
Bring
case
it,
you
bring-
didn't know,
if you-
this is the gentleman
If
that
you want to
started
ruin
it
my
all.
days for the next 2 weeks, I am down for that. Anyone who wants to go ahead and do it. I don't care what time zone it's in, what country it's in. You know, go ahead.
Scott will. You'll never sleep. We'll have to put a little bed in the back of your room for you there. So we'll just have like a camera. You could be all tucked in sleeping while you're still.
I think I'm the one who's not going to sleep because I'm spending my nights up. You guys are in
You're the one
daytime.
hosting it. I know it's so much easier for me.
That's bad. That's bad. Did you at least get a break to eat some food or something or drink some coffee?
I grabbed a couple of small chunks of
goodness.
brie.
Goodness gracious.
Cheeses, French cheese,
Oh,
keeping me
yes.
on the go.
Oh,
There you go. Good
I
stuff.
thought you were war rations over there. You can get brie.
Marva, please tell them this is the Middle East. This is the GCC.
Yep.
We're kings. Go on, tell them, Marva. Don't feel shy.
No, yeah, it's true.
Regarding teleoperation points, you said, Scott, I just want to say we shouldn't think very binary here. Is it teleoperated or autonomous? Maybe there is an intervention here going on, right? But the intervention is not as high. So there is a teleoperator behind this. If there is something seriously going wrong or the robot cannot handle it, the teleoperator might intervene here. So I think that
that's a common technique in a lot of this kind of post-training.
True.
Where they let the robot do it, and then you have like this dagger approach where someone will go in and just give it a nudge the right way.
Yeah.
But my assumption here is that if there was someone correcting it, he was really pretty slow. Everyone was trying to reach out and get something like that. So because if I was doing that intervention, I would have just said, push it to the side. Because it's very clear that's out of reach or there's something else. And the best strategy at that point would have been to knock it away and then just kind of continue on.
I mean, we've been watching this for 8 hours, and if there had been a lot of human interventions, I think we would have noticed them. I mean, there are not many occasions when it feels like, oh, this must have been teleoperated, because it's too kind of similar in its movements all the time. So it's not teleoperated. Come on.
Well, and also Brett did explain what that arm raise was. He said that it has to do with the steel
the
thing
chute
that's there, that sort of guard, that it was sort of raising its arm up over that to avoid hitting that. So that was his explanation. So
it's like the coverage of the cameras. I'm not sure if you can see that edge properly, or is it maybe modeled in the simulation? I'm not sure.
Is it? Do they have fisheye lenses on the cameras in the head?
True. Maybe that's
yeah. They have multiple. They have one in the chin. And then I think there's like the one straight here, and there's one at the top of the head, and I think there's one
behind. Yeah,
but it's really interesting that it's like it does this line, like around.
So rather than binocular,
interesting. It's interesting that you would think they have the binocular, but they have like one big one here, and I give the chin.
Okay.
And I assume the one on the top of the head is to maybe help with like SLAM, trying to get your localization where you are.
I'm actually surprised that you don't have more bot companies deploying 360 cameras. At least one in the body.
Depth sensing.
Sorry,
you mean like just doing a ring around like that, having more?
No. A single camera that's two fisheye lenses that are stitched to give a full 360 view, like a VR camera.
I think part of it is that the resolution gets really bad. It's like you can take those things and kind of map them to be flat, but the reality is things are only good like in the center, and then as you get out, it gets so distorted. It's hard
nowadays
to
you get like 8K. Just consumer cameras are 8K plus, and when you stitch the two together, it's 4K plus.
4K, but you're really not losing any potential resolution down the as far as it's not so much. It may look nice, but the question is it accurate? as it
Yeah.
stitches
Oh,
those
yeah.
things in.
Yeah.
And whether that's enough for
Very
navigation.
accurate.
The other is the overall amount of inference that's involved in that. So a lot of the question with the number of cameras, like, oh, just put enough so you don't have to turn the head.
Right.
And it turns out that each one of those cameras eats up a little bit of inference, and then you got to pull all these things together. And the other is, if you did like a 360 around here, the question is, where's the center of interest? So you could have a head that doesn't move, and we don't know what it's really looking at. And a lot of times it is actually better to point the camera at what you want. So that way the policy actually knows what your intent is. All it knows is like, whoa, all this stuff. What's my center of attention? I'm not quite sure where it is.
You could also maybe, Royden, think about this, which is for a car, it definitely wouldn't work because a car is a very large object that takes up a lot of space. But even a robot's head, if you put a 3D camera, a 360 camera on top of the head, it can't see down.
Thank you, Marwa.
Okay, yeah. So it's like 2 or 3 o'clock there.
Yeah. She's done. All
She's done.
gone.
She's like, I'm out. I'm gonna bounce.
Even the cat is awake. So.
Yeah. But the 360 camera would have a lot of shadowing from the head if you put it on top of the head. And if you put it in the head, it can't do the 360 thing because it's inside. So I think part of it's just a practical issue of like, where would you put this camera that would be as effective as just putting multiple cameras there? Because it's already doing what you're saying.
It doesn't really have compute. It doesn't have battery or compute. You could essentially have a glass head with a camera right in the middle.
Yeah. That's possible. Yeah. That would be wild. Like a fishbowl. It's just like a fishbowl.
Yeah, it's a fishbowl. Yeah.
It just walks around.
It's the simplest.
Yeah, but I mean, the vision kind of remembers what it's seen. Do we know how long the kind of vision model, maybe it remembers that there's a wall there for more than 5 minutes, or will it forget as soon as
That's a good point.
It doesn't exist? Because the Tesla car will kind of, I saw a human being over there.
Yeah.
So when I pass this car, there will be a human there. I guess this would be similar. It has a world model, so it knows there used to be a wall here until I see something different. There's a wall there.
I believe it does, because last year, and you may even see some of the examples here, where you had the one hand grabbing something else, the other one pushing something away. And so it was like sort of aware that there was something there, even though its focus was over here all of a sudden. It was like, get that out of the way. And it went ahead and did that sweeping motion. And the question is like, was that it was like persistent and knew it was there, or it's just something that was like a learned behavior?
Yeah.
Okay, you know what? I'm going to bring up this video that we got from Figure in the past week or so, or fortnight. This was showing the vision model.
Oh, there you go.
This is pertinent to what we've been discussing.
I noticed a comment here. Tony Source says 360 cameras don't work well with Gaussian splats. So I can't verify that, but that would be reasonable to guess that could be true. So, and of course you're having to do pseudo LiDAR with these cameras, just like with what Tesla does. So just exactly what you're showing us right now.
Yeah.
So, yeah.
I mean, this is the very conventional point cloud, right? This is even not Gaussian splatting, because Gaussian splatting.
Yes. This is
and it's pretty basic to be honest, as a mesh.
Yeah,
it's not very detailed.
Yeah.
It's just detailed enough.
Well,
that's the whole thing.
Yeah, except that this is being done with vision only, not with LiDAR. So that's the cool part about it.
Yeah.
It's not trivial to do that.
Yeah.
So, but I think the point that Gustav said, that's actually a very interesting point, that it's about memory, right? If robots have memory in that sense that we think we have. For example, if we can actually walk from our bedroom to the kitchen if it's everywhere is dark, because we have a memory of how that offline map would look like in the SLAM. But yeah, it's for robots, it's still, I think, far-fetched. Even I remember for LLMs, there was a discussion about like LLMs having memory or not, or short-term and long-term memory, of course.
This is another good point, by the way, which is that Brett specifically said that they train on a lot of online data, which would mean, videos of people, and you don't have a lot of 360 videos out there. So you would reduce your data set drastically by going with that. By the way, Gustav, love your cat. Very pretty.
Loving you guys.
What kind of cat is that?
This is your local breed. The main
it is the Maine Coon cat?
Yeah.
So it's Persian.
So,
No, it's
No,
very,
well, let's see. What is
No,
the-
this is
beautiful.
yeah, you got those ears. It's kind of, yeah.
Sorry, is the robot changed now? Because I see a label on the.
Oh, it says Gary. Wait a second. Can you rewind it a little bit? Let's find out when
hang
Gary
on.
came in.
Gary
missed
something. Yeah, Gary.
How did Gary get there?
Oh, they all have name tags now. Someone finally put name
What?
tags on all of them.
Oh man.
When did we miss the name tags going on?
I hope it's Gary, Barry, Larry.
Okay,
I
here
hope
we
they're
go.
all like,
Here, there's no name
Let's see what
tags.
happens.
What happened. Someone must have gone in there.
And slapped it on.
yeah, they must have put them on all of them because the ones in the back have them now too.
Yeah.
That reminds me
Someone
of, does anybody know the old movie Raising Arizona? Because they had the Arizona Quints and it was like Gary, Barry, Larry, Harry, I don't know, something like that. So they all had like.
What were the Hanson brothers' names?
Wait, come on. Well, the fact I can definitely tell it's nighttime back there because the light has definitely shifted in the offices. So where this is so weird. Where did the name
Where did
tags
it
come
happen?
from?
Yeah.
I wonder if one of the bots from the background walked up and just slapped it on.
That would be really
we
cool.
missed it. We missed it looking at good
Do you think they're listening to us? They're watching us.
Oh, yeah, they are. They are.
Blame here. Yeah.
Well, whoever did it fast because that did not take long.
Well, there had to be a bot swap in there, right?
No, I think they just put
it on while the bot was working.
Well, we'll see.
Oh,
At some point, we'll find out.
7:32.
Did you 2x this?
Yeah, it's actually Brett doing it at 7:32:06. So in
7:32. Okay.
Less than a minute. Da, da, da. I know Royden's actually had this ahead the whole time, so he knows exactly how many packages were sorted. So you'll be able to make it. Oh, here he comes. Oh, it's Brett. It's actually hi, Brett.
Brett. Okay.
Okay, there we go.
Okay.
This is caught in the act.
This would have been a pretty good thing to have done at the beginning, so we could identify which one was which.
Yeah.
Well, and we'll never know what the other one's names are, unfortunately.
So the one in the middle is Duns, I think, because he's the bad one. Bad.
Here we go. I guess he's good with being interrupted here. So there goes there was the headset move that they were talking about.
Yeah.
All right.
There you go. It's like it didn't care. It didn't care.
It didn't care at all.
Well, it looked as if
there
it
it goes
held
again.
its right arm.
Yeah. Interesting.
Hang on, let me just see.
Had a bit of delay actually, but then I came back.
Yeah. It's so hard to rewind because it's such a long stream.
Oops.
Here we go.
You're never going to be able to get it just precisely right.
Damn it.
You need to put it on like double speed. Just have it like race through.
Okay, there we go. Watch its right arm, okay? Because I think it notices Brett coming in on the right, and then it stops moving its right arm.
Actually, it's just do something aimlessly. You see?
Oh yeah, I think it is. I think it's trying to. You're right. It was probably trying to avoid hitting him. So that's actually good. That means it had like a kind of vulnerable, like a human in the air.
Maybe this was. Oh, Brett, don't hit me, please.
Okay, let's catch up.
Yeah. 9,000. Oh, we're getting close.
Yeah, 26 and counting.
You got half an hour. It seems to have picked up.
Yeah.
Okay.
1,300 in an hour, so half an hour should be like 650. So 10,400 should be.
Actually, we might not achieve 10,500. Let's see.
We named it Gary. I don't know this is
Wasn't it more fun if they were asking from the audience what they should be called?
It seems like
so that's what he says in the chat. Everyone was typing Gary. I don't know who is this. Someone from?
Oh, maybe. So you think like
is this someone from Figure?
No, not that I know of.
In the chat, everyone was typing Gary. That's awesome. Oh, maybe I don't know who that is. I don't know if he is. Meeks, are you in Figure? That would be cool if you were. That'd be
super cool.
Yeah.
I think if he was bigger, then he wasn't in the chat, right?
Well, no, but he may have been looking at the chat. Like I
Ah.
think, yeah, everyone was typing Gary. So, but who are the other two names? We're never going to know what the other two names are. Like they need to
come forward at the end.
Yeah, they should come and take a bow.
Yeah, they should.
What a performance.
This is like what's that John Cage music 433 where it's just they sit there quietly for 4 minutes. 33. This is like 8 hours. The new John Cage symphony, 8 hours. Just a bot. Come on, bot. Come on, bot. You can do it. You can do it. Oh, come
almost there.
No.
He came up and said, enough.
He must have a little timer in his head that's kind of like, I got to get this thing on the road. If it doesn't go in time, it's too bad. Wow. I think it's getting tired. It's missing a few boxes here.
What's happening? Where?
Yeah, I wouldn't blame it.
Gary's
I'm feeling bad for it, actually.
Larry.
Can you imagine how mind-numbing this is if a human were to do it?
I was
how
talking about
mind-numbing.
Okay, so Meeks was not part of it. I was talking to my wife at dinner, and she was like, if I could do that job 8 hours a day and make $100,000, I would absolutely do it. And I was like, not me. I would run screaming from the room after 5 hours.
Okay, so Meeks
We've
said,
been watching it for 8 hours.
Not at Figure. It's got it on the live stream at the same time. Okay,
cool. All right.
I mean, again, you can listen to Beyond the Horizon podcast and then do this job. Why not?
Yes.
Over the Horizon, yes.
That's right. That's right.
Oh,
Just put the
sorry.
Don't go to that one.
So there we go.
Biggest.
Come on, Gary. Come on, Gary. Come on, Gary.
You
There
can
we
do
go.
it.
Yeah. I want to get to 10,000, 10,000, 10,000.
Oh, yeah, I think it'll cross 10,000.
Oh, yeah. But no, but we got to count down. I mean,
Okay, so
worthwhile.
just to be sure, does the counter work for only the packages that are sorted correctly?
I counted one that it missed and it counted. So
Okay.
So
and also in the audience, is there anyone who has done this job as a part-time job or something? I'm really curious to see, is there anything in this job that might be a bit different than how the robot is doing it?
I think there was an audience member earlier that mentioned, and that audience member pointed out that all the labels are very precise and accurate, which is not the case in real life.
So a lot of times they're kind of messy. And, yeah, that's interesting.
Okay, but I think we were about 5 minutes behind. Let me just try and catch up.
Oh, no. Okay. Oh, he's really close now.
Yeah.
All right.
So what is the next demo we're expecting from these guys or from someone else?
Yeah.
Do we have any ideas? But I mean, there's one thing what we want to see, but what do we expect to see? Is it locomotion, or is it manual dexterity, or just robustness?
Local manipulation, both of them at the same time.
Yeah. You think they'll manage this year? Like running and juggling at the same time?
It's very compute heavy and power heavy, so I don't know.
Yeah. I did see someone suggest on X, and I hope they do take it up, the idea of just doing the live stream with the bedroom.
Yes. That'd be cool.
Now, there's a couple ways they could do it. One is, again, they have one set of bots that messes the room up and the other set that kind of comes in and redoes it again and again. Or you have humans running in and out, but then that's then the bots are getting a little bit of break. Or you have two bedrooms and the bots are just going from one to the next and one to the next. And meanwhile, the humans are going on.
Jeez.
I think that's the ultimate test. Humans. Because that's also human bot interaction, right? That's another layer.
Right.
That's the ultimate layer, right?
Mm-hmm.
Yeah, I think so.
Yeah.
So I mean, I think what they should do is just have them clean up their office space. Why not? That seems like the most reasonable thing to do, is where they're when they have their meetings and stuff, there's clearly going to be a mess afterwards and they can come in and clean it. So that would be useful.
And again, human robot interaction would be very interesting to see, some sort of or human in the loop, basically.
Yes.
It's human messiness is in the loop, and then the robot is trying to collaborate with human.
All right, and we have to see 10,000. Put it up again.
It's true. Yeah. Oh, you're close. 2, 10, 9, 8, 7, 8. Okay.
Oh,
Delays.
okay. Come on.
It's not a New
Power
Year's.
outage. Power outage. Power outage. Come on. Come on.
Power outage.
No. Almost there. March of the 9th. 10,000.
Look at us. Stop counting. Oh, darn it. I thought the counter was frozen at that point.
No such luck. No such luck.
Yeah, but I'm still the closest. I might be a little bit under, but
Yeah, I
closer
don't
than anyone else, right?
Yeah, I think
500s.
What 1,300 divided by 4? 250 plus.
well, you know what? This is at least this is a lot more fun than watching paint dry.
I might beat you guys, but I'm pretty sure an audience member.
We have a
Oh! Wait! Here comes. Hello, I'm.
Oh, hey.
So we're gonna lose 30 seconds.
So
Gary's
someone
about
just
to
told
get
me leave.
replaced. Whoa, this is
Okay.
exciting. Wow, big finish. They're doing a big finish here.
Do you think they'll be together?
Take your time. Take your time. Come on. Take your time there. Take your time.
All right, whoever Gary's being replaced by.
It's a long
Larry,
name, it looks
Barry.
like.
Yeah, it looks like it.
Okay.
All right, come on.
Take your
let's
sweet
see.
time there. That's fine.
Frank.
Is it Frank?
What is
I
it?
think it's Frank.
It's
Frank?
Frank and Gary.
Oh, Frank, you can do it. 250 minutes.
Okay. Readjust. I think you need to do another reset. There you go.
Oh no,
all
it's the
right,
bad
all right,
one.
all
It's the middle.
right.
It's the middle child.
Okay, I think from now on, Figure has to like name all of their bots if they're doing these things so that we know what to call them. This is great.
Okay, is there some sort of cultural reference to Gary Frank?
I have
Gary
no
Frank
idea.
and
Frank Gary.
I have a feeling it was just Galactic Marine says, bro, he just did an 8-hour shift. Give him a break. Like, Frank just tossed that. It's
keep grabbing. Okay.
But again, this is the lame one.
Goodness.
Sorry, man.
He's not the good one. He's not the good child.
No. Aggressive.
Yeah.
Yeah. I think he's trying to catch up.
It's fine. Just throw it. It's
Mick says it's beautiful. Bye, Gary. You got some more numbers coming in. 10,367.
yeah,
All right.
Numbers
Rob
dropping.
said 366, so I think that's about right. But that was half an hour ago. So. I still think Frank's gonna have a meltdown.
What do you think is going to happen at the end of the shift? That's going to be interesting.
Maybe
Oh,
we'll
yeah,
go
you never
for
know if they're
60
gonna
hours.
celebrate.
Yes,
Oh.
it's going and going and going.
Jeez.
Okay, there's someone from X commented saying Frank has different finger dexterity abilities.
Oh, interesting.
Does he? Do you think he's the new
Tell
hand?
us more. What did you spot, X? Or Mr. E on X?
Yeah, definitely.
Or
Does he have
Miss
different
E?
gloves? The hands do look a little bit different in some ways, but I'm not 100% sure.
Yeah.
He's a bit different.
PID controllers being reset here. He's a
I was
special.
talking about those hands, and that it seemed to me that they weren't really available for all of them yet, that it was still kind of in a prototype phase. Do we see any abduction going on here?
I don't think so.
Oh, it's the
He
same.
does seem to be blasting through, picking up those packets. He seems better.
He's much more aggressive. That's for sure.
He's much better with the packages. It's
Yeah.
almost like
Well,
the hands
he's-
are better.
He's all charged up,
Watching all
literally.
night, so.
Yeah, he is.
This is the guy who did least work.
It's
Of it.
quantity over quality.
Exactly. He just got charged up. He's starting his shift. He's excited. He's ready to roll. Wow. Go, Frank.
Well,
Go.
we're almost
Go,
at
Frank, go.
1100. So
Oh, too much, Frank.
we still have time.
No. Not
Come on,
as
slow down.
You know, we should there should be a 1.5 penalty for everyone he missed. So whatever that
yes.
is. Has anybody counted? Somebody surely has been counting all day, right?
Yeah.
How many packages you didn't do right?
Galactic Marine says he had his
He had his
coffee.
coffee.
Yeah, exactly.
Oh, wait. Does he figure out? Oh, that was an interesting. Man, the finger strength to do that one.
Gosh, he is definitely quantity over quality. They definitely seems to have a different personality there.
Oh yeah, for
It's
sure.
crazy. Wow, it's really weird.
Frank is cranking it out.
Yep.
Yeah.
And we'll never know who the last
Yeah.
one is.
He says, where is the bot that takes the packages from the end of the line back to the beginning? That's what I want to see. Yeah. You and us.
Exactly.
I think it's
Yeah.
on a conveyor belt that just goes back around. And
Yeah,
dumps
I
it
think we
again.
see it in the reflection.
You can
of-
see it. You can see it once in a while. A package goes up. like,
Yeah,
right in the
yeah.
foreground. So nothing as interesting as that. It's just very boring. But it is Sisyphus. I mean, there's no chance he can never complete his task. I guess if he starts, if he learned to throw them off the conveyor belt, then he could actually be finished. He just throw them all on the ground and he'd be done.
He figures out the hack.
Paul says he can't wait for a cigarette
Oh
break.
man, just like all those AI games where they figured out how to cheat, right?
I know, right?
The hide and
If he
seek
figures
and
out
all that
reward
stuff.
hacking, he's going to be throwing those things right off the conveyor belt. We
10
should probably
minutes to
not give
go.
him, wow. He's what? I mean, at this rate, he's going fast. He might make what, 300? 10,300?
Yeah, 10,300 something. 350, 360.
Come on, flip it. There we go.
So that's going to
Yes.
Oh, okay. Now we've got a pile coming in. Is this going to mess them up? The yellow ones are a little bit hard, I think, to be able to.
I think
he
it
gets
seems
that
like his
right.
vision.
Yeah,
One
I mean,
thing
the
is
contrast
this-
in that is hard. I can't even tell whether he gets it right.
Yeah.
Is that Frank is using both hands, sometimes actually managing.
What's happening?
Oh,
Hey, guitar.
Okay, now does he
This
figure out?
part is tricky, right, Scott? There are like a lot of boxes coming after each other. Let's
Oh
see
yeah,
how-
it's gonna be
Yeah.
interesting to see what that's gonna be like. Oh yeah, it's gonna.
Thanks.
Yeah, lots of boxes because it takes a lot longer with the boxes.
Mm.
Yeah.
All right, slowing him down. All right, slowing him down.
Yep.
Ooh.
Oh, okay. How do you get that right?
Flip it.
Oh, you get.
Flip it.
Does he?
Ah,
you
not
got
bad.
You got it right. Uh-huh.
Back to the.
Hands are getting broken in there.
Yeah.
Oh, we don't know if that one. was
Whatever. Not sure if you checked actually all 5 sides.
Flip it. There you go.
we're all coaching him.
8 times 23, 160
Yep. No
plus.
kibitzing.
That's right.
180.
There we go.
Yeah, I'm not even sure actually if they will reach 10,300.
Oh yeah, it will. It does 23 per minute.
Gustav has put some serious money on this. He's like, oh yeah, it will.
I sold all my. My
don't
It's
say it.
non-linear, Gustav. We cannot say that.
Yeah, I might just want to catch up and say to hell with it. I'm just taking the whole bunch and letting it go down.
Yeah, I could just like shove it all down there. That's true. That's a good hack too. Is just shove it all down. Oh man.
Oh boy, look at us grown ass adults.
Oh, nice. That was actually pretty good.
Yeah.
With the help of the conveyor belts also.
I don't know.
Oh, that one.
That counts. That counts.
It
kind of counts.
It's a half.
JDK says he's going to make 367. So
yeah,
so we'll see. We will see. That's 200 more. That's a lot. I don't know if he's going to be able to do that in 7 minutes.
7 minutes?
Yeah, I don't think so.
23 times 7. What's that? 23.
So what are they going to do
Actually close.
when the clock hits 8 hours? Are they just going to stop, or is someone going to?
No, I think they're going to stop the live stream because he said they're running 24 hours a day.
Yeah, I don't think it's going to stop. Keep going.
Oh no! No, he flipped it over.
Yeah, the boxes must be empty.
Yeah, they're very
Yeah.
light.
Yeah.
Some plastic
Oh,
packaging.
another miss.
Now it's getting really sloppy. Doesn't even care
Yeah.
anymore.
It's like,
Yeah.
yeah, to hell with it. I got 6 minutes to go.
Let's just get this done. Oh, tricky.
Come on. Come on. Uh-oh. Uh-oh. Oh, there we
Oh,
go. Just give up on that one.
It's all gonna fall.
No.
Oh,
They flipped it too far. Wow, this guy really does seem like he's at the end of his shift. He's tired. He's like 8 hours.
Still gonna get my check.
Yeah.
We'll ever know.
They'll dock his salary by 50%.
yeah. Are they going to get a salary?
Maybe that's what he realized. I'm not even getting paid for this.
It's like, this is ridiculous.
Why do I care?
It's fun. Imagine it's a robot fight. Then we can commentate on that.
Yeah.
That's the plan, Merdad.
Boxing.
That's the plan. Yeah.
There
We're going to
we
be the
go.
official commentators for the World Robot Games.
BFC
Gustav, 6 minutes left.
6
100
Five.
to go.
3, 180.
It might get
Oh,
to
5 minutes.
367.
5 times.
I think it'll cross 300,
Yeah.
somewhere between 350 to 400.
Yeah.
Would
Three,
we-
three.
367 might be very accurate, actually.
Yeah.
What's it?
All right.
10,221.
Weren't you at 350, Gustav?
No, 330 and something. Or at least that was
330.
330
Okay, great.
fix, I think it said.
I'm at 420. So I don't know how far it'll get. Probably closer to 350.
10,366 was Grok's approximation. About
Wow. It may be very, very
Tony
close.
Sara says I need 200 packages in 5 minutes to make my bet come true. What is this? Poly market?
Come on. Yeah, Poly. We'll start our own betting pool.
Yeah, we should.
Tell Frank to forget about accuracy. Just start shoving
Sorry,
packages.
Just right now, it missed 5, and it counted 3 of them at least.
I
Yeah.
think it's a bit
think
delayed. It's
all the
like counting the
packages-
ones that has
Yeah.
already passed. So
Then
I
they
think
have
this
another
box
one.
will be a bit later. So it's
What's
probably
probably happening
Soul
is-
Journey says I look away for 15 minutes and return to see the figure that figure has passed. Well, don't look away.
Yeah.
We're in the end.
It's the end game, man.
Yeah, so when it hits the scanners, I think it knocked it
that
over
was-
there. It had it right, and then again, it hit it too hard. And
Yeah.
what's interesting is if those actually had things in there, if it was heavy, it probably wouldn't fall over so easy.
Right.
yeah, it's
Unless it was off balance, like Gustav's box.
Gustav's box. Like Schrodinger's cat or Gustav's
Is there a cat in there or not? Yep.
Yeah, exactly.
What's in the box? It's actually some oculars for a microscope. Oh my God, we've been watching this for 8 minutes, Royden. I think you and me are probably the ones who've been here the most.
Yeah.
8 hours,
Yeah.
not
That's
minutes.
the lunch and everything.
Yeah. We deserve an award for this.
I think so.
Well,
want
we
one.
got our
I want
reward.
what's
We
in
got
that box.
we got Brett Adcock to spend some time with us.
Yeah, that's a
It was
pretty good
worth
reward.
it. Yeah.
That's a pretty good reward.
It was fun. Come on, you gotta speed up now. Another 50 boxes. What's that? Yeah, it's kind of 330.
Yeah, I might. I would still go for 10,321.
Come on, going low.
Wow, down to 2 minutes. He did kind of slow down there at the end. If I receive my package face up, I know it's you, Frank. That's pretty funny. That's perfect. Oh man. It's reminding me of those sometimes those Amazon drivers, and they come up and they just like throw your package at the door, and they're just racing. That was Frank. That's him.
Yeah, I think we'll pass 300.
We'll pass 300, but not by
I'm
much.
not sure we'll get 400.
No.
Uh-oh.
I mean, it's
Okay.
Crunch time.
in 1 minute.
Yeah.
Dun, dun, dun.
It's gonna be just.
Soul Journey says, I'm enjoying those figures walking in the background after their lunch
yeah.
breaks or returning from them.
Yeah, that's very cool too.
Oh, right. Ooh, last minute. Last minute. It's going to just be barely north of 300. Wow.
Stuff.
313.
Crunch time.
Quick, everybody watching, what's your bet? 40 seconds to go.
312. 312.
312. Okay.
No, I'm going to be off. It's going to be, well, actually, this box is slowing it down.
314. 314.
Slow down.
16.
Yeah, 30
316.
seconds. Okay.
Big
He's
ready.
going to have to be fast here. Oh, no.
I don't think we.
Here comes the pile.
Well,
Just-
he's already.
He's up.
Just push him. It doesn't matter. Just push him.
I hope he comes up and waves to all of us at the end. Go. Three. Oh,
Three.
Come on. Come on.
Two,
Come on.
one.
10, 3,
It's
1,
314. It's 314.
It's 314.
Hey, it's still running.
Bravo, round of
Oh my
applause.
God. Come on. Come on. Cut the stream. Cut the stream.
321. 321.
What was it at 3 hours or 8 hours? What was the number?
I don't know. I think it was 314 or 313.
Yeah, it's
It was
314,
close.
I
It might
think.
have been- it was hard to say.
Yeah.
Oh, so was there? I just went with pi.
It seems like
Yeah.
Frank is really
Yeah,
trying
there you
hard
go.
to prove himself. So
Yeah.
Right.
If they
So then
hadn't
he
swapped
says,
bots, it would have.
overtime.
Overtime.
Overtime. No, it's not overtime. It's encore.
yeah, maybe the overtime is counted for the ones that they missed.
That's right.
They missed.
They must-
Did they get paid more?
Yeah, a really steady pace. I mean,
Time and a half?
I don't know. We're going to have to start calling this Figure After Dark.
Yep. Figure out.
Oh,
There
boxes
we go.
coming in. Oh my God.
8 times 60 times 23.
Go, Frank, go. I was wondering if
Well,
Brett was
it's
going to
still
come in
going.
and shut it down. I thought maybe he would walk in and just say, like, goodbye, everybody. That's it.
He's in the
Go to
figure
bed.
5 meeting. He doesn't have time to come out.
Watching the stream. Come on, he's busy.
Yeah, that's right. He's watching us. What else is he supposed to be doing?
He's watching us, watching him.
Oh, whoa, it's so meta.
Yeah, he's watching us. He's like, oh, these guys. I'm gonna troll them.
I'm just gonna
That's
keep
at
it
8
running.
hours. Oh, I'm gonna give
I'll
them
never
9 or
stop
10.
it.
It's like,
We'll be here till tomorrow at that rate.
Yeah.
So.
I think Gary will come and say, "Hey, Frank, let's come on, man. Let's."
Yeah, come on.
It's like tap him on the shoulder. Let's go.
Let it go.
you can't leave now. Oh, man.
Frank's like, "No."
I guess we'll never know the last guy's name. That's too bad. I was kind
Yeah.
of curious to find out what his name was.
In 2
Well, maybe
hours.
that's the thing. We have to wait another 3
He
hours.
who must not be named.
He was, yeah. Oh dear.
He's going to run it for 3 more hours before the change. I know.
Just so we find out.
Oh,
do any
geez.
did any of the commenters know like what his name is? The last one? Because
No-
I guess
no
Frank
idea.
and Gary were 2 of the suggestions online. So
Oh, they were
You know.
suggested online where?
I think on the figure stream.
On the figure stream? Oh, so
Yeah.
we don't know what the third one is, huh?
No, as far as I know, maybe somebody does. Oh, Larry. So it was Gary, Larry, and Frank. Okay, there we go.
Okay. It
Makes
wasn't Larry Moe and Curly, huh?
To some extent, that might be pretty good in that case.
And we're the only ones old enough to know what was.
Yeah.
Yeah, I was like, what are these guys talking about?
What? All right.
He has no idea.
Who's Mo?
Gustav, do you even know?
The Three Stooges, of course.
Hey, all
Yeah.
right, good.
It was a game for the Amiga, the Commodore Amiga based.
Okay.
That's how I learned.
That's a very interesting connection.
Yeah, but what would be the other alternative names besides Curly?
Shemp was the other one, right?
Shemp,
Wasn't
and
there
there
the
was one
fourth?
more.
Oh gosh, I don't remember the fifth one.
That was Joe. That was Joe.
Oh,
he was at
wait.
the very end. He was at the very end.
Yeah. Okay, gotcha.
Yeah.
Was it Curly Joe or was it just Joe?
Just Joe.
Okay.
Joe.
Yeah.
Because I think it was it first Shemp, and then Shemp left, and Curly came in, and then Curly passed away, and then I think Shemp maybe died, and then they needed a replacement, and then that was Joe.
That's kind of depressing.
Someone tell him it's quitting time.
Yeah.
Speaking of classic video games, there was a good
Dinner's
one.
ready.
Fallout.
Dinner's ready.
Yeah, somebody ring the dinner bell. Tell them it's time. Tell them it's time to go.
Yeah.
Well, the sun is rising over here, so I guess it's about time to go to bed.
Oh my gosh, jeez.
Well,
It's very good that in Sweden it's a red day tomorrow, right? So
yeah.
Oh,
It's a red day. Yeah. So it's what is tomorrow?
It's Jesus Flying Day. I don't know what's called.
Oh, Christy Himmelfahrt.
It's like,
Oh yeah. Okay.
What? Super Jesus.
No. It's Ascension Day, I think.
Ascension Day. Yeah, that's right.
Of Deutsch is Christi Himmelfahrt.
yeah, it's the same as Swedish.
Yeah, something like that. And that means Friday's a bridge day. You have that one off too. The other thing is, I don't know if it's the same in Sweden, but in Germany, tomorrow would be Vatertag, or Father's Day.
Okay, no, it's
So
not.
I did find out that in Germany, Mother's Day is the same day as our Hallmark Mother's Day.
Really?
But the Father's Day is not
No
our
one
Father's
cares.
Day. It's tomorrow.
That's because Father's Day, no one cares.
Nobody. Everyone cares about Mother's Day.
Yeah,
Not this
Mother's
Mother's
Day,
Day.
yeah.
Father's
Mother's
Day,
Day.
nobody cares.
Father's Day is like a month later.
Yeah.
It's an afterthought.
because it's like they say, being mother is a full-time job, but being father is a part-time job. So
Exactly.
every 2 years they care about Father's Day.
Oh, is he going to get it right? Is he going to get it right? Oh, right.
Oh dear.
Oh, man.
Do you want to ping
Yeah.
Brett to just stop it?
No, Brett, we're tired. We're tired.
8-hour limit was weirdly exciting. Never thought I would be cheering for a box sorting robot. You and us.
Yeah, all of us. So say we all. So say we all.
All 10 of us looking at watching the live stream.
Meek says, that was fun. I have to close YouTube now and go to my real job now. Thanks for the laughs. You're very
There we
welcome.
go. That's it. Exactly.
I think I'll need to do the same.
Oh,
Yep.
no, to the bitter end, to the bitter end.
To the bitter end.
They're never going to shut it down. Somebody forgot. The person who started the live stream forgot, and it's just running.
They should have had a better ending, such as like
I know.
start fighting or something, you know?
Well, they could have. Yeah, they could have all come up and taken a bow or something. That would have been helpful.
Yeah,
Gosh.
for sure.
Frank's going to be working all night here.
Well, they started an hour early. They were supposed to start at 11 Pacific, and they started at 10.
Yeah,
And that set me scrambling. So thanks to Scott for alerting me.
Yeah.
Yeah.
But
So
now
maybe
what?
they had the time to end in an hour from now.
Maybe, yeah.
European audience.
Oh, well, it's been fun.
Yep, yes, indeed. I guess
so-
Brett outlasted us. We'll just say it's over. Yay!
It's over. It's over.
Yeah.
Oh, come on. We're probably going to be missing something exciting here. You know, they're going to be pulling the plug soon here. Come on.
Scott, you're on East Coast time. It's only 9:00 where we are.
Exactly.
It's
Oh, my
unfair.
God.
So
It's
you
4
guys
a.m.
can go to sleep. Royden, just set an alarm for half an hour to come in.
Scott and I will just sit here and
We'll
just,
just sit here.
something for the
I'm
next
not
hour.
waking up for another 8 hours. It's 4 a.m. It's past 4 a.m.
Oh my gosh.
Oh,
Poor people.
Who knows? Maybe it's just on the loop as the conveyor belt is. So, and we are just.
we're seeing the beginning again. We don't realize.
Exactly.
Oh god. You
Looping
bastards. You looped it. They looped it.
That's true.
Yeah, but you're right, John. It would have been nice if they had something planned for the end.
Right. Or
the
just
end of
if
the
somebody
shift.
had come out and like just wave to us and say goodbye.
Yeah.
I don't know. I assume there's still probably quite a few people who are watching this. So
1,000.
Has
I don't know,
Brett
check
has
the
Brett said
figure
anything?
page. Did Brett or anyone announce anything that due to popular demand we're keeping another hour or
We're
something?
extending it.
He'll just
Hang on,
come
let me
in and
just
say,
check.
"Oh, you're still here."
1.5 million people are watching. So
Oh, okay.
Well,
Here we go.
I wouldn't stop if 1.5 million people.
This is what he
watching.
says. Figure just live streamed 8 hours of fully autonomous supervised work. We just huddled internally, and guess what? We're not stopping there. 24/7 live stream. Oh no!
The show goes on. Oh no!
Okay,
Oh, good Lord.
wait. We have to bow to Brett because he beat us.
Yes, indeed.
20.
Everybody
Wait a minute.
fuck
Wait a
you,
minute.
yes.
This is now turned into the Truebot show.
It is the
Yes,
oh,
The Truebot
yes. Oh my
It
gosh,
is-
I can't believe
Okay.
believe he's going 24/7.
By the way, I think Scott had a hand in that because he, when we were brainstorming it. Actually, he was suggesting ideas for branding. He's like, let's make this a Truebot show.
Yes, exactly.
Did you know, Scott?
I didn't know anything.
He's hiding his eyes. He's lying.
Oh boy. And it's going. Just as he said. This is the Truebot show indeed. Well, it's been fun.
That was fun, but I definitely am glad that he said something because otherwise we could have been.
We're just, are they doing something?
Wait a minute. I'm seeing
Oh,
Bob, Frank, and Gary.
Bob,
It's
Frank,
not
and Gary.
Larry.
Yeah. Yeah. Yep.
What's that?
YouTube traffic is now spiking from all robot names. Okay. Poor film crew.
Yes, exactly.
This is too funny. Oh my gosh. How many? I mean, we're looking at like 26,000 views for the naming one and 4,000 views for oh my gosh, this is hysterical. Figure wins. Figure wins. We can't win.
Yeah.
Wow. Well,
and it's kind of satisfying everybody's prediction about like now 10,500. So
yeah. No, I was actually kind of okay. So
everybody wins.
Let's say 12 hours from now, by like 12 hours from now, how many packages?
In another 4 hours, that mean? Yeah.
Yes. Everyone's surprisingly addictive to watch. Jeez. I mean, this is you're gonna start going to
If Frank is handling these packages, I don't think if they will come back in a good shape later.
Yeah, exactly.
Yes, but when we go to a sports bar now, is like one of them going to just be the Figure live stream next to the Red Sox game? It's like, and the Lakers game. Are the Lakers still? I'm not even following that anymore.
Our world has just changed.
Yeah. Yeah. So
it's a brave new world.
Okay. So you guys can go to bed.
Yes, I will. See you guys.
Yeah, I will for sure.
Okay.
Thank you, everyone. John, Scott,
yeah, absolutely. Thank you.
Gustav,
that was fun.
Phil Truby, and Marwa, and Devong.
And
have I missed anyone? Oh yes, I have. Brett Adcock. Thank you.
Oh yeah, of course. Yeah,
of course.
just a little guy.
Just a little.
Just a little bit. Yeah. Okay.
Does he have an example?
All right, folks. That's about it for this live stream. Thank you so much for tuning in. Listen, if you liked what we saw as much as we liked showing it to you, like, subscribe, follow us, because Scott is going to be up to a lot more mischief. And I can bet that you're going to see a lot more of this. Thank you
That's
for
never
tuning in.
The next one. Yeah.
It's been real. Thank you. And good night.
Everyone, bye-bye.
Good night.